What does this mean? I will read a little bit on the text. So what is the definition? A non-public network, NPN, is either a standalone non-public network, SNPN, that is operated by a non-public network operator and not relying on a network functions provided by PLMN, public land mobile network, or it's a public network integrated NPN, that is a non-public network deployed with the support of a PLMN. So it's a standalone. Now, both, as you will see on the note, they can share an NG-RAN. If we have some time, I will try to show you what is actually the capabilities, what NG-RAN, next generation radio access network, provides when it comes to so-called unlicensed spectrum that provides unexpected capabilities. As you see, a little bit of further elaboration over there at the end, what is a standalone non-public network, and it is very much an architecture with the 5G core with untrusted non-3GPP access. You can see the figures to the right, and it is actually, as you will see, it is trusted non-3GPP access and untrusted 3GPP access. Now, what also you have here on the top is credential holders, CH. It's an abbreviation about the authentication and authorization for an access to such a standalone non-public network. Now, as you will see in this specification of 3GPP, that is release 17, this is from December 2021, this is referring only to an access that is defined by 3GPP. Now, in a few slides, I will show you also a little bit what is coming in the future so that you have an understanding. What does this mean, actually? This is just in general about identifiers. So how do you just be aware that each and one of these non-public network or standalone public network has an ID that is defined. Yeah, I think we don't have to go through the text. Just keep in mind that all they have an ID on that. Another part here is now with this latest release, 17, what is included? What type of 5G features and functionalities are actually not supported in this solution? Starting from the top, first, interworking with EPC, Vault Packet System, is not supported for these standalone non-public networks. Emergency services are not supported. Roaming is not supported. Now, interestingly, I will show you certain interconnections between these SMPNs as a home and visited, because AT&T today, they announced that they actually will provide some roaming. Number 4, handover between these SMPNs is also not supported. Number 5, cellular IoT is not supported. CAG, closed access group, is not supported. This is primarily for some also as number 2, emergency services, but also for some kind of a specific configurations. As you will see that, there can be a user equipment with 2 or more subscriptions, with one of them can be or more network subscriptions, maybe subscribed to either this standalone or can be, for multi user equipments can be actually defined. But when it comes to the PEI, that's a part of the EMEI, how you define a terminal or user equipment. Yeah, you should be, there is a number that is pre-configured for this that is actually limited, and it may not exceed certain number for the configurations. Now, this is a very, in my opinion, very important table, because it shows for these non-public networks, standalone non-public networks, it shows 6 different configurations. As you will see, starting from number 1, this is credentials that are owned by an entity that is separate from this non-public or standalone non-public network. So there can be an external party that actually can provide an identity for registration and onboarding. The second one is, as you see, this is one of the 3 architectures for enabling services on the 5G network. That is VIAPA for video, imaging, and audio for professional applications. The third one is for the IMS. And the fourth one is onboarding of the user equipment and remote provisioning. Now, if you look, before I go to number 5 and number 6, if you look with the access, now it's interesting, in my opinion, what I would like to share with you is that for these 1 to 4, if you see, there are 56 different solutions. Now, there isn't one single solution that is actually covering all 4. So that's, in a way, depending on what type of configuration and what type of service you will be using, that will be applicable for that. Now, going to number 5 and number 6, as you will see, these columns are completely empty. 0, there is nothing. The explanation for this is they, 3GPP, they couldn't configure and they couldn't define this for this release. It's coming in the next release. So number 5, it's an equivalent standalone non-public network. The key term here is equivalent. What is equivalent for a network? Verizon and AT&T networks, they are equivalent. So when you can use them interchangeably as your home or as a visitor. And as you see, so what you will have, if you look here, 56. So you can suddenly, if you recall from the previous slide of what is included and what is not included, roaming and handover was not included. But here now, when you have equivalent standalone non-public networks, you may have a handover as well as roaming, very much as you have today between the mobile network operators. And as you see as number 6, there will be a for non-3GPP access, Wi-Fi, Bluetooth. Now, think for a while how this may impact the edge. Suddenly, you will have multiple networks that will be interacting very much as you have today the interaction of the mobile network operators. These specifications, I mean, I have some of these parts. I have chosen not to show anything, but part of this is coming now in June, July. So just a little bit that I focused on that. A little bit on now coming at CMEC hackathon. This is a little bit on the user equipment, the edge enabling client. And this is what you will have on the user equipment in order to interact with the network through the edge configuration server over there with edge enabling server in order to actually discover and act with edge application server. But you will not have only one client like the edge enabling client. You will have also another edge DNS client that is closely interrelated with actually edge application server. And I will show you because this actually utilizes the network edge application discovery service function and the context. And I will show this to you briefly because it will be, this is what I showed LFH tag that GSMA Open Platform Group, operator platform groups, they actually chosen the 3GPP edge architecture for developing edge applications as an end-to-end solution for providing edge applications. And this is part of it. So for the hackathon, we will see whether or to what an extent ETSI-MEC has come with the adoption of actually these recommendations for further evolvement or enhancement of the ETSI-MEC architecture, because this is still in the 3GPP. Another client will be also fused location client. This is actually for fusing both the 3GPP, the network location, and the so-called the terminal SUPO location. I will not go into details into that. You have to have different platforms for this. Another very important client on the user equipment is, as you see, network slice capability enablement client. And I will show you, very much like in the previous 6 categories and configurations with the 56 solutions, I will show you similar configuration for network slicing with 3 different categories and 13 different solutions. Actually, very much using different type of radio access technologies, different frequencies based on subscription and coverage and regions, just to give you an idea. And another client that we have to take into account for vertical application layer clients, this is the application data analytics enablement client. So this is very much with respect to, yeah, you can say throughput. This is very much about the cloud native, how much processing, computing, and networking power you may need. Why? In order to be able to provide and secure the quality of service of what is defined as a throughput and latency for the respective services. This is a little bit what I mentioned to you about the use of the context, application context transfer and application context, actually relocation. As I mentioned to you, it will be interesting to see. This is defined. This is standard defined. And this is, as you will see, using the 5G network data layer specification, where the context is actually of the application of the network function is stored in the core network, and it's separated from network functions application business logic. Now, a little bit going to this part number 2 about the market definition and what is the actually deployment of the so-called 5G private networks. This is a little bit coming from the February Global Mobile Supplier Association about the private mobile networks assessment. So the demand, as you will see, has been very much based on the 4G LTE, and now the involvement of the 5G technologies. And it's very much because of the growing amount of data, security, also the issues, the so-called digitization, and of course, these enterprise mobility requirements. Now, a little bit what they are using in this report, naturally, as you will see at the top, it is very much based on the definition that is used of the private mobile network, so NMPN, as you already have seen in the first couple of slides. Their definition also includes something that is multi-fire and the future railway. I have decided future railway specification not to share it with you, but this is also included in this offer, this report. And this is very much also including the intended for business critical or mission critical operation, like time sensitive networks, mission critical communication, and it's also including some of these non-3GPP networks. So this report has been very much prepared together, of course, with Ericsson, Huawei, and Nokia. Now, what I would like to share with you that when it comes to the parties that has been actually utilizing these non-public networks, this has been including, interestingly, in my opinion, not only the enterprises that we have been very much used to hear, but it's been educational institutions that provide mobile broadband to students. So in the future, schools, universities maybe also need to be considered as potential parties for this type of non-public networks. Private fixed wireless access networks. Who are deploying these? Communities for home and businesses. If we have time, I will show you something about the multi-access for customer premise networks with multi-access that actually can be also a potential party for these non-public networks. And the third, city or town networks. Smart cities that we have been used for very much for different IoT smart buildings, and as you see, libraries or any public places that today they're using very much Wi-Fi or wireless backhaul. Now, according to the Global Mobile Supplier Association, there are about 58 countries and territories that today has some kind of a deployed 5G or LTE private networks. Interestingly, if you see here, you have also these type of regions that are offshore locations, and even as you see, oil and gas industry rigs, as well as the ships that had been defined as a location for this type of networks. In total, by February 2022, according to Global Mobile Supplier Association, there are about 656 organizations that had been deploying LTE or 5G private mobile networks. Now, I will go a little bit in the last 6 months, what has been in the media with respect to this type of solutions. This is actually, as you see, from September 2021, about the hard lessons for private 5G. As you see on the top, very much as Doug Eng indicated about the 5G, I will read that. The market promise is overhyped, and it's very much has been related to designing, building, and managing private 5G. And it has been very hard, and it remains normal. And as they indicated, until a few months, private networks has actually been perceived to be a very quick and easy win, with a lot of revenues and enterprises, very much probably because it has been targeting these huge enterprises. Nevertheless, if you look down, the outcome is that there is a learning curve for the enterprises, and there is learning curve for everyone who is also selling these private network services. With respect to enterprises, in a couple of slides, I will share with you what is the actually feedback from Ford, primarily for these 5G private networks. So unfortunately, as you see with slightly bigger text, is that the market is moving much slower, and majority of these 5G private networks are tests and proofs. And also, the majority of these solutions are actually based on LTE. So even though they are presented and they are marketed as 5G, so this is right now LTE market. And most of these use cases are actually based on this LTE. So one suggestion, Tina, from me, with respect to, some few minutes ago on the LFH tag, when it comes to 5G super blueprint, maybe it's worthwhile to see, maybe to avoid that actually it very much like in this case, it is presented as a 5G, but in reality it's an LTE. So maybe to check the GSMA configuration and presentation on the standard specification, what you can actually call a 5G. They have indicated 7 options, and primarily in the case of the LFN 5G Super Blueprint, to check option 3. I can present about this if it will be necessary. So, as you will see, continuing on the same topic. So, I would say that most of these vertical licenses so far, unfortunately, they remain attached to proof of concepts, to POCs. So unfortunately, the early interest from industrial leaders have often been, with a vested interest in selling solutions over the top using this 5G naturally. It's lucrative because of the name. So unfortunately, as you see, the number of fully fledged deployments are very limited. So if you look at the name of the licenses, more than 50% of them are strictly speaking non-commercial. So if you recall from the previous slides, from 658, it's almost 660. So that's, 330 of these are non-commercial. So what are they? They are either research or proofs of concept, as it was mentioned. And they are provided by system integrator deployments, all of them who would like to test and showcase the 5G solutions. So is it something, a takeaway that we can take to an Akraino? So just to see how much there is a commercial deployment, how much there is a proof of concept and tests. So here is a little bit an indication when it comes to China and a little bit to Europe, to Germany. And this is also reflected in Akraino. If you look at some of the Chinese companies that we have in Akraino that actually have deployed commercial solution or commercially deployed their solution, look at their installation document. And you will see the difference between proof of concept documentation for installation and a Chinese company that has provided this in commercial network. So this is a little bit about the German market. And I would like to speed up a little bit because time is running, and I would like to go a little bit to as I mentioned, this is still about China and Europe. And as again, would like just to indicate that most of the deployments in China are sales driven. Only few of them are used to enhance the enterprise workflows and operations. So as you will see here, number 3, in Germany, most of the private networks are sold by system integrators or factory automation vendors to showcase 5G and to integrate their product offerings. So there is a criticism that, unfortunately, as you see at the bottom, no enterprise cares about whether they deploy 5G or 4G, as long as it solves their pain points. So here, I would like, as I promised to you, to share with you some information from Ford. This is actually from May last year. And this is at the Private Network Forum in, I think, in London. So as you see, what Chris White, an electrification manager for Ford's European business, has been indicated, industrialists, in fact, are pretty clueless about the industry of 5G in general. And that's what he says, shares with everyone. Our understanding was really poor at the start. We have been in this a year, working with Vodafone, and we have built up that understanding. But that understanding about industrial 5G is very poor outside the telecom world. Now, what he also says, standalone, non-standalone, all the latest 3GPP releases, there is a lack of understanding about all these things we have talked about and what they mean for enterprises. And then he adds, helping enterprises with that knowledge is really important. So what he underlines is that 5G is just a means to an end. And he is also indicating that at the bottom, as you see, 5G is just an enabler. There is no business case for 5G. Just to, slightly to elaborate, it is selected capabilities, functions, features in 5G that has certain, they are all important without any doubt, but they have only value, they have only meaning when you relate them to services, or as he indicates here, it is related to applications. Now, we are coming to third section. I have about 10 minutes, I guess. I will just now show you selected slides as examples. As I indicated to you in the beginning about what a non-public network is and what a public network integrated non-public network or standalone public network is. As you see, these are three pictures. One of them is actually showing you the interaction of the communication between these standalone non-public network core network together with the public LAN mobile network core network. Which one is accessing the other? That's the only difference. And at the bottom, you have an example of this multi-access PDU session, but with this ATSS for actually that provides some capabilities. I can go into details with the service function chaining, but I will prefer to show you some enhancement with respect to that, where actually you are using this to be able to do access to without having actually a connection between the LTE and 5G SBA core networks, but using this enhancement, you still can actually the users that are registered with both 4G or LTE and 5G actually can use the services from the both networks. An important slide is very much because it shows how do you get a user equipment onboarding the standalone non-public network with a default configuration server, as you see to the right, and there have been two different configurations. This is one of them. As you will see also here, it's an indication, as I mentioned to you, about visitor and home standalone non-public network. This is a little bit to number 5 for these configurations, when you will have actually communication between equivalent networks of these standalone non-public networks. This is just an example of the standard specification. I will go a little bit quickly, as you will see to the right, very much as I indicated to you, this PNI public network integrated non-public network with respect to the provisioning. As you will see, there will be a new to the top here with red OEMF. This is onboarding information management function. This is how you actually a particular function on the core network, as you will see with the SPI, SBA, that actually will handle this onboarding of both user equipment as well as of the networks. A little bit just to show you about, again, on handling subscriptions on this. This is a little bit about the so-called dual radio, and a little bit that I mentioned to you about NGRAN, and this is also, I will share with you the importance when it comes to slicing. This is a little bit as I showed to you on the category, I guess, 3 with respect to IMS, with the support, again, onboarding. This is a little bit what I would like to share with you on the right side, again, with the provisioning, that you will have alternatives for local provisioning server and a central provisioning server. Now consider if this will be a series of chain of, for instance, food chains or stores that actually you can have a provisioning, or I mean pharmacies, anything. Imagine that you can have a local presence and then you can have a central presence, and this is with respect to the provisioning of the users. It's a one option. This is again about this onboarding provisioning function alternative. This is about the selection of subscriptions that you have of different users for different networks. This is again the downlink and uplink, the dual radio. This is a little bit, as I promised to you, with respect to what AT&T has published today on the interaction and roaming of these 5G private networks. As you will see, here is a configuration, as you will see, between, you see, standalone non-public network 1, standalone non-public network 2, and there is a home service provider, and there is the interaction of the load with respect to the communication of the respective service, and then how you actually with mobility moving. So this is part of already defined specifications that AT&T most likely will implement with respect to these service providers for different services. Again, this is again the interaction of the mobility of the user equipment between different configurations. Another slide very much on the PDU. This is also about the selection of these standalone non-public networks. Again, the PDU session, very much that we are used to. A little bit more details on this. This is that we already have seen, but I guess that now, yes, bear with me just a couple of seconds, minutes, 5 minutes, I guess. What I would like to share with you, this is about these non-public networks. But here we have, for slicing that I promised to you, that I also will share with you with some services. As you see, there are 3 different categories, and there are 13 different use cases or configurations. The first one is when you have a slice that is actually defined with respect to the frequency bands, sub-bands, radio access technologies, geographical areas. The second one is actually when you have a slices that are actually defined with respect to subscription. I will show you now in the couple of slides. What does actually mean? What does the subscription to multiple network slices means also with respect to different frequencies, use and sub-bands and radio access technology? And the third one is the priority. Now, this is the same configuration, but for industrial IoTs. I have not included the defined for industrial IoTs and factories of the future process motion control from process automation and motion control for discrete automation, but it's definitely applicable. So these were the different clients on the user equipment for these particular services. But this is also something else that 5G is also now providing. It's a unified access. As you will see, this is a configuration of the user equipment depending on the access or depending on the category. So just to show it to you, this is something about a traffic classifier with respect to the service function chaining so that you can provide and assure service continuity. Here you have actually a pretty clearly defined actually specification how this is. Just to show you a little bit, this is from 2019 with regard to what 3GPP has envisioned and planned for industrial IoT and ultra reliable low latency communication. As you will see, adding 5G new radio capabilities for full wired Ethernet replacement in factories, primarily time sensitive networking, etc. And then the second is 5G new radio operation in unlicensed bands, as you will see here, including both license-assisted access as well as a standalone unlicensed operation. This is a little bit an information how this new radio covers, but to the right, as you will see, this is about this non-3GPP access that actually new radio also is designed to support. So this is a little bit, do you recall this slide here? Number 6, support for non-3GPP access for non-public networks. This is already specified, and this is with respect to the Wi-Fi, as you will see. Now, this is something that I would like to share with you, as you will see, with respect to these different services, time-sensitive networks, ultra-reliable, low-latency communication. You can have something that is a supplementary uplink or the supplementary downlink, so that you actually can have either 2 uplinks or 1 downlink, but that's depending. And as you see here, it is the new radio frequency in the unlicensed spectrum that actually you can use. This is about the slicing. I'm finishing. As you will see, this is depending, as I indicated to you. Yes.
Tina's trying to break in for a second.
Yeah, sure. Because today's agenda is packed. So thank you for your flexibility to, what's that? Oh, so Winhui said their team can share with you for another, you can go on for another 5 minutes. Then there was that at 9:50.
Maximum 5 minutes. You
Okay.
see, this is what I wanted to share with you. You see, this is how we use dynamic spectrum sharing, round trip time, frequency division duplex. This is how you actually can use these new radio frequencies. And do you see down here, this is the application preferred network slice for Rama and Krishna during evenings. This is off working hours. But during the working hours, you can use the VPN. And even if you're working from home or office, or if you're now in the Hannah's Coffee, and you, Tina, and Jeff, and Doug, you are, for instance, corporate users. So now, despite that you're in Hannah Coffee, because you're corporate users, you can automatically be assigned to a slice that is assuring you about the latency and the throughput with respect by giving you a tunnel and VPN. This is here that I would like to show to you. That is the performance requirements for airborne base station for non-public network. And as you see, here is the data rate for uplink and downlink. One thing that, yeah, I would think I will stop. This is about these localized services that actually can enable you here, as you see, by using this AT access traffic steering, switching, and splitting enhancement. You can actually also use the service provider without having a connection between the networks. And this is a little bit a specification indication of how this can be used. Here it is a little bit, on this. Well, I think I will stop here. Maybe if you have any questions or anything, maybe for 1 minute or.
Hey,
yes.
Doug, I have a quick question, I think.
Hi, Doug. Yes.
Thank you for this. I think you probably packed a week's worth of conversation into
True.
less than an hour, so I do appreciate that. Maybe I missed it, but do you have any N9 examples where it's sort of this partial local breakout, partial centralized UPF use cases? Are you seeing that as part of sort of the non-public network examples or designs?
Well, that's a little bit tricky question. This is depending a little bit, we have to reverse it. You and I, we are trained and we build up, we're building up the networks. But now, you know that all the profile, you're using the SMF to get all the UPF profiles, and there, in the NRF, it depends on the consumer or depending on the, producer. So it depends when you turn on your phone or you start using the application, because then you're getting the FQDN, frequently qualified domain name, with your DNN and DNS. And then you have the PDR with the quality of service. And then you're interacting with the OSF and going to the NRF, and actually you are getting the assigned which UPF you will use, because you recall the service session continuity, and then you can use from the application functions. But I had something that I wanted to share with you that was very critical. Let me see if I can find it, because you have on this service session continuity that you can go to the local NEF. Here, information elements contained in the application function request. You see here applicability for PCF or NF. Now, you see what is mandatory, and this is for the Edge application server and the here that you have. Now, it is for NEF. This is very much defined in the PCF. It is not so much that you can have a local NEF, as you see. It is, as you see, it's not applicable when it is only to NF. So unfortunately, Doug, you need to have an insight into the core network and in the PCF, and how it is actually defined. And then actually now they're working on something called service-based management architecture, and how you actually, you will, on the application layer, you will manage the subscription and service category. And
Okay, all right, sorry. Thank you for that. I mean, we'll probably have to take this offline because I know we're over time yet again. So I drug you off the line, off topic. So thank you for.
But you're absolutely on the right spot to ask, because you're asking the right question. You're absolutely right. That's very, 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 very good question. And you need a person who has an end-to-end with an insight, starting from the user equipment, subscription, core network, then transport network with the EAB and conditional handover with this donor, and child. And then you have to have to the new radio. And then on the application layer, and then on this context, the network data layer 4, and then the 3 architecture for services. The architecture for enabling Edge, the SEAL, and the VIAPA.
All right, no, thank you. We're gonna have to transition to the next topic. But
sorry,
you're awesome.
But very good question, Doug. Very good question.
Yeah. Okay. Cool. Let's introduce the next speaker.
Thank you.
Thank you.
Thanks, Ike.
Thank you.
Wenpei from ByteDance and Chini from Open-Minded. Like who? Open-Minded. Okay, I was saying Open-Minded. Sorry about that, Chini. Yeah, my pronunciation too early. I need coffee. Okay. All right. So.
Yeah. Hi.
And you want to use this if you want, or you can use yours.
Yeah, I just muted.
No, if I
To
do.
avoid echoing. Yeah.
Okay.
Yes. So today's presentation is about privacy preserving technologies and open source projects, and the challenges and opportunities to push all these new technologies into production. So the presenter is me and Chimney. Chimney is actually the tech lead of OpenMind.org, which is a super large organization, like across different countries, for focusing on the federated learning algorithms. So privacy preserving technologies is for this project. So in this presentation, we will firstly review the current privacy preserving technologies. And then for each one of the privacy preserving technologies, we summarize the popular open source projects for you to select from. And hopefully that will be embedded into, like donated into the Akraino Edge stack afterwards. And we review both the progress of the current and in progress standards and regulations and law in regulation these technologies. So like Tina and other people could select the best performed framework, open source frameworks and code to be integrated. And then afterwards we discuss the challenges and opportunities if any like industry people wants to pull from Akraino code and test it out, and what are the challenges there if they want to push it into production, and what has to be considered. So if there are some sensitive issues to be considered while doing that. So there was a report by Gartner that by 2025, 60 of the large organizations will use one or more of the privacy enhancing computation techniques in analytics, such as in Google Maps, and also in the Twitter's headlines or the ByteDance or TikTok's headlines. So these are for the business, not only for business intelligence, but also for cloud computing as well. But what is like federated learning, and what are the privacy goals for federated learning? So the goals for like the target consumers for federated learning are like people or industries who are doing statistics and machine learning on top of the data which they got from the different entities. And they want to preserve like the data from data leak, and also constrain the sensitive data while they are providing the right statistics results or prediction results. So there are currently some like 9 most popular open source frameworks for federated learning. The most comprehensive one with the most technologies like embedded is called WeBank FinTech. And the most influential one, however, is the number 7, which is called PyShift OpenMind. It has like inspired for most of the research works and most of the use cases. And actually, PyShift actually inspired Google with TensorFlow federated for the federated learning on the neural networks. There are also some tech leaders which actually provided open source frameworks for federated learning. For example, AI Labs from Taiwan, ByteDance, Intel, Baidu, and also Jingdong. They also have some open source works here, which are very popular and tested by many people. So what are the technologies involved in these frameworks? So for privacy preserving techniques actually allows sharing sensitive information. So below other technologies that are used in federated learning, I put them in a way like the constraint from 1 to 6, the constraint level and the privacy preserving level is from low to high. Sorry. Oh, sorry. Where was my code? Could you? I don't know. From low to high. So the first one is anonymization, which is the weakest to preserve privacy preserving technologies. And then afterwards, we have differential privacy, means like when we categorize the people categorize a lot of people. We want to preserve the privacy on a group of data instead of on a single data. And then we have full homomorphic encryption. Afterwards, we have we'll discuss about zero knowledge proof, and then the framework of how to build secure multi-party computation on top of zero knowledge proof and full homomorphic encryption. And then we'll introduce the current status of art, which are actually the strongest preserving for integrities and confidentialities for data, which is a hardware-based technology. It's called confidential computing through the trusted execution environment. The current status is STX from Intel and STX2 from Intel are very mature, and the Trustron from ARM is very mature, but they are for application-based privacy preserving. And Intel is going to release the next generation which called TDX, and ARM is going to release the next generation CCA for VM-based privacy preserving, which will actually enable the privacy preserving technology to be applied to a large amount of data afterwards, and that will be more applicable to the cloud. So let's take a look at the federated learning stack. So on the federated learning stack, we have two groups of entities. One is a client group entity, the other one is a server entity. The client will provide their personal data, their client's data, and then the server will aggregate the data and do the machine learning and the statistics and give out the prediction result from there. So the client, what they do is they do the anonymization, like de-identification and diversity algorithms on top of it, and de-anonymize the data. After they de-anonymize the data, they send the data to the server, and the server will aggregate different data or different databases, and performing differential privacy on top of the databases to preserve the data that are actually might be some privacy data might be shown to be break while they are aggregating the data. So differential privacy is applied here. Then afterwards, the server might apply zero knowledge proof on top of the data they aggregated and perform the differential privacy on there, people through and afterwards people are struggling between whether to encrypt the data on the client side and then perform the machine learning on the full homomorphic encrypted data on the server side, or let the client encrypt the data on the memory through the hardware using trusted execution environment, which we could see on the very bottom here, which is hardware-based memory encryption instead of software-based data encryption and homomorphic encryption. So the difference is the software-based full homomorphic encryption is takes a lot of energy and computation resource and it's quite slow, while the trusted execution environment is fast developing and not so mature yet. However, when Intel Intel TDX and ARM CCA are released, it will enable more opportunities for encrypting a large memory such as the memory for the whole VMs. So all the data will be under encrypted in the encrypted memory, and the privacy and the integrity will be preserved from there. So we first dive into the first technology, anonymization. So the goal of anonymization is to anonymize the data and through the key anonymity and eye diversity, so that the data could not be associated with one individual. What does it mean by key anonymity? Key anonymity means like when we generate a data property so that the group of data it belongs to with at least a key minus one individual who have the same properties. And for the eye diversity, it means like anonymize the data for its sensitive attributes only. So like all the data could be like released while their sensitive attributes are actually masked. One way to like achieve the key anonymity and eye diversity is by adding noise to the data. By adding mathematical noise to the data as a whole, or adding noise to the data to its specific sensitive attribute field, we make it difficult to assertion whether one individual is part of a data set. After we have performed the local de-anonymization, then people will at the client side will perform a local randomization, as you could see on the second stage. So after perform the local randomization stage, the messages and data will be aggregated on the server. After as you could see, A, Y minus here is like the aggregation on the server side. So the differential privacy is like a technology is used after the aggregation and in the aggregation process. So it provides an output privacy, as you could see on the Z here, for the statistics and the databases. So there are lots of like open source projects for the differential privacy, for Akraino to select from and reach out to like integrate. So one of the most popular ones is the DeepPrive Lab, which is built and supported by IBM. It is also designed for data statistics scientists for machine learning tasks. And there is some like Uber uses SQL diff for data flow analysis and differential privacy for SQL queries, especially. And Microsoft Ping, which is an old project, it's very quite mature, and it was developed like 8 years ago. So like it's a SQL query engine with differential privacy preserved. And also the pipeline DP is a framework developed by the OpenMind based on the PySafe library. It performs like differential private data aggregation. And which library, the PySafe, actually inspired the number 2 Google TensorFlow, and the TensorFlow, which is the library for training machine learning models with privacy for training data. And also, there's another very popular set of tools, which is called OpenDP. It's defined for designed for data scientists, which includes the implementation of many of the tools we have discussed here, put it into like a different noise samples and adding noise and to preserve the privacy on the grouped data in the aggregation stage. So then we come to a technology which some people might be considered to using it, which is called fully holomorphic encryption. It actually is a crypto system which works on the calculation and machine learning on top of the encrypted data, as it is like a set of algorithms which is working on the encrypted data. So its appliance and the use cases, the machine learning algorithms to be built on top of it is quite limited actually. So it's only like a little set of machine learning techniques could be working on the encrypted data. So since like FHE does not perform computation processing in the as what is did in the TEE. TEE is like more broad, and it will support almost all every, like I should say every, all the machine learning techniques to be performed on top of it. So like and it does not support application code integrity or the code confidentiality from there. So it's like less strong than the TEE, and also the calculation set and the usability is quite limited. So that's the difference. So there are the full homomorphic encryption has been generated, like devolved in like 4 stages. Actually, it has been there for like more than 30 years. Actually, yeah, we have the pre-full homomorphic encryption, which was like first started by the RSA crypto system long time ago, which has an unbounded number of modular multiplications, and we have the some like newer ones like a 3rd generation FHE, which is developed and developed by Greg Ashmid-Shah and Brent Walter, which is building on the FIC scheme that avoids expensive relinearization. And this is the most, the GSW is the most popular one, the most like most of the open source communities like will use the GSW algorithms. And the follower ones like FHEW and TFHE and CKKS, they all based on the GSW crypto system, which is the 3rd generation of the fully homomorphic encryption. And there are lots of like open source projects for homomorphic encryption, and the differences there. Here, the Microsoft has a seal, which is very popular, and you have the Paradise, and the HTFE is very popular as well. However, these tools, they don't like include all of the algorithms that we discussed in previously. So of all the 3rd generation fully homomorphic encryption algorithms, we could see here the HE lab, it increased CKKS, which is really which is a faster process, and also the Microsoft seal. This one is widely adopted, mostly, yeah. So among all the algorithms for like open source homomorphic encryptions, like if you want like a better performance, CKKS is like mostly suggested here, and we could select the libraries to be embedded for see. These one libraries, they all have the CKKS algorithm. And then we added a section here from zero knowledge proof. So zero knowledge proof actually provides the ability to prove the honest computation without reviewing the inputs, which was started by Yao. The zero knowledge proofs has to like implement 3 properties. One is completeness, which means the statement is true and both the prover and the verifier should follow the protocol. Then the verifier will accept the proof from there. And the soundness property, which means if the statement is false and the verifier actually follows the protocol, then the verifier will not be convinced by the proof. And then the zero knowledge means if the statement is true and the prover follows the protocol, then the verifier should not learn any confidential information from the interaction with the prover, except that the statement is true. So that, which means that the honest computation without revealing the input data. So what are the use case of zero knowledge proof at edge? It is used for like a checking, for example, which is like this by some samples, which is given by the UN Handbook of Privacy Preserving Technologies. The mostly use cases like checking the taxes, which has probably paid by some company or person, and you don't want to know. You just want to know some companies if they pay the tax or not, and you don't want to relieve the individuals or the sensitive information inside the company, like what did they buy and what sensitive internal like business plans are there, like use the money, and what people did they hear to like actually did they pay the tax for the people's like humans stuff, humans like how can I say, when you hire someone then you have to pay some taxes, those ones. And by checking if a given loan is not too risky, you just need the result to know, okay, it is risky or not. And there's this knowledge, zero knowledge proofs technologies are actually implementing on the trust zone a lot. For like in our Android cell phone, and in our like whenever we are putting in our fingerprint on there, it's actually calculating in the secure OS, and the secure OS will only return you whether this fingerprint could open this cell phone or not, and without telling you, okay, what are the characters and what are the features of this person, or like the features on your fingerprint. They just return you yes or no. Then like your cell phone is authenticated. And the same thing happens with the Apple phone with a face, like with a face recognition to open it. But the Apple's one is built the zero knowledge proof on a different hardware. They have their own memory built up, while the Android is using ARM technologies for trust phone. There are some open source projects of zero knowledge proof here, which includes succinct and non-interactive arguments of knowledge, and starts, which is like a faster with C++ implementation here. And they have some like Python, Java implementation as well. So for secure multi-party computation, which was like started by Andrew Chen Yao, which was like a long time ago, like more than 30 years ago, which is called Garble circuit. It supplies these algorithms supplies a high bandwidth. However, it's high latency as well. And the most popular ones today is developed by Shar and Berkeley in 1979, called the secret sharing. It has a low computation overhead and low communication overhead. That's why people are taking this. Low computation overhead means the algorithm is not so complex. While doing the calculation, not too many like instructions had to be performed. While the low communication means like such as like in the three-way handshake or the four-way, five-way authentication, not too much like back and forth communication are there. So like that's why like secret sharing is mostly adapted in the open source community. And there's one new one is called oblivious transfer, which means like when you send n messages, the receiver only receive one of them. So like they could be also used in the private setting intersection. So like you will never know which one, the sender will never know which one receiver is received. So the sender just send out messages and receiver get one of them and authenticate from there. So that's a oblivious transfer. And there are some lots of open source projects for secure multi-party computation here. I won't like dive into this part because for secure multi-party computation, we are not suggested to use it too much in the production. I will discuss why we don't suggest it too much in the following slide and for the while we're doing the comparisons between all these technologies. And there's one new technology which is called confidential computing through the trusted execution environment. And this hardware-based memory encryption technology actually preserves both the data confidentiality and data integrity and code integrity. So the data confidentiality means that unauthorized entities could not view the data while it is in use within the TEE. And data integrity means unauthorized entities could not add, remove, or alter data while it's used within the TEE. And code integrity means unauthorized entities cannot add, remove, or alter code executions in the TEE. So the current TEEs, like most mature ones, are including the SGX and on Intel, which is built on both the desktops and Skylake CPUs on which is used in the data center. And the most widely used TEEs is called like ARM Trustron. It's on the mobile side. However, there's one almost mature ones, which is called AMD SEV SNT, and Intel is gonna to release TDX soon. We have in Q4 or Q3 this year, and ARM is gonna to release the CCA as well, so that it will be more mature for federated learning afterwards. Hopefully, it will be like a prospering market there. And since the STX is the most mature and has the most open source community here, and they see all the open source projects on the STX, from which the Grameen build is actually the Intel SDK is developed by the Intel, which is a native one, the performance the highest one. And then if you want the library OS, you could choose from Grameen, which is hosted by Intel as well, or Photonix TE, which is like with Photonix TE, because it's built on Rust, and you will have the memory protection, special memory overflow protection from there. And also there are some other popular TEs like Open Enclave as SDK and Agilis DB, which are popular as well.
So what was the one you mentioned, the coming from ARM?
CCA.
CCA.
Yeah.
So is that similar to SEV or similar to STX? Because these two are different, right? SEV is more memory encryption, VM protection. SGX is the whole computation protection, right? So this CCA, so what's which one is it's more similar?
Oh yeah, it's similar to the SEV and SNT.
Okay.
Yeah, TDX, SEV, SNT, and CCA, they are more.
They're in the same category. Okay.
In the same category, and like the VMs and the Kubernetes could be easily deployed on these three.
Okay.
While you have to rewrite the code on the STX or Trustron. So that's the difference. Yeah.
I have a question too. Why do we not hear more about homomorphic encryption? Maybe I'm just missing it, but I didn't see that mentioned much. Is that because of the computation? Because
yeah, computation.
So whoever is doing that needs to have some processing.
Yeah.
Power, right?
Yeah, as we could.
It's a lot of math, right?
Yeah, a lot of like.
It's not just the decryption; it's more than that.
Yeah, not only the decryption, but the calculations will be quite limited.
Okay.
Yeah.
Okay.
Yeah, like neural. People still don't have any idea like how to put neural networks on top of homomorphic encryption.
Okay.
Yeah.
So that's the R&D is ongoing.
Yeah.
But you said it's been around a long time.
not proved to be
Yeah, but it started many years ago.
many years ago,
So
yeah.
somebody is, it's like encryption, I guess, that's also started in the, like, public key and all that started in the 80s, really. So
Yeah,
it's been,
it has been going on for a
people
while.
recognize the benefit for many years,
Yeah,
but they just take some time to get it working.
yeah,
Like, kind of like deep learning. We had neural nets in the 1980s, but they didn't work, right? They're not deep enough.
yeah.
Okay.
Argue they still don't work. Thanks.
Well, they need to be deeper.
Yeah.
Okay.
And
well,
not
that
too
helps.
much data in
Yeah, it
back in
helps.
the
Yeah, I'm
90s.
just trying to
Yeah,
understand. I mean,
yeah,
it sounds really interesting. You can perform math operations without actually decrypting,
decrypted. Yeah,
right? But I don't see like AWS and Google, saying, hey, we've got this thing.
yeah,
They don't, maybe they do, but they're not
They're not
making a
telling
big
you.
about it,
Yeah.
making a big deal about it, right?
yeah,
Okay.
exactly. As you could see here on this diagram, the performance is quite low on when we're doing stuff on top of the data that are encrypted. And the generability is medium because some
Yeah.
of the operations could not be performed. And the security is actually high because
Right, right.
everything is
Exactly.
verified.
Yeah, exactly.
Yeah.
It feels like blockchain to me. It's like something you're
Is it?
keeping
Yeah.
it, you're having it, not only are you encrypting, but you're also having a way to further verify the
Yeah.
encryption and besides the keys and besides the encryption. So it sounds good. But I see you labeled it as its maturity as like, increasing. That sort of sounds like in progress to me.
Yeah, lots of people are still working on the research part for
Okay. Yeah.
making more applicable to
Yeah,
all the
okay.
machine learning use cases
I got
and
it.
reducing the computation and communication
older.
part. Yeah,
Well, yeah.
yeah. So that's why we put it as a not for this moment
Yeah.
for the production, but maybe it will be mature. Lots of researchers are trying to verify and prove more
Yeah,
algorithms from
Yeah,
there.
well, there's many things. I have my own personal label for these things. I call it the 30-year rule. There's many things it takes like 30 years before it hits the big time.
Yeah,
And
Yeah.
like the mRNA vaccine, deep learning, all these things, they've been working on it for a long time.
exactly. Yeah. Yeah. So we could see here something like we suggested for production, for example, the anonymization. The performance is really high, just add noise to it, add noise to the data and anonymize there to preserve the eye diversity and the identification. And the generability is really high. So for almost for all the data, you get a distribution of it and you figure out which Laplacian or what type of noise you want to add to it. So the generability is really high and the security is medium because you don't really know how much it's not verified. So there's a privacy budget from there. So based on how much noise you add, if you add more noise, then the machine learning result might not be so good.
Yeah.
But yeah, so really depends on noise level and the data. Maturity is very high for this technology. But we could do sample trainings for this technology before we use them to see, okay, what are the privacy budget we want to take from here. And the differential privacy, the performance is really high. It's like adding noise and on the aggregated data, and however, the generability is a little low, while the security is a similar and is a medium as well. Because the differential privacy has a security budget, and when we actually do the differential privacy on different databases on different data types, we have to come up with a specific differential privacy strategy. It's a very case by case. Google is not verified yet. So whether the privacy will be preserved after the differential privacy. Yeah, so that's why we did not suggest it for production, and Google has the same guideline saying like, okay, you could combine the differential privacy in your production line. However, we don't suggest you use it alone. Yeah, so that's why. Yeah, and we just discussed about that full homomorphic encryption, high computations, and the maturity is increasing. Not for production at this time, but maybe later. For the zero knowledge proof, the performance is quite low because we use lots of communications in like secure authentication protocols, and the generability is like a little low as well. But however, all the authentication protocols and these ones are actually verified, so the security is very high.
I can raise his hand.
Yeah.
Do you have a question?
Yeah, I mean, you have such a vast knowledge in this topic, and there is a topic of interest that I have. It's very difficult to get some information, and I'm just wondering if you have any update, and it's related to the Shor algorithm and quantum encryption for the security. You know, Australia, New South Wales, Microsoft, Google, IBM has a test lab providing, you know, that you can do some applications on Python. By any chance, do you have any update on that? Shor algorithm and the quantum encryption in the superposition?
For the quantum positions, like I think the Caltech is working on the research on that part, but it's still under developing. And according to what I know, from my friend, is like they are working on the algorithms like one by one, and the error correction coding part is like still limited in progress, because when we like do the encryptions on like based on the quantum computing, like right now when we work on the base level, we know exactly, okay, we have the parity check, we have the error correction, but on the quantums, it's like a phase delay based like and the encryptions on top of that, and whether how could we correct the phase difference, the phase errors, that will be quite challenging task right now. People are still working on it. If we don't know for sure if the result of the quantum computing encryption is still correct, then it's hard to, yeah.
Right. Right. That's decoherence. It's a huge issue, you know, keeping the electrons actually in parity in coherent states.
Yeah, right. Yeah.
Certainly. Thank you. Thank you so much.
Thank you. Hopefully,
the qubits, sorry, to be the right term. So thank you.
Yeah, thank you. And also we discussed about like confidential computing through the trusted execution environment, of which we need to trust the hardware providers. Right now, they have the hardware providers will provide the remote attestation both for the hardware and for the software SDKs they deliver to us. So if the customers trust ARM or Intel, and or they trust the root CA delivery people, the authorities from there, then they don't need to trust the cloud providers to perform the trusted execution, because they like the keys are like authenticated by the like hardware companies. So this part, the maturity is increasing, and they expect to mature in about 1 year, because lots of companies told us like they are going to release it soon. So it is suggested for production. So that's the our understanding on the summary part here. And there are some pushing the privacy preserving technologies into production. Probably there are some standards or regulations and laws, the system integrators and the product managers have to take into consideration while they selecting the different open source frameworks. So what are the current standards right now? Like we have to make the cloud provider has to make our framework follow the laws, the regulations, rules. So these are the 4 rules, the current standards we have to follow. One is the ISO IEC, which is focusing on the privacy architecture and framework and regulations. And ISO IEC 29101 is focusing on the European General Data Protection Regulation. While this one also it is focusing on the anomalized processing and using secure computing, which is like both multi-part regulations and multi-party computation, and also trusted computing execution for the detailed regulations. And also there's a standard called ISO IEC, which is like secure techniques on the secret sharing part. And ISO IEC 19592 developed in 2006 and 2007, both on the secret sharing part. And also our system integrators probably have to take in extra care. We'll have to consider some like standards in progress. There are some like standards in progress for homomorphic encryption, like which we should take care of, like while we are using the open source projects. We have to see, okay, if this homomorphic encryption follows the standards, or like is it verified and could match the specifications in the standards. And also there's like a homomorphic encryption standard initiative, which is under developed. And for the anonymization part, for the first stage, by adding how much noise to de-anonymize it, there's also a standard ongoing as well, which is called ISO IEC 20889. So like how much noise and what are the distributions of noise, and which field or the whole data, are we serialize the data, are we like perform the noise adding on one field on the structured data. So it is still in progress. And if we want to push the privacy preserving technologies stack in production, there might be several challenges. Firstly, is like if we are using the fully homomorphic encryption, we have to reduce the computation and communication overhead on the encrypted data. For example, the FHE will expand to 1 to 4 orders of magnitude of data after the encryption, and the calculation is like a lot more if we are not doing it on the plain text. So the bottlenecks actually lies in the node or the party which has the smallest computation resource in the federated learning part. So we have to figure out who has the smallest resource and then debug the bottlenecks from there. So, and the federated learning requires all the nodes and the parties to be online at the same time, perform collaborative and synchronized compute and communication. While some parties might be using also AWS, some parties might be using GCP, Google Cloud. So synchronizing between the cloud and synchronizing between the different parties needs a consolidated communication protocol to be performed, and also
How close in time do they need to be synchronized? Is it microseconds, nanoseconds, seconds?
Seconds.
It's seconds,
Yeah.
not anything lower.
No,
than that,
not
so-
to,
okay.
yeah.
Okay.
Yeah. But if like one entity is like trying to get a predicted result for today, and the other party, if they are still calculating it on the data yesterday, then when they aggregate the data, And this one already calculated the data for today has to wait for the other one. And one wait on the other, if you have a straggler in the cluster, in the federated learning cluster, then that will be an issue. It's just a delay, communication.
Oh, just a delay, so it
You have
stacks
to
up
wait
basically.
for other
Yeah.
people, and you have dependencies. Well,
Okay, so it's not
yeah,
synchronizing the data, it's really just a chain of events,
yeah,
and the slowest one slows the whole system down.
yeah, you're right.
Okay.
Yeah. So avoiding the straggler nodes and parties is very important. And also interconnectivity between the different nodes and parties is requires a common protocol because they are on different architectures and supported by different cloud providers. And if they are using different privacy preserving algorithms, for example, someone anomalize the data in this way and the other party anomalizes in that way, if they aggregate together, some data might be reviewed. And if one party actually do the differential privacy on one field of the data, and the other one actually reviews the data field of the same data struct, then that might be an issue. So we need a consolidated protocol where people are trying to aggregate the data. Like
Who would work on, what organization would do that?
iOS standard.
iOS would? Okay.
Yeah, IEC, they're still working on the standard.
And then that would be that'd be electronic protocol as opposed to a policy
Mostly algorithm.
algorithm. Okay.
Yeah, algorithm protocols like
Okay.
yeah.
You still have to reveal, I mean, you would have to reveal how you did it and what you
Yeah,
left open, and I would have to do the same thing. We'd have to agree on that
yeah,
communication so that the algorithm would be able to understand.
yeah. For example, you use Laplacian based, the other one use Gaussian based.
Right.
If they join together, will it invoke some issues? We don't know yet. Yeah.
Okay.
Yeah. So, and also avoiding inventing the tools like for different cloud providers, probably some agreement on sharing the open source tools as a basics.
Right.
That will be better for the collaboration. So each party don't have to reinvent.
Right.
Yeah. All right.
Where you have the same bugs.
Yeah. Yeah. And here the future works in production to get to work faster. First is like optimization on the algorithms, like decoupling the computation modules and the reorchestration of the calculation modules. And second, reduce communication overhead by reducing the communication frequency and computation data size for the synchronization part. You calculate today how chunk of data on today or on yesterday or by half a day or whatever. And also tracing and identification of resource limited node and parties. And right now we have the identification of the stragglers on inside of the AWS or GCP, but we don't have any algorithms to trace the stragglers across the different cloud providers.
Oh, I didn't.
Yeah, and also integrity preserves the tracing and logging system because it's from different entities. And also some like compiler optimizations for accelerating the algorithms in implementation and hardware accelerations like TPU, GPU, and for acceleration of the encryption technologies. And also pipeline the scheduling for the different entities is like some future works in production. And safety and security measurements for grading the federated learning platforms is needed. Actually, we don't have any gradings for like security levels, whether they match the standard or not for the federated platforms. And also automatic evaluation and standardization is still, as you could see, is still both in performance and security. It's still ongoing. And also the enhanced explanatory of the federated learning is needed. Yeah. So like, yeah.
And is there a minimum amount of data you would need in order for the security to be valid. In other words, you have a unit of one, then obviously,
Still-
even if it's fully, you put all the noise that you want, you still know it's from you.
Yeah, and it depends on the data pattern as well.
Right, so is there, each one of these algorithms must have different minimum amount of
Mhm.
information you would need in order to be the security rating would apply, I assume, right?
Yeah.
And what do you do if you don't have enough data? You just sit there and wait?
Yeah, that's a synchronization part and scheduling part.
Oh,
Whether
so
we
that-
should
okay,
scheduling,
okay.
whether we should wait or not, it's still ongoing. Yeah,
Okay,
yeah, lots of work to be done for sure,
Okay.
if we want this one to go friendly in production. So we are quite running out of time. Probably I won't explain like the example of pipeline DP OpenMine, but just there's one projects going on there. So if you have any questions, I think the tech lead Shimha is online to answer the questions like for the PySwift and pipeline DP and all the libraries, which is hosted by the OpenMine organization and what the OpenMine organization is. Shimha, are you there?
Yeah, I'm here.
Jimmy, yeah.
Yeah, I'm just curious to know, so for the release 6 or 7, how does the first release of the software stack look like? So because there's a blueprint for release 6, you have the software stack, you'll pick the specific hardware you're gonna run on it, right? So did you guys already?
Yeah, we have
Oh,
it,
I
yeah.
see. Yeah, so which hardware are you gonna run on?
We are not decided yet. It's like Ubuntu we tested already, and like anything that supports Ubuntu is either ARM or x86 works. Yeah.
Cool.
Yeah.
Yeah, so we have the LF Edge Share Lab. There are many pods and have both servers, switches, and GPUs. I guess you need GPU, right?
Yeah.
So-
No GPU at this moment.
Okay, that's good. We provided, they feel free to use that. Okay, so Mehmet, yes, you're the next. Okay, so we're on time.
Maybe.
Thank you. Mehmet, can you hear us?
Yes, I do. Yes, I do.
Go
Let
ahead.
me share my screen.
Yeah. Cloud services. Yeah.
Do you see my screen?
Yes, I do.
Okay, great. Well, I guess good morning to you folks, and some of you good afternoon and maybe good evening. And today I will talk about the cloud service architecture. And cloud services, as you know, provided by public cloud operators and also even some telecom operators. And those are, most of you know those names, as you can see, network as a service, infrastructure, and so on and so forth. And actually, there are so many of them are created. And in this diagram, basically, I try to show them that it's possible you may go, let's say, if you want to have a software as a service, you may have IaaS and PaaS in between before you go to the software as a service, which will be on top of the infrastructure as a service, network as a service, I'm sorry. But in some cases, they may go direct to the network as a service. That's how they implement it and so on and so forth. The purpose of really the cloud service architecture is those implementation are all very proprietary implementations, and the intent is to bring a standardized approach to the cloud services, so that hopefully it will be easier for the service providers, customers, as well as the vendors of the cloud services. So this is just a list of the characteristics. That doesn't mean all, but some of the characteristics of the cloud services. Number one is it combines the connectivity and applications. The services that I show you in the previous slide, most of them are, at least some of them are defined by NIST, for example. They really only include applications. So the intent of the cloud services over here, the model is it includes the connectivity as well as the applications, so that it's really it is an end-to-end service. And connectivity may include the legacy networks as well as the non-virtualized components. And of course, the applications will have virtual machines, containers, and the CNFs and VNFs. Now, the application term I use here is a little bit different than the normal application term that we use in the industry. That is I represent application, I use application term to represent virtual machines, containers, and also the CNF, VNFs, and then also the applications that really do not follow the CNFV guidance at all. And the services are provided by single or multiple operators, and customer will be able to basically scale their resources up and down and monitor and track their usages. And also the purpose over here is the collaboration between the cloud operators and also the connectivity operators, so that you can really provide the service end to end. And of course, the high availability options and also the usage-based billing are among the characteristics of the cloud services. Now, if we look at an overall diagram here, let's say I have a enterprise customer on the left side, which is a cloud subscriber, and then you have a cloud service provider, which is the large hexagon, which is the responsible entity for end-to-end, responsible entity from end-to-end performance, service assurance, and also billing. Now, the cloud service provider may or may not actually own the facilities to provide the cloud services. Now, the cloud services may contain the connectivity operators. Cloud service provider may actually have an agreement with the connectivity operators and also with the cloud operators to provide applications. So as you can see here, cloud subscriber, of course, can use the private networks to access the cloud operator applications, while also they can use the internet to do that. As an example, this is a simple example. If I have a enterprise customer with multiple locations, let's say the cloud subscriber on the left side is representing one of the offices of the enterprise customer, and let's say the other one representing the headquarters. If they want to access to internet and use the security gateway service from the cloud service provider, as you can see, they basically set up a connection and use the applications from the cloud service provider. And again, in this case, both connectivity and the cloud operators are involved in providing the service. Now, what we define is we define a demarcation point between the cloud subscriber and also the cloud service provider. And we call that demarcation point as a cloud user network interface, Cloud UNI. And similarly, we define a standard interface between the operators. It could be between the connectivity operator and the cloud operator, or it could be between the two cloud operators. We call them as a cloud ENNI, and that's again we are hoping that there will be a standard interface between, let's say, Azure and AWS or Google, or similarly if the Azure is talking to Verizon and AWS is talking to Verizon or AT&T, things like that. The Cloud UNI and the Cloud ENNI interface is a 7-layer protocol stack. As you can see on the left side, both UNI and as well as the ENNI, it's 7-layer protocol stack from layer 1 up to layer 7. And also, in my view, is I added the AML on the right side, as you can see on the top. My intent here is to show AML functionality will be actually usable or utilized in each of these layers. So really, the AML can be used from layer 1 up to layer 7. Of course, all these layers, we have data plane, control plane, and management plane functions. Now, if I am a cloud subscriber on the left side and I have a cloud service provider on the right side, I, as a user, I basically would like to connect to the application, which is the green bar on the right side, and set up a connection we call the Cloud VC. And of course, as you see those, the points at the UNI as well as on the cloud application, We call that Cloud VC endpoints. Now, this doesn't have to be point-to-point. It could be multi-point. As you can see in this diagram, if the cloud subscriber set up a multi-point cloud virtual connection, they can access to the multiple applications simultaneously. Cloud application interface, that the application that I showed you before, the interface for that is a protocol stack from layer 2 up to layer 7. Of course, there is no physical interface there, but the rest of them are the same. That is, again, AML functions on each layer, and also data plane, control plane, and management functions. Management plane functions, again, involved in each of these layers. Now, if you look at the examples of the cloud application interfaces, in the left figure on the left side, you see virtual network function is acting as an application, and you have a virtual network, the cloud application interface, represented as blue here, and the subscriber is basically setting up a connection to the VNF using the cloud virtual connection. And if you look at the right side, again, I'm using the containers or the virtual machine interface, representing the interfaces as an application interface. So, of course, the attributes will be different, but nevertheless, we represent it as a standard interface called a cloud application interface. This is showing if you have multiple operators providing the cloud services, what the really internals of that. So here I have a connectivity operator and then the cloud operator on the right side. Each of them providing the connectivity. So we divide or segment the cloud virtual connection, which I haven't shown over here. This is between the subscriber and the application. Broke that divided into two segments. The first segment is in the operator A, which called operator cloud virtual connection A, and the second segment is the operator cloud virtual connection B. And of course, the cloud operator provides both the connectivity segment as well as the application. It is also possible to have a little bit more complicated configurations. Here I have a connectivity operator, and let's say two applications, one provided by AWS and the other one is provided by Azure, and I have a multi-point connections as a subscriber, and that basically I'm simultaneously using both applications. Now, if in this case, of course, the cloud subscriber really may or may not be aware of really they are accessing to the AWS and Azure, because cloud service provider is basically responsible from all. They may hide all these details from the cloud subscriber. And this one shows if I have two cloud operators like AWS and Azure, they talk to each other through an internet, and the cloud subscriber on the left side is able to use the applications again provided by both operators. Now, as you can see, the cloud ENNI, which is the standard interface between the two operators, are spread over the internet, and the demarcation points starts where the green termination points are on both sides. If we think about, okay, what are the really attributes of those interfaces? Now, we haven't really defined that in the MEF yet. And actually, I started this work a long time ago before the MEF, and we did some really initial work, but the new projects are being developed now in MEF. Hopefully, we'll define them for each type of service in details. But this is just to give you an idea. For the Cloud Uni, for example, you have physical interface attributes, as you can see, and you have maybe multiplexing, the connection-related attributes, multiplexing or maximum number of connection endpoints. And then if the connectivity is layer 2, maybe you have layer 2 configuration attributes as well as the service O&M. SONM stands for service O&M attributes, and maybe the higher layer protocol stack attributes, and also the security and operational administrative states. Again, these are just examples. And if you look at the cloud application interface, in this case, you have maybe the VM or container flavors, and maybe the protections, maximum transmission unit, again, maybe connection multiplexing, and again, could be if application interface is terminating layer 2 or the layer 3 or maybe higher layer protocols, you will have attributes associated with them. For example, if you have a virtual firewall, in the virtual firewall, in addition to what you had in the previous slide, you may have license-related attributes. You may have bandwidth-related attributes, and again, the MTU, and also maybe the addressing-related, whether it is static or dynamic, or DNS, or the type of protocol type of attributes, and maybe NIC protocol, NIC port related attributes, and also, of course, the protection-related attributes like affinity or anti-affinity type of attributes that you may have for virtual firewall. If the security, for example, virtual firewall is a service that you are going to offer as a cloud service. If you look at the virtual router, in the virtual router case, clearly you will have the routing tables, whether it's a single tenant, multiple tenant, and the routing tables accordingly. And also maybe you may have loopback addresses and various routing protocol and option configurations and load balancing, maybe ANS numbers, maybe ANS federation numbers for BGP, and all other protocols that I listed that you may have attributes for those. Now, as far as the cloud virtual connection endpoints, and they may have traffic management, fault management, performance management, protection, and security related attributes. And examples are, again, like Cloud Uni. If this virtual connection endpoint is in a Cloud Uni, you need to have a Cloud Uni ID, or if it is a application, cloud application interface that you are terminating, that you may have ID for that. And also the subnet addressing, and maybe the DSCP, or if you are using MPLS, your EXP mapping, bandwidth profile, and maybe frame packet counts and additional encryptions, maybe connection authentication, and things like that. Those are, I expect to see as part of the cloud virtual connection endpoints. One thing that, of course, I added over here, protection, it may be somewhat unusual, but I'm also thinking that we may have same connection. For the same connection, we may have two different termination points on different uni interfaces. As far as the virtual connection is concerned, again, you have now on top of the fault management, performance management, protection parameters or attributes, you may have service level objectives and also the billing parameters. And the service level objectives is like delay, jitter, loss, and things like that. And on top of that, I gave additional examples like you may have connection start time, connection duration, or connection period if you are repeating periodically the connectivity. Redundancy, of course, the packet count, and so forth, would I expect to be part of the attributes for cloud virtual connection. Now, those describes basically the attributes describe the data path related attributes, but certainly you have additional O&M functions, operational administration, maintenance functions for cloud services. And those are like coding, ordering, inventory, of course, the provisioning, performance, fault management, service availability, and also maybe testing and billing. Those, again, needs to be addressed as part of the cloud services. So that's briefly, I summarized really what I think the cloud services architecture is and what are the components. I'm really hoping that the folks slowly use those concepts and model to build the cloud services, standard cloud services, so that we can start to interact with each other. Thank you very much. If there are any quick questions, I'll be able to respond before I leave.
Thank you, Dr. Twice. This is a great presentation. I have a quick question. Isabel, I see you're very active in the public cloud edge interface. So are we going to use this architecture in the PCF blueprint?
Well, I think it depends on Oleg and me. So how closely we work and really establish that. Absolutely, that's my envision. I would like to see that happens in the PCI on top of the orchestration architecture that we discuss in other meetings. So that's certainly my view. And certainly I want to mention this thing which Oleg is part of that. We have a project in MEF now related to the edge computing IaaS, infrastructure as a service, and that is using those cloud service architecture. and building the services for IaaS based on that. Hopefully, I'm just hoping that maybe we'll have that spec sometime next year and will be published as a standard in EMEA.
Yeah, very good. I look forward to seeing it being integrated or complying with this cloud service architecture. I think it's very important from the operator point of view. And we appreciate the viewpoint from the end users. I think this is how Akraino kept the momentum here. I don't know how many people are watching our YouTube live streaming now, but yesterday there was a WeChat, we opened live streaming yesterday night. There were like 1,800 people watching, and we got 9,600 likes from online. So really, so maybe just several people are building the blueprint and this architecture, but a lot of people are deploying it and implement this. This is tremendous useful for the industry. Thank you, Dr. Toy.
Thank you, Tina. If anybody wants to approach me offline, please do that. I'm really, I'll be able to help if you need to. I'm very much, behind this architecture and really would like to be used in the industries.
Mm-hmm. Excellent. Any questions from the online people and people in this meeting room? Yeah, we're getting more and more people when it's closer to lunchtime. It's very crowded now here. Cool. All right. And I think the next topic, we have a Sukadev talking about private 5G LTE. And the problem is this morning he sent me a message, he got a medical emergency. Now, at that time, he was going to the doctor's office. I hope he's feeling better right now. So he asked me to cover for him because he and I made this private 5G LTE presentation to LFN before. Thank you for his trust. Now, let me share this. Here you go. Can you see it? I got is it Sukadev, right? I didn't occupy the other people's time. Okay, it's 30 minutes. Okay. So this is last time Sukadev and I presented to the LFN developer and testing the forum. And we talked about Akraino and Tensor Fabric. I'm Akraino TSC chair, and Sukadev is a Tensor Fabric TSC member. So we covered at that time the brief description about Akraino and our achievements, collaboration with other communities like network cloud blueprint with Tensor Fabric and private LTE 5G blueprint with Tensor Fabric. So this is the LFEG project, the landscape. You can see we have stage 1, large projects like Beto, Open Horizons, Q service on board SDO. And we have stage 2 projects like E-Fledge, Home Edge, State of the Edge. And stage 3, which is impact project, we have only 2 projects so far, Akraino and EdgeX Foundry Mix is ready to be deployed. So you can see Akraino, this line is going from all the way from the constrained device edge to the center, the data centralized data centers. So it covers the smart device edge and the on-premium data center edge, access edge, regional edge, from user edge to the service provider's edge, from dedicated operator to the shared IaaS and PaaS, or whatever you want to name it. And so they are more like application side. Akraino is more like infrastructure side, and we welcome different kinds of applications running on top of it. This shows the LFEG from end-to-end, the context. You can see Akraino working perfectly with Open RAN, I mean RAN, Home Edge, EdgeX Foundry, Flash for the enterprise and IoT to integrate the upstream components into the blueprints. And also, like we had the ONAP talk yesterday at the TSC call, integrated OpenStack and Kubernetes, Akraino AI, etc. for these different clouds like public cloud, private cloud, and telco clouds. We're also working with the ETMAC. So Jane here, our representative, well, actually from ETMAC side, Alex from our side, and we work with Bob and Daryl, the people, to organize a 5G Mac hackathon for 2022. We had a hackathon before the pandemic in 2019. It was a successful story. In this case, we have a project, product, and deployment and profit. It's a very healthy closed loop. And then to show you the Akraino's blueprints, blueprint proposals, and development projects. This is a set of open infrastructure and application blueprint. It has the coordination and collaboration, cooperation with multiple upstream open source communities like Airship. They use Airship 1.0 all the way to the 2.0 in different releases in Akraino blueprint for this blueprint. And also working with Elephant Anokit. And tomorrow we have Bess will talk about the latest update of Anokit and why it's important for Akraino. We work with OpenStack, of course, and Tensor Fabric, which is part of this blueprint. ONAP, ETMAC, I just talked about. GSMA, I think the public cloud edge interface, they work with the GSMA OP and TIP. And after lunch, we have the colleagues from Meta will be here talking about TIP, Metaverse, and also the Metaverse ready, the networks. Of course, CNCF is Kubernetes ready, and we also integrate the K3S here. And ORAN. So we have the RIC radio, the RIC blueprint. And the objective is to deliver a fully integrated stack. You can see from the bottom to up what is Akraino, everything about Edge. Akraino is the Edge project. On the bottom, you can see the fully integrated open Edge stack. And then we develop the Edge middleware and APIs. We have the API subcommittee here, and with development of the Edge applications. All of this combination for the certain use cases on a combination of hardware and software with specific configuration and lifetime management, that's what our blueprint is. So this is a more detailed look in the what is an Akraino blueprint. It's a community integrated, tested, deployable, end-to-end edge stack. As I said, it's use case based, just like we have Wenhui just presented and Mehmet presented, like the use case could be the privacy, they care from like ByteDance. And also, and then we require the fully CI/CD. For CI, we recommended to use Jenkins, so you can build a continuously integrate to the server. And also we ask to push the CD log to the Nexus server every day. That's what we do, the continuous deployment. It's proven and tested by the community. So for all the blueprints, it has to go to the security scanning, like a VAS Linux scanning, and also has the Kubernetes Hunter if you use Kubernetes in the blueprint. And it has to go through, if it's in the incubation stage, it has to go to solve certain vulnerabilities. If it's maturity review, it has the higher requirements on the how many vulnerabilities you need to solve to make sure this blueprint is healthy and safe, right? And also the tested, we have the BlueVal, the blueprint validation framework, which is nothing but just the automatic scripts. You can run all of this testing. So there is also community lifecycle support. Each blueprint will go through the proposal stage, incubation, and mature, and core, and maybe archive. So in this case, we ensure this is the production quality and ready for deployment, because all the blueprint we ask for the business drivers is already being deployed or tend to be deployed, is there already a business plan, and who are the customers. So in this case, we achieve the benefits for low cost, large scale, zero touch provisioning. So we have lady talking about zero touch tomorrow from Europe, and the industry adoption. And we asked yesterday night when we asked about what's the open hardware, right? So we use the OCP white box here, or the OEM hardware here. So this is called open hardware. So since launch in 2018, 4 years now, Akraino continues to gain community support for collaboration and validation with more than 30 blueprints. As I said, there were 1,000 people watching our live streaming yesterday night. Here is how the release 5 blueprint looks like. Release 5 plus blueprint, and the blue dots means the new one. You can see from here, the smart data transaction. This is for the CPS. It's on the top. And the Cassini Smart Cities software defined camera. I think Reed is going to talk right after me. And the CPS robot, I see people are driving it. I see some deployment in the university and also in Tokyo, in the university campus. And topology prediction for vehicle networks and TAMI COVID-19, the rural edge. This has been deployed in South Korea, and this one is the winner of the MIT hackathon, and it's been deployed in India. And another new one is buffer the edge. I think Jonathan is on the call, and he can add some flavor here. There's the ICN multi-tenant secure blueprint driven by colleagues from Intel. This is new. And federated Mac cloud platform, I think colleagues from FutureWave actually doing this. This is part of a public cloud edge interface. Besides this new one, all of the green dots are the existing one. Almost every release, they have the new update, either the new version of the software or the version of the hardware, or they try on different hardware, different use cases. That's why every release they have the new CI/CD, because the CI/CD is daily job, push the log. So for example, the IoT predictive maintenance integrated from Eve, integrated from Fledge is the other project under the LS Edge. And also the Iliad IoT Gateway UCP has been deployed like in South Africa Telecom. And the 5G Mac cloud gaming, I think it has been deployed in Tencent. There's one thing I want to mention is the connected vehicle. You know, this the Winter Olympic, right? Winter Olympic, there was a girl called Eileen Gu. She won the Big Air, the Olympic golden medaler. So she was jumping fly over in front of the cooling towers, right? But those cooling towers near that, there's area. The connected vehicle was deployed there to for all the vehicles going there has to be managed and report the data for the road situation to the Mac. The Mac edge server is in charge of the area. So you can see actually from all the TVs when you see that, nobody noticed that we are actually deploying there. We are all the TV at the headline. Everybody's focused on athlete. Well, this is what we want, but we're there at the headline. So there are more. Yeah, you can. We will talk about over this 3 days. I think Oleg is going to talk about in detail for the public cloud edge interface tomorrow. So this shows the where the Tensor fabric is positioning here. You can see the Tensor fabric is a single SDN kernel, DPDK, SRLV, and CNI here. I think it's very similar to Wenhui's picture about your software stack earlier, but this is part of the Edge platform software component. It was part of the network cloud blueprint families. What happened? Okay. And here are the details for the Tensor Fabric documentation. If you're interested, go to the wiki. Here shows go to the topic of private 5G LTE. So you can see all the end host, like from the ambulance and anything, the assistant for the health industry and the heartbeat detectors, they all connect to the eNode B, which is the CBRS device. We know in the States, CBRS is very popular topic for this startup companies or the industries. And then they go through the private LAN, connecting with the EPC 5G core, which has the MNE and SP gateway there. So, and ONAP plays a critical important role here. You can see the CBRS cloud SaaS connectivity goes through to the ONAP, and there's incumbent access and priority access and the general authorized access, all managed by the ONAP. And also ONAP sees the local breakout, the overlay, the VLAN, etc. And the 5G core connected with the public-private cloud. There is the SDE WAN, the public interface, public internet, the private MPLS, etc. And also there's the Intel's OpenNIST apps running on the Edge clouds here. And oh, you got it. Ah, thank you. Hey, people. So switching topic. If for people who come on site in person, it can go to the 250 Hamilton Avenue to get a ticket. Like this, it's $25 for the whole day parking. Otherwise, like every 2 to 3 hours, you need to switch to different color. I mean, this is Palo Alto, the center of the universe. I have no comment on that.
Yeah. The clerk at this in City Hall insists that they're enforcing it now. She says since November, which is the last time we were here, they're enforcing the 2-hour parking. So.
Oh my God. Did you put on top of my car? Yeah.
No, you have to do that.
Oh, yeah.
You need to put that inside your car. If you put it on top, Tina, they're gonna steal it.
Yeah, you're right. Okay, I still have
you can keep it to the window and see how that goes.
I have 10 minutes to finish this presentation. Sorry about that. Okay. Yeah, so this is how the private LTE 5G software stack. Okay, they are, well, anyway. Yeah, if anybody can put it in my car, appreciate it. I can give you my car key. You can see the existing ICM blueprint is in the blue one. The new for this special BP, we put the LTE 5G RAN and the use case apps and the VEPC 5GC at the apps part, and also add the AF integration within the subset of ONAP projects of this whole software stack. And we add UPF here as part of the NFV component. So in this case, this is all about the Kubernetes and the NFV components. So it's just a piggyback at the ICM blueprint. I think the private LTE blueprint has been merged with public cloud edge interface blueprint family. We are taking care of the maintenance there. For more information, please contact either Sukhtel from Juniper or Oleg from Akraino. Okay. This shows the data flow, how it works. You can think about there is the data plan connection over the physical networks. Let's say 192.168, 122.5 to 122.6 through the BGP control plane. And we have the two clusters, cluster 1 and 2 with the Kubernetes here. And ENCO does the service orchestration on the top. This is what PSET the blueprint has already implemented. And the single node, the cluster will just look at both class 1 and class 2. This is like what functions in the class 1 and 2. James, you can correct me because you know more than me about the exact implementation of the PSET. So within class 1, we have the AMF, AUSF, NRF, PCF, and SSF, SMF, and WBOI, and UDR, the UDMI, and cluster 2, yeah, here or there. Yeah, we have more and more people, and next time we need to book a bigger meeting room. This is the biggest for the HANA house that, you know, yeah, because we just, everybody's resumed from COVID. We don't have any big companies say, hey, we can have a meeting like a Mariner or Intel yet, or Futureway. That's why we choose the third-party places. So, and the cluster 2 has the, sorry, switching topic all the time. Just want to say hi to you. The Gnode B, simulator, and UPF. So the different cluster will have the different functionalities for the 5G LTE, the private 5G LTE. Okay. Here is how the networks is connecting with each other. They use a Gnode B simulator here, going through the N1, N2, connected with the AMF, and on the right-hand side through the N3, connected with UPF, and the UPF connected SMF with N4, and connected DN with the N6. So, but the networks do span over clusters. Yeah. What is that? Taking photo of me. Hi, cheese. Selfie all the time.
We're ordering food.
Oh, ordering food. Oh my God. Yeah. It's just cross the street. Don't click. You just walk there. It saves a lot of money for the outage. Yeah. Here are the more details of our private LTE 5G blueprint. And yeah, we super devs here. He got an medical emergency this morning, and he's now in the doctor's office. He asked me to present for him. I'm doing like a mimic job. Questions? 10 minutes earlier finishing, 9 minutes earlier finishing with assigning timing. Yeah, I think this morning I could give a talk about private 5G as well. I can, if you have any questions for SuperDev, we can take it down here.
Well, I mean, maybe I will put my presentation because probably I'm the last person that should ask any questions.
No, we never say that.
Related to this. Related to these slides, I mean, it's also very much indicating there is a lot of simulation. I mean, so it's, I think, yeah, I'll be probably the last person to ask any questions, but thank you so much.
Okay. So Jane, any questions? Because I think you guys are doing it commercially.
Not really. We're on the 5G side. LTE, I'm not very familiar.
Yeah. Cool. Yeah. Well, since there's.
I mean, Tina, maybe just to, if it's possible, just to make a brief comment to Doug, you know, to his question. I mean, with respect to the UPF in the SMF, there is a advertisement function, PFCP, on the packet forward control protocol that actually you can interrogate through the NRF and you get all the UPF profiles over there. And then depending on the quality of service, because if it's a 4G or LTE, you have the QCI defined, all the applications and all the throughputs, quality of service. But if it's a 5G, then it's a 5QI for the quality of service. And then it's slightly different. Then you're using the SMF, the PFCP to get all the UPF's profiles and the service session continuity. But now there is also this service function chaining that you can use with the multi-access and ATSSS. Because then you don't have to have the N26 interface between MME and the AMF. And then you can use these, service level agreement between different service providers by using, this dual access. If, they're registered to a network that is combined between LTE and 5G core network or 5G SBA. So, thank you.
Thanks, Ike. So maybe I'll ask it later, but I'll just ask it now. We can talk about it later. But, so you have the 5G system architecture, but you have EPC listed as a function. They're talking about lunch. Oh, we're talking about the car.
Oh, sorry. Yeah, because the city will give me ticket
You
if I
want your
don't.
car when you leave, basically.
Yeah, exactly.
I get it.
Doug, maybe I can assist you on this question because, yes, according to GSMA defines 7 options about configurations that can entitle you to call it a 5G. In the configuration where you have, that's how it started with release 15 and evolves towards 5G. They're indicating that if you have an EPC LTE core network, but you have a new radio on the run, then you are entitled to call it a 5G.
No, I get that.
So
I appreciate that, but I just was referencing, so the previous slide had only a 5G service architecture, I believe. But in the block diagrams, it mostly lists either NSA or just EPC's reference as a 4G network. So I'm just trying to understand what's actually being deployed and tested. Does that make sense, Ike, or if I confused you, then I confused everybody?
no, that's very, very good comment because again, now you're absolutely right because in the LTE, this like 5G SBA, in the QCI, between the PGW and SGW, you have different tunnelings and it's very, very difficult.
Yeah.
You don't have also the multiplexing in the tunneling. So you have to establish each tunnel between this S5 and S8 interface. They have resolved this in the SBA through the NAS, where you can have from the user equipment through the core network, through the RAN or to the core network, to the UPF over NAS, a tunnel that you can also multiplex so that you can assure this quality of service. While in the EPC, you're a little bit right because also on the 5G SBA, you're absolutely right. The IP traffic is going on the GTPU. Now, and it's very much, to assure this quality of service. In 5G LTE, this simulate, it's also on the what you are getting from the RAN. If you're taking reference signal received power or reference signal received quality, it's in the LTE E node B, you are getting this from cell reference signal. In the 5G G node B RAN new radio, this is getting from channel state information. It's a signal synchronization for the time. So you're absolutely right because this is, if I understand, they're using a lot of simulations.
Sorry,
And-
this is all like, what was the question? My apologies, I missed that.
This is Doug is actually asking that you're using on the core EPC, LTE, NSA, and then you have references, if I understood correctly, to eNode and GNode B.
Well,
And how is actually implementing all this communication
yes, so I
between the
can
core and the run?
I can I participated in a few meetings with the private 5G LTE blueprint, and also we started doing this work in the PCI blueprint. So my understanding from what was tested was the implementation of free 5GC core, as there was the slide on multiple clusters. So in one cluster there was not this one, there was another one, but yeah, that one. You can go back to like this one here. So in the PCI blueprint, we're actually separating the simulator and GNode B into a separate cluster just for flexibility. But basically, what happens here is that the cluster one had all the control plane and the database, right? So this is free 5GC. This is implemented using free 5GC and cloud native version of it with Helm charts, right? And then the UPF in a different cluster, right? And the network in between. So in this case, it's Tungsten Fabric. In the case of PCI, we don't use Tungsten Fabric. There is just IP-BGP connectivity in between. So the simulator is also free 5GC. So it's not a real device, but it does implement the all the NAS and all the UE registration. It even looks for the sector. So it's all in the software implementation. The PFCP is implemented between SMF and the UPF. The AMF is talking, to the GNode B. So everything is done in software, and then the UE, which is not for some reason shown here, is also implemented in software and is able to actually pass IP traffic, to the UPF using GTP, and that requires a special installation on the on Linux to support the GTP stack, right? And then you could actually pass data. You could actually get a valid trace with this implementation. So there was no real kind of, my understanding, there was no real GNode B involved here or UE.
Okay.
One other thought here is that the free 5GC implementation of this simulator, they say they're compliant with release 15. However, there may be some, I guess, discrepancies or whatever, however call it. I tried to run this with a third-party simulator, and it just doesn't work. It has to basically, it supports the call flows as I described, but I think it's very specific to a particular software release, and it has to all work together as shown here. And this is just an example of a simulated end-to-end environment.
All right. Okay. We probably need to move on, right?
Yeah, we are on time.
Thanks, Oleg.
Yeah, no problem.
Thank you. We can keep discussing. Stop sharing offline. So our next topic is Project Cassini IoT and Infrastructure Edge Blueprint Family. Who's going to present?
Tina, this is Reed. I'm going to present, and Olivier, I believe, is online. He's a little under the weather on voice, so he'll be available to answer questions as we go through if needed.
Yeah, thank you, Reed. Thank you, Olivia.
Okay.
Thanks, Reed.
Yep. Can everyone see the?
Yes, I can see the screen. Do you mind? We want to see you.
Sure. Let's see here.
Everybody else has to be on video.
You don't want to see me.
Yeah, Olivia is supposed to come today, but he couldn't. But Reed is from Texas. And
Yeah.
you're Jeff.
Where is he? Where are you located, Reed? In Austin?
Based in Austin, yes.
Okay.
Yep. So hello everyone. I'm Reed Hinkle. I'm ARM Transformation Architect. I work in our channel organization. So I work with our ecosystem from our silicon partners all the way out to end customers. The main aim of my activity in our group is to work with our ecosystem to deliver the best on ARM solutions. And when we're talking about cloud and 5G enablement, all on ARM where possible, which is increasingly possible with the capabilities ARM architecture-driven systems being driven by various different cloud partners, beginning with Amazon and their Graviton instances. So our discussion today is around Project Cassini, and it's how we look at enhancing the cloud native development experience at the edge on ARM. This is an initiative that's driven by my colleague Olivier Bernard, who's our director of high performance IoT. I think you heard he spoke there just briefly at the beginning of the call. He's just a little bit under the weather voice wise, so I've stepped in to deliver the presentation, but he'll be available here for any answering of questions that you might have that go beyond my ability to answer. Let's see here. So just to begin with, wanted to go over and talk a bit about how ARM focuses on sparking the world's technology potential. ARM is the global leader in development of licensable compute technology. We have over 2,000 licensees, and that's growing by about 100 every year. We have 600 plus licensees that are industrial leaders, high growth startups, chip companies, and OEMs. We have over 200 billion ARM chips shipped to date, and it's impressive that number grows on a pretty good elliptic curve to date. And there's 28 billion to highlight that 28 billion ARM-based chips shipped in 2020. So you can see that, how we're climbing up that curve. So we do emphasize that we are have a collaborative business model and a culture of collaboration with our ecosystem. So a lot of the work that Olivier and I do are basically how do we include and incentivize and make it easy for our ecosystem partners to collaborate with ARM. So basically what we're working at on a daily basis is how do we fuel the innovation and growth in IoT? And we look at that across three different vectors. First is evolving our IP to address market needs, as evidenced by how we have solutions from everything from the smallest microcontroller to the highest compute level in the HPC market and everything in between. Most notably, the heritage in cell phone application processors has basically exploded into compute from endpoint to cloud. We focus on making our technology more easily accessible to our customers, and that's in our licensees. And that's not just from a licensing or actual IP availability model, but for how we actually make the IP available from a business point of view, licensing point of view. And we have a high priority on the developer experience, which is really what the Cassini program is all about. So we look at that there being significant deployment challenges, mostly focused for IoTs, mostly focused around the fragmentation and the requirement for scalability. And that goes everything from devices that have, are the rich endpoints that have one core per device to 5G infrastructure that might have thousands of cores per rack to intent-based networks, where you're looking at core counts in the millions when you're talking about our major cloud partner deployments. And that ranges from the sorts of use case requirements from minimum latency and power. These are typically on massively distributed, diverse, and very heterogeneous compute platforms, to maximum compute where it's centralized, connected, and homogeneous by nature. And then our aim is, how do we take this from a developer point of view and encourage software compatibility across the entire ecosystem. Big job, very hard to do, but I think we found the right balancing point to be able to drive this forward. What's actually driving this is, and from the initiative, and particularly as we look at edge computing, is that we have to move the computation closer to the data. The reasons are pretty clear. There's certain things that you can do. You can enable a lot of things in the cloud, but the one thing that you can't violate the norms of physics. We physically don't have enough bandwidth to transfer all the data that we would like to transfer to the cloud if we were to do all of our compute in the cloud. We don't have sufficient power across the various spectrum of compute to be able to deliver the sort of compute experience that we need across the without having a greater focus on edge compute with lower and lower power thresholds. We care a lot about latency in terms of the applications that we're developing. So latency in terms of having round trip to go all the way to a cloud server and return the result back, and then actuate, take action on the insights of the data. Many times that can't survive. The latency requirements of an application can't survive that round trip of data and compute. So that's a significant factor, particularly when we're talking about autonomous actions, things that are happening with robotics or autonomous systems. When you're talking about distributed compute, the generation of terabytes and multiple terabytes of data, much of this being personal, certainly needs to be secured to maintain its business value. That means that the architectures required for the devices are necessarily different than you might have in the cloud. When you have cloud equipment in racks guarded by guards and guns and efficient systems, you have one type of a threat model that you have to deal with, versus something where you have significant compute that might be on your street light, lamppost. It could be sensors embedded into autonomous systems, and all of those are potential access points for hackers. So we have to take great care of devices that are more readily available to make sure that they're secure enough to be able to survive basic attacks, and to prevent the sorts of grander scale attacks that might be possible if you're able to capture the wrong credentials or the wrong entry points into a system. So security and privacy, highly important. And then at the end of the day, you have to be able to deliver the maximum business value, which means you have to account for all of these different factors. So Cassini is effectively was brought about a little over 3 years ago. It's an industry-wide initiative across the entire edge value chain and the ecosystem. It was designed to support and enable the diversity of ARM hardware, and it's made specifically to enable the ecosystem to leverage the significant investment made in cloud native software. So all that, all the intelligence and everything that was developed, all the the data science and inferencing and everything that was developed in the cloud. How do we, the aim was, how do we move that closer and closer to the edge and do that securely? And so what we did is devised Project Cassini, and it's three major components. It's robust standards, so we basically have a set of standards. All of those standards documents are available on the Cassini website at arm.com. And basically it specifies everything that you need in terms of the specifications that need to be met by the hardware and the firmware on a platform. Also, all the documentation to be able to, the required and the test suites that are available to be able to test to make sure that your systems are compliant. It also includes this security API and certification regime as well. That's encapsulated by a couple of components that we'll talk about in a few minutes, named Platform Security Architecture and PSA certified, and also Parsec, which is our security microservices layer that delivers the security services from the secure world to the non-secure world processing environment. And then there's the cloud native software stacks and reference use case code that's being developed in conjunction with our ecosystem partners. The idea is that we deliver tangible benefits across the value chain by providing choice and optimized hardware, diverse hardware for ODMs, OEMs, and end users. We want to reduce the cost and the friction for supporting the ARM architecture across various different use cases from ISVs and system integrators. And we also want to ease and accelerate the deployments of these platforms. And the best way to accomplish that is to create that layer, that right balance of platform harmonization that can provide the sort of assurance that you need that the software that you're developing for your deployments will work as seamlessly as possible on ARM. So give you an idea of the value chain engagements that we have that spans, as I mentioned, across from the silicon ecosystem, ODMs, OEMs, the independent software vendors and system integrators. We deal with a great number of these the companies that are depicted here by their logo on a daily basis. And intensely with about half of these, very intensively, and then we're growing out that engagement with the broader ecosystem each year. That includes a lot of engagements that we have, not just with commercial software products or companies or cloud-based SaaS providers, but also a lot of open source projects that we collaborate with from a Cassini perspective, including Akraino and many of the other LF Edge based software projects. Why is this important in terms of when we talk about cloud native, and what does that mean? I think effectively it makes sense if you're developing certain applications in the cloud. You've made very large investments in your cloud software. You want to be able to leverage as much of that as possible and be able to pull as much of that as possible into the edge platforms. And so what we see is, from that perspective, is that about 60% of cloud application programmers use containers. There's about 4.7 million cloud native developers globally, and there's about 13.5 billion ARM container downloads just in June of last year. So you can see, the immense draw towards having containerized workloads, and this obviously this is June, almost 2 years ago. So I haven't seen the updated numbers, but they continue to rise in a similar level as they do on this particular chart. So what defines cloud native at the edge? So effectively, you're looking at, first of all, devices that are network connected and managed as network connected devices. So this means that there's an emphasis when you want to maximize your business value of your IoT deployment. You need to make sure that your device is managed, which means that it needs to be managed through its life cycle, including the ability to maintain its security posture and also keep it updated all the way from the firmware all the way up to the various different workloads that might be operating on the platform. Needs to be able to run general purpose operating systems. It also needs to support virtualization. So by hypervisor and other virtualization technologies, that's an area of particular focus for ARM in other initiatives within the company. We target that virtualization not just at traditional IoT or cloud-based workloads, but how do we create virtualization environments and heterogeneous platforms that are basically delivering autonomous functionality like vehicles or robots. And so there's a lot of ARM emphasis on how do we create the best virtualized environment that also meets safety requirements and security requirements in a system. And then basically, at the end of the day, all of these will depend on having a root of trust in the platform. And the requirements for that root of trust may be varied across the use case in terms of the level of robustness that's required for the application and the end equipment. And then also looking at how we provide software-defined device functionality. So that if you look at the picture here, that you can see where on the left axis on the lighter blue-green bar, that's where the security, the platform security architecture, and where the base system architecture and the base boot requirements from a system-ready perspective impact the entire stack of software on the right. This is a representative list of the project Cassini certified partners as of this quarter. As you can see, we have a number of certified boards. I think we're just breaching 50 certified platforms and boards. That comes from an array of the top silicon device makers that are developing with Cortex-A based platforms, including NXP, Broadcom, Ampere, Socionext, and we have probably nearly that same count of silicon partners that will be getting their systems system ready, or their silicon base EVKs certified in the next within the next year. We're doing a lot of this work through certification labs. So we have 4 labs that we're working with currently, located different places in the world for us to be able to deliver the ability for a growing number of partners to get their platforms certified. We're beginning to collaborate significantly with the OEMs, who are going to be a significant consumer of these platforms, and you're going to be seeing many of these OEMs talk about their experience with Cassini and how it's actually helped them achieve their platform goals and lower their costs for deployments. We work with a number of the top software companies and operating system suppliers, as evidenced in the ecosystem part, and that's a very small cross section of the partners that are actually involved. And then we also work with a number of the top labs from a platform security architecture certification perspective. Last but not least, we have the Parsec project, which is our how we deliver the security to in a currently in a Linux environment, how do we deliver the security microservices to containerized workloads via either OSs or directly from Linux via the Yocto. And so that we'll talk a little bit more about that later in the presentation about how that actually takes place. So engaging on Project Cassini, there's really multiple different ways depending on where you fit in the ecosystem. We do have a compliance program that focuses on, from a system ready perspective, that's the software defragmentation piece, and we work with silicon companies on getting their SoC designs made according to the base system architecture for Cassini or for system ready platforms. We work with them also to get their system boards, their reference platforms certified as a reference to then be able to take and get their ODM and board partners and their OEMs and their partners to be able to deliver platforms that are certified. We also have a number of advocates and participants in this effort, including EDA partners, operating system vendors, independent software vendors, our cloud telco enterprise OEM customers, our partners, IoT infrastructure enablers, and system integrators. So those are a number of our advocates and active participants in that portion of the market or of the program. With the compliance program for PSA certified, there we work directly with the SoC developers, the silicon ecosystem, the ODMs that manufacture the devices to get as many of their base platforms enabled, and then end OEMs to make sure that at the end of the day their platforms conform to industry best practices for root of trust enablement as a baseline for how they would then enable the security infrastructure on their devices. Then from a adoption focus, working through the Parsec project, which is how we enable standard OS and hypervisors to provide the security virtualization and orchestration runtimes, and developing IoT platforms and their edge workloads that can access the security services of a platform without having to have specific knowledge of how the security infrastructure operates on a platform. So from system ready perspective, there's one key vision is how do we take the SoCs that are targeted across multiple different market segments? How do we then take the various different systems that are a result of or the manifestation of the systems that are built upon those SoCs? How do we then enable those SDKs, the board support packages for those platforms to meet system ready certification? And that's really the crux of how we work on to defragment that the software on a platform. So we bring all of these BSPs up to the same level of platform firmware support, and then we're able to test that via a test suite, and then we also require OS or ISO. So actually the firmware images of, or the software images of various different OSs to boot on unmodified, so that you can prove that the systems all have the same level of capability. So what we did is you can't treat all systems the same. You can't treat a server the same that's built for the cloud the same as you would build a embedded or edge server or an IoT device. They're all certainly different types of platforms that have certainly different set of baseline requirements. Our aim is in the spectrum that's listed across the bottom here is that you have things that are fixed function, which are really, your server needs to be, it's low flexibility. You want to be able to run, software very generically. And so that's really the focus of System Ready for servers, or the SR certification, all the way to the devices that are much more customized, or your Yocto IoT type devices. You want to be able to enable the customization, but without that high software maintenance cost. And so that's where we really focused on finding the right balance for that to enable the innovation, but also can be able to control the cost. So finding that right balance of compatibility, software compatibility on the platform. And that's what we believe that we've done that with the System Ready specifications. So from the frictionless edge, we see as being critical to unlocking value. So if you take that same broad set of value delivery from rich endpoint all the way to the intent-based networks, you can see where the different elements fit. Server Ready fits the cloud data center and peering content services delivery systems. At the infrastructure and edge, and more specifically the 5G infrastructure that we talk about within the Akraino project, the most of those systems would be embedded server ready, or ES. Industry 4.0, or kind of the fog, used to be termed the fog, would be some mix of the edge servers, the ES band, but also with the IoT ready band, which are a lot more custom to the application. IoT gateways being more of the IoT ready band of requirements. And across the bottom, we have, or basically across all of those, what spans all of those is PSA certified, the certification program for the root of trust. And then for everything that's the IoT gateway up through the intent-based networking would be Project Cassini. And we have a new program for microcontrollers that's aimed at solving some of the same issues for creating cloud-enabled devices as microcontrollers. That's called ARM Project Centauri, that was announced at ARM Dev Summit last October. And you'll be learning a lot more about that in the coming months. So trust is essential for digital transformation. Basically, if you to get that data, to establish the value of the data, you have to, you first have to trust the devices that the data is being collected by. And then you need to be able to connect and manage those devices, continue to be able to manage their security and their provenance over the lifetime. Only then can you trust that you're harnessing the data in a way that you can actually rely upon that data for the insights and actions that are intended to be taken by the solution that you're developing. So at the end, trust brings value. So what's the vision of PSA certified? So it's really all about the fact that you have to have a certain level of assurance for your platform, and a best practices way to achieve the security, particularly around the root of trust of a platform. It's aimed at how do we keep the trust profile of a world where you'll have trillions of connected devices. First, you have to build trust establish the trustability of the device, and then you have to be able to measure that through, and that's what we believe that we've done with the PSA certified program.
Hi, Reed.
Yes.
Remind you about the time. Even though from now to 12:30 we don't have any talk, it's free lunch here, but you may want to save some time for.
Yep.
any
Yep.
question.
Yeah. So effectively building in the security, there's 10 security goals across this. We can, if you're interested in learning more, there's a lot of information at the PSA certified .org website. But effectively, we focus most of the effort around the root of trust. A lot of other certification schemes, worry about other aspects above that, but there's not a singular security certification scheme other than PSA certified that focuses on making sure that you have a properly built and root of trust on a platform. We'll talk a bit about Parsec. So this is, basically how do you create a cloud native experience from a security perspective? Most of the cloud native developers are not experts in security. Most of them don't program in the languages that are common for how you do the implementation of security in your system, which is generally C or Rust. So basically, the idea was, creating the abstraction to be able to deliver the security services, but in ways that cloud native developers can access it without having to understand the underlying functionality and how it's built, or even touch it from that matter. So the idea is any platform, any architecture, and any hardware, from a hardware perspective or the firmware perspective, that means multiple different ways that you can deliver the security infrastructure on a device, whether it be TPM, HSM, trusted services running in trust zone. And then when you go above the line in terms of the microservices, how can you access that across cloud native access applications in any programming language, any runtime with any kind of container orchestration? And I believe, again, we've achieved a lot of these goals already, and continuing to build that out through the work that we're doing in Parsec. Before I leave this, it's basically, or it is a CNCF Foundation sandbox project, and we're working on actually graduating that to the next level this year, as we've been able to do integrations with Amazon Greengrass 2.0. We're working with Microsoft on Azure Edge integration and the Enclave confidential Enclave blueprint. So we've got a lot of integrations going on with significant projects that enable secure edge devices with popular cloud delivery platforms. We have a number of reference implementations that we're working on across industrial, high performance edge inference, smart cities. A number of those. Some of those are these blueprints that we're working on here within the Akraino project and more. Skip through a couple of these. Because we can make these slides available. So the Smart City Blueprint is the one that Olivier's been sponsoring inside of Akraino. And so obviously, Smart City being considered critical infrastructure hits a lot of those notes in terms of needing to be highly reliable. It's a highly diverse set of applications. So we see this as a particular good way to illustrate the good that Cassini can deliver in terms of building a cloud native environment for developers and to deliver high business value. So at the end of the day, when we were evaluating how we were putting together, Project Cassini, it had to have advantages, obviously, versus inaction, and we wanted to make sure that these advantages were clear and the value proposition was clear, across all the key ecosystem participants, whether they be the silicon partners, ARM Silicon ecosystem, our ODMs and OEMs that deploy platforms based on ARM, the software ecosystem, system integrators that are responsible for putting together the end-to-end solutions, and more importantly, as we look over the lifetime of life cycle of products, the IT and OT infrastructure partners. And I think we found a good note for all of these, ways that Cassini can address the particular problems that have historically made deploying products on ARM a little bit more difficult. And so I think we've gone a long way to be able to really show the value across the entire ecosystem. These are what some of our partners are saying about the program. So we had at our anniversary launch event at Dev Summit last year, key supporters include NXP, Advantech, Red Hat, Rancher, Capgemini Engineering. So you can see this is just a representative. These are just a few of the various different partners that are talking about the value that they see in their work with Cassini. Traction and progress. This is a similar slide as before. You saw where we were at in terms of the devices on the left side that are already certified. You can see where we have a number of new platforms that are coming in, both at the silicon level and also at the device level, and then a constant pipeline of additional devices, silicon platforms and devices that are coming. And now we're also beginning to embark on system-ready engagement, including certification of some of the software platforms as well. So I think you'll see over the next year some of the different OS partners that will actually be getting the system software part of their platforms also system-ready certified. Where we're at in the journey. Sorry, this was a four tranche journey. This last year, we're this fiscal year, which ends at the end of this month, we're completing phase 2, and now we're entering into phase 3. And I think some of the things that you'll see is we're moving from the adoption phase to showing it as more of a standard. Many of the elements are either codified in industry standards or specifications. A lot more collaboration with the other elements of the industry to make sure that the fine work that we've done can be leveraged anywhere and everywhere in the ecosystem, including all of the elements of open source software that are a part of what we deliver, much of that already in or moving to open governance. So that'll be a lot of the activities that you'll see over the next year, or the kickoff of those activities. Now we're to questions.
Reed, my name is Sai Callison.
I'm at the live site in Palo Alto. I have a question for you. Can you hear me?
Yes.
Okay. So everything sounds, first, pardon me for maybe asking I won't say critical, but difficult question. Everything's good. I like your emphasis, especially on meeting the identified challenges. But I don't see mention of performance. You did mention graviton at the beginning and kind of put some emphasis on that as being an example where ARM is achieving higher performance, but that's not a commercially available device. People can't go out and put that into edge computing. They have to, that's going to run in the cloud. So they're basically, that's just the old client server relationship. And they're stuck with using server side. Forgive me for my 20 terminology, but so what's your plan there? What is ARM's going forward plan for something either that competes, at least on some level, with Graviton, or has that level of performance, or partnering with someone like Amazon to make those chips commercially available so that developers who are working on edge-centric hardware might have access to it?
Yeah, so the one so one of the partners that you saw on the list there was named Ampere, and so they are a they make a, or they have developed a chip, a server grade chip, and it's packaged in a couple different ways. They have a 80 core and 128 core version, so it's a very powerful chip. But what they've done is, you can deploy it in data center applications, but it's also deployable in edge applications as well. So there's a platform that we're actually working on right now. So we've actually had for a program that we call SOFI, which is an autonomous, it was that heterogeneous autonomous vehicle platform in terms of the virtualization that we were talking about. We actually developed a developer system through AdLink, a Taiwan manufacturer, called Ava. So if you look up ipy.org/Ava, I think that's the name, or the Ava platform. And what we're going to be doing is expanding that into basically a developer platform that can be used in different markets, including 5G and edge, basically other edge use cases. So that will be directly available by developers as a platform to target, very high performance edge development. That would kind of be at the high end, and then we're going to be working with some other kind of middle end solutions. There's a lot of our ecosystem that will be launching new platforms in the coming months that can fit kind of the mid range to that, somewhere between that and that higher end platform. And then you'll see us, working to be able to highlight how those can be positioned across different use cases.
What chip is on this AdLink Ava platform?
That's the 80 core Ampere solution. Let me see if I can find you the.
Reed.
But Reed, we also have a number of other partners like Socionext that has very powerful products.
Socionext, Marvell, yeah. But the one,
and all of those are supported by Cassini.
Right. But the one that's going to be available in a developer type format, that Ava platform is one of the first of its kind. That's going to really kind of put that sort of power in the hands of a developer.
Hello.
So what do I search for? Wait a second, guys. Hold it. So if I put in Ultra,
Ultra,
Ultra.
Ampere, AMPE.
No, I know Ampere, but that's not what I mean.
Ultra.
Ultra, not U.
Ultra with an A.
ALTR.
Okay, Altera.
Okay, can I ask a question?
Ultra, ALTRA.
Got it.
So there's other form factors coming from other ODMs, which will be towards the
Hello?
that we just mentioned.
Okay.
So besides the 80 link that we mentioned, there are other platforms like
That's right.
Supermicro and a few others already announced.
Well, if anybody hears from Ampere, Peter, if you're on the call, you might want to fix your links, because if I put in Ultra ARM chip datasheet into Google, you guys come up first, but unfortunately the link doesn't work.
Excuse me, can you hear me or?
Yes.
Yeah, we can hear you, Ike.
Okay.
We know it.
I will just read on page number 7.
Yes.
You had an indication, kind of a pie with reference to standards.
Yes.
Now, I send you a message with a link. Can you open it, please?
Let me see here. I gotta reopen my.
It's in the Zoom chat.
Yeah, I got to reopen my Zoom window because I had it minimized.
Right.
I got to figure out how do I get back into the regular Zoom.
So I don't see
I mean, let me see if I can.
In addition to Ampere.
I try to assist you because.
Using the Ampere chip.
Yeah, like Ampere. I got that.
I'm sorry, I'm having problems with my Zoom here. Let's see.
No, I'll try to assist you also. So that
What is the question?
I will show you, maybe you can, I mean, it's related a little bit to IoT and the IoT standards.
Go ahead.
Yeah, I will just, now, I will go, if it's possible that I can share my screen.
Yep.
So that maybe you can help me.
Go ahead.
You have to release your screen, please.
Yeah, I'm trying to do that right now. That's what I'm having a problem.
Stop sharing. If you just can keep, press the button, stop sharing.
Yeah, the sharing, but oh, here we go. It moved on to a totally different screen. So sorry about that.
Exactly.
I hate when it does that.
Yeah, thank you.
Yep.
Now, maybe you can help me. Can you see my screen?
Yes.
Now, this is the information that I have here to the left. You can find, do you see that?
Yep.
That's the legacy standard, IEC 62541. It's 274 pages. But when it comes to IoT standards, this is the information that I have.
It's okay. We know.
Here. Do you know this standard?
Yes.
Okay. Now, could you please be so kind to help me? How you, because this is pre-integrated with 5G and uses the security and decryption. And this is used predefined artificial intelligence. This is about, the metaverse. But this is also about semantics and the context information management, the next generation service interface, linked data. Now, this is the global standard. It's a national standard in Korea and in India. And this is pre-integrated with 5G NDL, supporting context and semantics. Now, you please be so kind to help me. This is about the semantics on the node level, and there's also a little bit about on the application level. Now, when it comes to standards, now I'm getting a little bit confused and I need
So the standards that we're talking about are
some
actually
help from you.
So platform and firmware standards. So not touching these application standards. So in other words, the standards that we're talking about are the firmware standards like U-boot or
an
like
application.
No.
So that's right. We're focused on the platform firmware standardization.
The ARM system ready standards are ARM-based standards on architecture's implementation.
Right.
So they're much lower level of compute.
How these architectures are related to the IoT standard defined platforms and implementations, because here you have 15 common functions defined, standard defined across these 10 use cases. Let me show you.
Those are an application standards. They're much higher level in a value stack.
What do you mean they're at a higher level at the value stack? This is a kind of a 15 common functions that you see across these 10 use cases. And these are the common functions. Let me show it to you in the
Yeah, we're very familiar with these. Yeah, so when we talk about standardization, when we talk about standardization, we're not saying we're standardizing all IoT software. What we're saying is we're standardizing how the ARM software architecture or the overall architecture is represented from a software point of view. What are the firmware interfaces that you can expect on a platform. So all of this sits on top, well above.
Another way to
that
look at
layer.
it, if I may, is the ARM system ready standards mostly apply to silicon makers. A lot of the standards you're showing here applies to end users and ODMs and OEMs and people who are developing the application stacks.
Right, exciting. But I mean, could you please be so kind to help me? Can you add to your presentation anything that you have already implemented or delivered that is actually related to these 15 common functions related to these 10 use cases that are already implemented?
So all of those functions that you're showing and those applications usually sit on top of operating systems. Right?
Okay.
The de facto application is you have an operating system with a system framework, with system firmware, with container management orchestration services.
Right.
We're underneath this. So we
Okay.
are making sure that any software, any operating system can land on any hardware. And a common value, a common value we had is you could have the same operating system working on multiple silicon suppliers, or on a silicon suppliers, you can have multiple operating system working the same way and non booting the same way.
Wonderful. This sounds very good, because in this case, you're quite ahead. Now, the question is, because India and Korea, and they're also certifying in implementing, by any chance, do you know, or do you have any cases where people have implemented this using your platform, so that you can actually add this to your presentation and say that, look, guys, this is also what they're doing with respect to the one machine to machine platform with these functions for these use cases. Do you have this?
Yeah, so if you look at the presentation that we just got, around slide 21, 22, 23, those are the kind of use cases that you're looking for, that are looking at the high level application and how they're enabled and accelerated in deployment due to the fact that those are Cassini products.
Yeah.
And that's why we're working with Akraino to create that blueprint for smart cities.
No, I understand that.
And we're linking all of this together.
But I'm asking you specifically for this specification and this implementation.
I could try to take this offline because we're running out of time here.
Okay.
So our next speaker is sitting here, the CEO of Anilog, sorry. Moshe.
Yes.
Thank you, Oliver. Read. On the PD, we also started last year on site.
Moshe, I read your summary.
Oh, you did?
So if there's any cloud guys on the call, they're in for a ride here.
Well, I'm more interested in the ARM thoughts about what I'll be showing, but
Yeah,
so
you got quite the presentation coming.
yeah. So let me bring it up.
You need a chopstick.
Sorry. I could. The folks over here.
Oh. The folks here.
Oh yeah, look at all those forks.
No.
My goodness.
Maybe we just need a knife. Go ahead. We didn't want to block you. We're just too hungry.
I was just looking. I mean, so I had so many screens because I also I'll try to do also a live presentation, a live demo of how Anilog works. So I've got so many screens open, so it's a little bit.
Oh, I see. You got something that.
Yeah, so I'm connected to what we call the Anilog network.
Are you based here in the Bay Area?
I'm in Redwood City.
Okay, well, Redwood City.
Do you want to get some food first?
I'm good.
Round of sugar will get you.
I'm fine, thanks.
That's
There
so
will be
boring.
something left over. Continue later.
Thanks. So, hi, thanks for the opportunity to speak here. My name is Moshe Shadmoner, and I'm the founder and CEO of Anilog Anilog, or what I'll be talking here is how to make edge computing the future cloud. What we'll be showing is a platform that serves edge data to the applications without intermediaries, without the cloud. So we're able to connect the applications, regardless of where they're running, on-prem, on the cloud, directly with edge data without the need to move the data to the cloud. And we're very focused on being very efficient with very large data sets. I don't know if we have time today for me to go to all the details, but it's a platform that could deal with the largest data sets in real time. And it's really a platform that every industry that has a lot of IoT data could leverage, whether it's smart city, industrial automation, connected cars, robotics, oil and gas, all those platforms could leverage what we're doing. So let me first speak about the problem that we solve. The main problem, the main issue is that there is huge amounts of data at the edge, and we're all engineers. We know that even simple problems, when there is a lot of data, those simple problems could be very, very complicated. And on top of it, there are other issues. I mean, the first one is that the data is not in one place. What makes the cloud very attractive, or one of the main reasons that the cloud is attractive, is that at the end of the day, the data is in one place. And you could put a team around it and build something. Maybe it's not the most efficient, it's not in real time, but you'll get something working. On the edge, you're in a place where the data is distributed all over, and companies do not have the resources to put so many people and professional services on all those edge nodes. So that's another problem. So millions of disconnected nodes, each one of those nodes have a portion of the data. And those nodes, we know, are not very strong. They're in many cases low in compute and storage resources. So the problem, or if you think about the scenario, companies really don't have any choice other than moving the data from the edge to the cloud. And if they do things at the cloud, it's really kind of trying to solve specific problems. Obviously, they don't have on an edge node, you don't see all your data, you see just local data, you try to solve specific things, and you would address it by proprietary projects. Another issue that we see at the edge doesn't offer the cloud services that are available on the cloud, right? So you have to shoehorn the solution yourself. So that's kind of at a high level the problem that we're looking at, and here's where our solution comes in. And what we're able to do is we are able to transform the edge to a virtualized cloud where nodes are dynamically integrated to provide the optimized power and storage and compute that is needed to host the application and be the platform where the data is being managed rather than a station of the data on the way to the cloud. And if you really think about what you're doing and you think about this concept, what we really are able to do, we're able to connect the data consumers, which are all those applications that need the data, with the data producers, the devices that generate the data, without intermediaries, without the cloud in the middle. And we're able to do that with 100% automation, which brings high levels of efficiency, simplicity, immediate go-to-market, and very low cost of ownership. So before I'll talk about how Anilog works, let me just summarize it and say that the value here is that we are able to automate everything, make everything simple, and at a fraction of the cost. And the idea is you deploy Anilog on edge nodes, and I'll show you in a minute how that works. But that's all that needs to be done. From here on, everything is self-managed and automated. That means that those edge nodes that host Anilog instances on them form a network that makes all those nodes that are members of the network operate and process data as if all those nodes are a single machine, which is optimized for IoT data. And we're doing it with 100% automation. You as the user of the application is able to get a unified view of the edge data. This system processes data and allows users to interact with the data in real time. There are no scaling limits. It could deal with the largest data sets that exist today. It eliminates the need with technical and professional services. It's self-managed. There are no dependency on the cloud, and applications get standard interfaces to the data. So the value here is data remains at the edge, fastest time to market. So think about a smart city today where you deploy, you want to make the data available. This could be a multi-month project. And we know smart cities, just picked an example out of many, we know huge failure rates in trying to manage the data and bring the data to a unified state. Whereas here, you deploy Anylog on edge nodes and you'll be able to immediately interact with the data, and the data is unified and organized without any effort, which obviously have an immediate impact on the cost. So let's talk about, let me show you how that works, and I'll show a diagram first, and then I'll show you the live demo. I mean, what is the experience of users that are using the Anylog network. So this diagram shows on the left side, we see the devices or sensors that generate data. And the common practice is to move the data from the left side, from the device, all the way to the right side to the cloud where the data is being managed and could be serviced. And by the way, this approach is problematic because we know it requires multiple software stack. Some of them are outside the cloud, and then obviously the cloud software stack. So we're talking about an approach that says here to manage IoT data, we need to support multiple software stacks, different software, software components in every stack. This is hard to build, hard to manage, and very hard to scale. What we're saying is we allow users to deploy Anylog on edge nodes, and those nodes form a network. So all the nodes are able to operate and appear as a single machine. And that means that the applications are, all they need to do is connect to the network. And practically speaking, they would connect to a single node in the network. And this node that they are connected to would virtualize all the data that exists down there at the edge as if it lives on this single node that they connected to. So the node in the network that they are connecting to may have zero data. It might not have the data, but it's able to virtualize all the data that exists at the edge, and it's doing it by peer-to-peer processes. And in terms of the technology, I'll just give you the direction. I mean, the idea here that rather than moving all the data from the edge to the cloud, we are such that queries could be satisfied, we're doing exactly the opposite. We're moving the processing to the edge. I'll say differently, instead of bringing the data to the queries, which what people are doing by moving the data to the cloud, we're moving the queries to the data. So when this node that virtualizes the network gets a query, it's able to figure out very quickly, very efficiently, where the relevant data resides, which are the nodes that host the data which is relevant to the query. So we could have millions of nodes in our network, but given a query, there is a subset of nodes that host the relevant data. Those queries are being pushed into those nodes. So we're able to leverage massive parallelism here, process the queries concurrently on all those nodes. All those nodes return the result to the node that virtualizes the data in the network. All those results are being unified and returned as a unified result to the user or application. So think about it like map reduce dynamically on the fly per every query. That's the approach. And by doing so, we're able to remove the dependency on the cloud. The data is serviced directly from the edge node, which gives a lot of power to the edge, right? Instead of the edge being a station of the data, by doing this approach, the edge is the source of the data, and obviously huge impact on the cost. So by connecting the data consumers with data producers without intermediaries, that's what we do. We do it with complete automation, real time, immediate go to market, and a fraction of the cost. So let me show you now the demo. Before the demo, I'll just explain what you'll be seeing. So every one of those green dots is an Anylog node that is deployed somewhere in the world. So this is, you'll see a real map, and those green dots would represent real machines, usually low power machines, edge type of hardware that hosts data. Now, each one of those edge nodes is connected to devices that just push the data to the node. And the claim is, what we're saying, that's the only thing that the data owners needs to do. From here on, everything is automated. And I'll show you what that means. So, but if I'm a smart city, industrial automation, connected cars, whatever, the only thing that I need to do is bring the data to the network. From here on, the network manages the data in a completely automated way. No coding is required. It's all automated, and the data is immediately available. So let me go to the demo. Okay. So here is the map. So those dots, those green dots, are really nodes that host the data. I need to be able to navigate here. So data is being pushed from different sensors into those nodes, and we connected Grafana as an example of an application to one of the green dots in the network. It really doesn't matter which one. We picked one of the nodes. I think it's this one that my cursor is standing next to, but it doesn't matter which one. And this node may have no data at all. However, you could see here, and by the way, this would move as we speak because it's all in real time. Grafana is able to sense the query and interact with the data as if the data lives on this node, whereas really the data is on all those nodes or some of the nodes in the network. So I could move and show you all the data that exists here in the network, and everything would be represented in real time. And I'll make it more concrete in a minute, but as if it lives on this node that the Grafana is connected to, and all the Grafana is virtualizing all the nodes that exist down in the network at the edge without the need to move the data, without the need to do any processing on the data. It's all automated. So I could show you more and more, but let me make it very concrete. So this is one of the GUIs that we offer to interact with the data. And I just prepared a query, right? So let's say that I'm an application that wants to issue a query. So let me cut and paste that to the GUI. So here is my query, and I'm sending the query to one of the nodes in the network. So you see here on the top left side, the IP of the node, and I'm telling it that I want to send it to the network, and I'm hitting send. Okay, so I'm hitting send and I'm getting the data back. You could see there is a lot of data that came back, but as if, so the whole experience was as if I'm running against an Oracle database or MySQL database where everything, all the data is here, but this node brought the data in real time from all over the world and presented it to the Grafana. Grafana thinks it's talking to an Oracle or a MySQL database, but there is no data at the node that Grafana was connected to, or in this case, the GUI is connected to. The data is spread all over the world, but it lets users and application interact with the data in real time as if the data lives on the node that we are that virtualizing the entire. Sure.
So is the query going to the Anylog node, or is it going to the actual devices?
I'll show you. let's go back to this slide. So Grafana or my GUI send the data to the Anylog node, which is in blue on the top, right? This node is able to, and if we have time, I can show you how that happens in more details, but this node is able to know, looking at the query, because it's got the query, it's able to know which are the nodes at the edge, host the data, which is relevant to the query. So I can get a query saying, you know, tell me the gas meters increase in Palo Alto in the last 2 days. So there could be millions of nodes.
Good question.
Good questions, I know. Millions of nodes in the network, but only a subset deal with the Palo Alto gas information, right? So this node that is virtualizing the network looks at this query, knows it's able to know where the relevant data resides, pushes the query, this query that wants to know what happened in the last 2 days to those nodes at the edge. These nodes at the edge host the data, right? That's our starting point. We keep the data at the edge. There is an analog software too, not just on the virtualization node. So those nodes know how to satisfy the query, and we are able to achieve here efficiency because the query is distributed to multiple nodes that are working concurrently to satisfy the query. All of them return results to the node that's orchestrating the query. All those results are being aggregated and returned as a unified result to the user application.
And the query is going from your regional data center up to the Anylog node?
Yeah, as the query goes down and the results go up. Yeah.
So you have a piece of Anylog software also running on the regional data
Yeah,
center,
yeah.
or is it a backend, any other application?
We run there because
You have an agent running.
yes, we have an agent. So all those nodes actually have the same software stack. Every node could act as a coordinator of the query. You could issue a query to every node in the network, and each one of those nodes would know what to do. Some of the nodes are configured when you deploy a node to host data. Some are just there to satisfy queries. And
is there any amount of caching done at the Anylog node at all, or is it just real-time queries?
it's all real time. It's what you show, what you're seeing here. It's all real time against live
So there's no
data.
caching done.
No caching. It goes all the way to the edge and gets the data, and it makes the edge the source of the data. So rather being a pipe to bring the business to Amazon, what we're actually showing here, that you could be the source of the data and you could service the application rather than being a pipe to Amazon. That's
And there is no, sorry, why do you go ahead? I'll ask that question.
so no, it's just to summarize. So we are making edge computing the future cloud. That's what we are bringing. That's the story that we're bringing. So the main point where we transform the edge to a virtual cloud, which means that we manage distributed edge data and resources from a single point. And it's a self-managed platform, which means that we replace the cloud services. We do it with complete automation. We provide unified view of the data. You don't need professional services at the edge. You just deploy Anylog nodes and everything is automated. What we're doing, the way we are, or one of the main values, we're able to connect the applications directly with the edge data without moving the data through the cloud. It brings efficiency, simplicity, real time, and we're doing it. We talked a little bit about it by moving the queries to the data, not the data to the queries. That's part of the technology behind it. And all of that leads to a fraction of the cost, because if you think about this model, what it would cost really to put something like this is only the cost of the hardware and the electricity. You don't need to build data centers because the data center is all virtualized. It's in the cloud. It makes all those nodes process and appear and operate as one data center versus everybody else that are building physical data centers. And so it eliminates the cloud services and proprietary edge projects, which also have a big impact on the cost.
But your nodes need to have enough storage for maintaining the history of whatever it's sent data sent. So that's, in essence, maybe it's a data center of a 1RU server, but it has to have storage for whatever it needs. And then if it runs out, then you have a dilemma, right?
So, okay, so that's a great question. So the considerations here, the thing is no different than the cloud, right? Also in the cloud, when you run in the cloud, you have storage and you could add more and more storage. When you're same thing here, because it's architected that you're able to scale horizontally. So you could start with a node, and this is not sufficient, add another node and another node and another node. And there is a mechanism where if you have the resources, this would scale and you don't have to worry about that.
But the node, so that the IoT devices are pointing to one node. You're saying that you can have a cluster of nodes that represent.
Yes, I mean, it's a little bit simplified the way I described it, but it's more sophisticated. You connect to a logical, let's call it a cluster, and you could add as many devices on the cluster, many resources, and just scales horizontally.
So then the cluster is really a data center then. I mean, this is where it gets.
But it's all virtualized, right? It's not physical data center where you need to bring the machines, you need to bring people. You could deploy it from a switch or a gateway all the way to the largest server and determine yourself where you want it to be hosted, which in this case would be at the edge.
But you need servers. You may not need a data center by some definitions, but
you need servers to host the data.
I think Moshe's assuming that growth, right? A big growth in servers and storage, the densification of the edge.
And I think
so it'll be there somewhere. And then
my
you gotta
definition of a
figure
data
out-
center is much smaller than most. That's why I'm thinking of a data center potentially being a quarter rack in some.
I think if I understand it right, you're saying, pick from here, here, and here, and that becomes my
that makes sense.
Exactly. So it's exactly this next slide, I think, would
as
show.
these products come out, like Ampere servers, and
Well, it doesn't.
we were talking
It's just
about the
this space, right? I mean, do you have any hardware specific or operating specific requirements?
We work on we could work on any operating system. We could work on any.
You can work on the cloud as well.
Because we virtualize everything, so there are multiple tiers. I could, if we have time, I could show you more details of how it's integrated and how it's virtualized everything from the storage layer all the way to virtualizing the tables and the databases, and it all becomes virtualized. So we are very flexible and very scalable. Okay. So I think this slide would answer some of those questions. So what we were saying is, look, devices generate data, push the data to where you want the data to be hosted. And in many cases, I mean, if it's industrial, as an example, you don't want to take the data to the cloud, then to run again queries on the industrial floor, right? You want it to be right there. So you push the data to any node that you think you would want the data to be. But then the cloud is being done in a virtualized way. We call it edge cloud, which means that the cloud is all virtualized, and the interaction with the data is all done in a virtualized way, and the software is all self-managed.
I think that's it.
So my last point is that we are moving from an old model. What we're building or what we are offering is to move from an older model where we allow to move where in the old model we need to move data and remodel operational data from the edge to cloud-based data lakes and warehouses. That's how companies deal with data today, to a new model, which is what we're offering. We're offering operational data and analytics to remain at the edge, to make those edge nodes self-managed, and enterprise cloud application could be serviced and satisfy their queries directly from what we call the edge cloud, the data that is hosted where it's being originated, eliminating the need to move the data to the cloud and manage the data at the cloud. It's a self-managed platform, allowing companies to keep data where it is and manage the data in an automated way and provide the applications the same APIs that they're used to today in order to interact with the data. It's all in real time and at a fraction of the cost. That's what we're doing.
Can we ask some questions? So you showed some data. There were some slides there with some graphs. Was that? It looked like speech data to me. Was that
So actually, I don't know what the data is because it's different users that
Okay.
push data there.
Well,
and,
let's use audio then. How would you do that? Would you store, like, would you transmit encoded audio between nodes? What's your, when you talk about a lot of data, I'm thinking like media,
right.
audio and video, but audio is a good place to start because it's, not as intensive as video.
So what?
But that's still a lot. I mean, you're doing speech recognition, for example, on a node, and you're trying to get some data from another node for whatever purpose, for something that needs to be shared or training purpose or analytics or whatever. That's going to be a lot of data.
That is correct. So because it's a lot of data, it makes much more sense to keep the data where it is originated, then starting to move the data and get only the data that you need. So per query, so you've got you have two ways to deal with it. Let's move all the data, the petabytes of data to the cloud and host it in one place versus I'm getting a query. Let's figure out where the relevant data resides, push the query to those edge nodes and process the query right there at the edge and just return the result, which is what I think companies are trying to do today. They're trying to move processing to the edge, so we just enable that.
Okay. But at some point, there still needs to be a physical transfer. Like, let's just take a simple conferencing application and say you wanted to do that between very private, right? Nothing goes to the cloud, no identifying personal or background information, and you want to do that solely between a series of edge nodes. How do you address you're collecting data, individual speakers from different nodes, and then processing and supplying the final result back to all those nodes. That's still a lot of data.
It is a lot of data.
I don't see how you can just magically virtualize that. It's got at some point it has to move.
Okay, so first let's talk about the let's call it the place where we focusing, which is time series data. So
Okay.
time series data, let's talk an assembly line, and the query that I ran was saying, tell me what happened in the last day on those sensors and give me the min, max. So this is a query that, let's say we've got 1,000 nodes in our network. It's able to identify that only 50 nodes or 10 nodes have this relevant data, push the query there, and then the results are coming back. So that's not a huge amount of data.
That's not a huge amount, right?
And so that's very efficient, and that's a lot of use cases.
Sure.
We could always find cases where it would be less efficient and you need to do specific things. So I'm not saying I'm solving all the problems in the world.
Well, no, I'm just trying to, yeah, that's good.
So we need to, what I'm saying, if you would want to know things, we would direct you to the node where the relevant data resides and facilitate the processing there. If you're asking me, are there use cases where we need to bring the data, do things differently? Yes. It's like a database, right? If you work with Oracle, you've got indexes, and if your query are following the structure of the indexes, they're very efficient. But obviously, you could have a query that would require a full table scan, and you don't want to do it. So you'll have to optimize it. Either create an index that would. It's exactly the same thing. So I'm not saying every query in the world will do it, but what I'm saying, and by the way, one thing that I can say, which is relevant, my previous company, I was a founder of a database company called ScaleDB. ScaleDB merged into OSIsoft. I don't know if you're familiar with OSIsoft.
Not familiar.
Yeah,
I read the bio.
Yeah, they used to be, because they were just acquired by Aviva a few months ago, but they used to be the biggest provider for backend software for IoT. Chevron, Boeing, they're all their customers. But anyways, they were interested in ScaleDB because they looked at a problem in a city with 1 million sensors, electricity sensors that generated information every 15 seconds and couldn't find a cost-effective way to deal with the data. Obviously, you could throw it to a mainframe or something, but it's just a lot of data. And the use cases are, I want to know where is the peak, what is going on. I'm not saying that we would solve all the queries, but the core of the queries that companies, industrial, smart cities are dealing with, this could be addressed in the way that I showed.
Sorry to disturb you. It's time for the next.
Sure. So thanks a lot, and I'll be happy to continue the discussion offline.
Yeah, that's the whole purpose. We meet in person, no better. And
Is there an email that we? Sure, or the cardboard.
yeah, so thank you.
The old way. Yeah, thanks.
Our,
Yeah, the old way.
our next speaker is Shah Rahman from Meta Connectivity, and he just got back from Barcelona from Mobile World Congress. So thank you for agreeing. Maybe you're still like have jet lag, but talking about the metaverse ready networks and recap from Mobile World Congress. And you're joining from Zoom, right? If
Yeah,
you can start
I'll be presenting
sharing.
from,
Yeah.
and I can start presenting.
Yeah.
All right, let's see how it works. I will be. Hi, everybody. I am very glad to be here to the Akraino group at the Edge. And today I'll be talking a little bit about the metaverse. That something that we started talking about a lot over the last few months. Last week at the Mobile World Congress, and I hope you find the talk useful. And feel free to ask any questions. Again, we do have time at the end for more Q&A, but if there's something that you'd like to interrupt, please feel free. So quickly about myself, I'm part of a group called Connectivity. I support the software engineering team there. And my team is focusing on pretty much the heart of the next generation internet, Web3 and metaverse, and what do we need to do.
Check the audio. Can people hear clearly from the audio online?
Yes,
Yes,
Tina.
Oh, okay, good. Okay, go ahead.
I can go. Or
You want to switch?
closer?
Oh, this will,
Yeah,
this
they
as far as
can-
it goes. So.
Yeah,
Okay.
Yeah.
Yeah. I can speak a little louder.
yeah, this is, okay.
I'm sorry, it might have gone a little random. So with that, let me get started. If you're okay, I'll just feel a little comfortable with standing up and then just a little eyesight. So let me start off with just a quick recap. Most of you know about Facebook, and we're basically being rebranded to Meta last October, about 6 months back. It's a family of products that from Facebook, Instagram, and they help connect over 2.5 billion people in the world, by far the largest communication services and platform on the planet. And I think that as we go into the metaverse, I think would be really interesting to see that how we saw the evolution since the company was established in 2004. Like early days, people used to share the information using text, like go and post something, mostly like, okay, oh, Santa's so cool, as an example. Then came the time over the last decade, a lot of photo sharing and sharing things that are happening in your events, in your family, with each other, or like distant, people are living in different parts of the world, and so on. Last couple of years and off late, videos, short form videos, all kinds of video sharing is now becoming very common and popular. That's what we expect over the next few years. And then as we kind of get to this is what we believe is the next evolution of like things that are a lot more immersive, things that are a lot more, should give you the feeling of like people who are present here and not present here. I mean, today we're doing this through Zoom. This is my usual favorite example. And it just the number of boxes that just, it just grows and grows and caps at 1,000. I've seen a meme that float around with tiny boxes with 1,000. Our goal is to try and see whether we can make that like one space, right? We can all feel each other, those who are on the call, those who are here physically present. And that's what we kind of expecting it to be. Okay. So with that, let's see what metaverse is. A little bit of video. I'm going to try and avoid like too many flashes and marketing. It is a technical crowd. I do understand that, and I'm going to go right into that in the most of the conversation. But this is where the setting the context is really important for this, because some of these experiences that you see here and we're building, it's because there's sometimes it's I would say metaverse people often equate to the gaming, right? You know, kind of say, okay, this is something that's a lot of virtual reality, gamers out there doing this, what's in it for other people, what are the other use cases? And I was just looking at, the previous, you're presenting, there's a vast array of different use cases for Edge. We're going to connect right to the Edge. Why I'm here and why I'm kind of like want to talk to you guys is that there's a lot going on here behind the scene. And from a use case perspective, education, event, sports, fitness and health and fitness, right? So there is just a wide variety of different use cases that are metaverse would actually enable per se. And quickly, some of the things that we're doing at Meta, and then we can connect to the network and info side of things. On the left-hand side, you have the Horizon Worlds, which is more of a virtual, I would say, space or world building exercise. So in other words, you can kind of recreate this space with the blocks and building blocks inside a virtual space, and you can then kind of bring in other people and interact with your neighbors, your friends, and so on. That's Horizon Worlds. Raven Stories, that was released last year. It's a smart glass. It's not an AR glass, but you can do things like taking photos, taking videos, taking phone calls, listening to audios, all kinds of stuff. And it's the exact same form factor as a Ray-Ban sunglass. I think that's the interesting part here. Like, it doesn't require any extra goggles, something sticking out. Can't even feel it's anything different than a regular sunglass here. Avatars is a super important part of the metaverse, because if you need a digital representation of ourselves, not something digital, something 3D, these are 3D stylized photorealistic avatars that we're building, and it's 1 quintillion. I think I've been reminded 18 zeros after 1 is a number of combinations that's getting built just of Meta, and I can only imagine other metaverse players like doing something similar. But this is what's going to represent us in the digital world. Then we got Oculus, that's the VR side of things. Obviously, this is what's already Quest, and you can, like, as a head-mounted display, you can have a full experience of the virtual space, virtual world, right from the Oculus. These are some of the things that we're doing at Meta to enable the path towards metaverse. Okay. And this is sort of like another one of my favorite ones. No music, and just you saw that Saturn. Now this is the full version of that. And imagine what would it be in future. I mean, I reflect back to my childhood, where like it was all about books. Read a lot of books, thick books, and I think much of the world is still running in that way, right? I showed it to my kids, and they were like, "Okay, I get it. I read about the Saturn, the ring around Saturn, but I didn't know they were made of ice, right?" So this really connected, interactive, immersive, and pretty amazing way to learn about things. And as human beings, those things really stick. My kids saw this and they're like, I immediately get it, right? I didn't need like pages and pages of description about Saturn. So this is the future of education and as we see the things. Okay, that's sort of like the first part of it, just to kind of share like what metaverse is and our view of the world of the metaverse. Now we kind of go into like, what exactly is the metaverse for networks? And this is something that we're looking at as a company very, very closely. Because today, we don't believe the networks that are out there is actually capable of delivering those kind of experiences. And there's a number of different reasons for that, right? And the industry will face challenge. If you just we're looking at today's video calling, there's a one direction latency of 150 milliseconds, right? And you can deliver that at roughly 5 to 10 Mbps and you're good, right? Tomorrow, if you want to do the cloud VR, the sort of one of the metaverse experiences, that will require less than 30 milliseconds of latency. And this would be end-to-end from UE to wherever your cloud GPU is sitting at 25 megabits per second. If you do this math, you'll very quickly realize that there's like small portion of the networks in the entire planet that can actually deliver that. Very small. So it's not 5G, not Wi-Fi. Yeah.
Is this application latency or just network layer?
This is end-to-end latency. It does not include the application. Mostly the network latency here, because it says UE to the cloud GPU. So it's not counting the UE process side processing or the GPU side processing. Right? But this is kind of like why kind of I'm here, and just like many of our colleagues are out there talking to everyone in the industry, and you guys are kind of the experts in some of the areas. You come from different companies, right? I've been in the industry for a long time before joining Meta, so I can totally connect to that. And this is the part we're trying to preach. First part was the application. This part is the network. And our vision of the world is that application and network need to come together a lot more closely to be able to deliver this sort of high bar that we're looking at. And I think in the next step, that when we look at like the entire spectrum of the user network, RAN, communication service providers network, and the services cloud, this is where Meta is operating, other metaverse players are operating, and various like different use cases that are out there. Even if you think about like non-metaverse use cases are running on the service cloud. It requires breaking it down. I think it's right now one of the things that are very challenging is that things getting optimized here, optimized here, optimized here, optimized here, right? Very segmented. But there is not a end-to-end sort of like view to say, when we say QoE here, what does it mean as QoS here? What does it mean as an SLA here? And those mappings are a little, I would say, not ad hoc, but they're a little not so harmonized, if you will. I think that's probably the right way to put this. So, and therefore, what we see is a world where like, really better connectivity is going to be a key to build connections across these different worlds. And this world is now like, so far we built networks that helped like the physical network connect with each other. Now we're talking about physical world getting augmented with another like layer of the world. And then that's getting, on top of that, you got a virtual reality that's kind of running, right? And so a couple of key technologies is 5G, Wi-Fi 6E7 are going to be very important on the access side. And then we kind of think about like our network of the future vision, that how do we see the network to actually shape up? One of the things we're saying is that we're getting to a point where, like on the cellular side, for example, it's been generational, right? 3G, 4G, 5G. We understand that many people in the industry are already talking about 6G, but we're taking a vision that maybe 5G should be the last G. There's no more G after this. And it becomes very continuous evolution, right? You just keep adding the newer things and stop that radio backward incompatibility that really gave rise to the Gs per se. When we think about the 3GPP releases, they're actually pretty continuous, right? They're coming out, and then we kind of cut somewhere and say, okay, here's kind of a G. Maybe we don't need any more Gs from this point. Maybe we just go and kind of go in a continuous evolution of that. Wi-Fi, I would say, generation has not played that big of a role. It really denotes the different frequencies, if you will. 3, 4, 5, 6, 7 is like a continuous evolution already. So we see that's one of the things that we're looking at. Then there's a number of other things that are super important, where a lot of the workloads are moving to the cloud. That needs to happen. One of the things that's relevant for this group is that many network services are moving closer to the user, right? We need to be able to find places to run some of the workloads right at sometimes user premise, right at the provider premise, sometimes at the service provider, the meta, we call it the meta edge, but it's just an application service provider's edge, right? So it needs to happen in this way. So we're looking at architectures that would actually help us run our applications or devices and then sort of offload certain workload in a very transparent way, right? So it should know what it's actually running. It basically starts up and then after that finds the right place, or it's more of like a split compute, if you will. We're kind of going into that kind of paradigm per se. There's also a number of other things, spectrum, innovations are around the corner. This network slicing is going to play a role. There is so many other features that we see, but our vision of the future is that maybe there is no more G. We just continuously evolve at this point.
So just a quick question. So you talked about the wireless access. So you have Wi-Fi 6E and 7. 7's, you said, is evolution, but this is basically the 6E or 6 or 7 and 5G advanced have the same timeline. So why don't you have 5G advanced? Or because
I mean, this, like I was just describing, that if it's the last.
but why don't you cut off Wi-Fi 6? I mean, that's inconsistent to
Okay,
me.
just to be clear, this is not meant to be like prescriptive,
All right.
it's more like
That's too
representative. to
nitpicky
say,
is what you're saying.
yeah.
Okay, then that part is, that's fine. So why don't you have fiber or sort of the expansion of the distribution network as part of, because that's a bigger or as big a hindrance and a capital outlay for the telco providers as the 5G radios are, at least for the big three in the US. And globally, it's probably gonna be even worse because you got to get rid of
Yeah.
all the copper is gonna have to go away.
So it is, to be frank, there's a little bit of org mapping here, just because my group works on the first mile and the middle mile is represented here. But there is an entire spectrum of things that happen from the backhaul backward, from fiber perspective, from network, infra perspective, that's not represented. This is not complete, and this is not a full representation either. It is just a.
So does your group have representative, like even like say at co-chair level and 3GPP and ETSI-BEC, and are you guys
usually
members? Because you're gonna have to do some convincing. You tell these guys we're not gonna do releases anymore. We're just, continuous, right? Continuous standard.
No, just to be clear, standards are already continuous. Standards
Yeah, I
are
know.
coming out every 2 years,
I know.
very nicely. At some point, the G's become a little bit of
I know.
marketing term.
But
No,
when
why
you
don't
go into
cut-
that 3GPP meeting and say, this is the last G, I want to be there.
I'm not actually, I'm okay with that.
I want to hear the
6G is gonna be sort of minor evolution, probably with a lot more hype. That's probably what it's gonna be, kind of like 5G, the big hype already is, as Ike's already said several times today, that I keep on hyping it up. But I'm just trying to figure out, so as a sidebar, on the telco industry right now, right? So I'm trying to figure out how the community would be incented to do this when Facebook generally, or Meta doesn't generally put money into the pockets directly into the
We don't
people
put
that are
money
investing
into
in
the
the
pockets.
networks. What's that?
We don't put money into the pockets?
Of the networks that are spending the billions of dollars, the hundreds of billions of dollars in capital in the US alone to build these networks. I'm trying to figure out how we get from where we are today to your vision. And part of it's maybe based on timeline. If it's a 50-year timeline, then we get there. Which I don't think it is.
Probably not work with the.
I understand.
timeline. So probably more like 5 to 10 years.
Yeah, I get that. So
Yeah.
yeah.
So that's a great point. I think I understand now what you mean. I mean, look, at the end of the day, the telcos are building out the networks, and they're the ones, it's kind of like their bread and butter. Metas happens to be one of the application service providers they cater for. Now, having said that, if you look around the world, the level of investment we've made for the subsea cables to connect Africa, to connect APAC, mini, LATAM, and so on, it's pretty extensive. And those are a little bit no man's land.
Yeah.
That's where we come into picture to kind of help. On the telco front, on the other hand, this is what we did at MWC. And if you just hold on to your thought for a couple of minutes, you'll see how we're actually working with the telcos, what we launched with them. This is a way to basically say, there's this notion that, we're becoming the dumb pipes, right? I went to many meetings and there's this common theme there, right?
Yeah.
We want to help them not to become the dumb pipes. There are probably ways, right? And it was good to see that Metaverse was seen as potential, killer app, that so-called killer app, right? To actually be one of the ways for them to monetize. I think to your point, now, like ton of investments have been going in and continuing to pour into 5G deployments, right? Now there's this big question: how would you monetize 5G? Like that's, and I don't think that outside of China people really found any use case, to be frank. And China found it because there were a lot of industries getting connected. That's what 5G was.
You're absolutely
Yeah,
right.
yesterday-
There's not a week that goes by people aren't discussing, what is the big use case? What's the killer
There
app?
we go. There we go.
It happened in Akraino meetings, it comes up all the time.
Yeah, so
This is what
when
we want-
Unicom presented yesterday night about the mine in the place, Pang, that place.
Sure.
Yeah.
I think the industry, mining, all of those places.
But those are
these
not
use cases.
killer
They're not
apps. Those are very,
utilities, right?
very niche use cases that
Yeah.
don't drive investments for 1 billion people. Or
Right, see, this is a thing, I think it's an important thing to.
it's a cool
realize in
use
your
case.
calling is
I'd
like
like
a
to work on it.
niche, yeah, it's a niche use case when you look at it from most of the developer perspective, right? When you look at China, that's actually different because there are factories everywhere and they need those to be connected. It becomes a mainstream use case and it makes sense if you think about it, right? There's a reason why China has way more connections in 5G than anywhere else in the world. Okay,
Well, they
so
have
just kind of leaving that aside,
Okay.
coming back to this point about, those are very good points, by the way. And I just wanted to highlight that from here, how we're sort of looking the way, and this is the important part. We're trying to get a shared network readiness vision, right? I don't think that anyone, like the entire industry or our partners always agree that what exactly that shared readiness is like. I mean, am I ready? Am I not ready? That's where the metaverse ready networks notion is coming in. Because from our perspective, we're looking at it globally. We can say it's a fraction of the networks are actually ready, right? So that's sort of like the first step. Then we look at something, we find a new approach to measurements and metrics, specifically QA and SLO, that should actually give an end-to-end view. Today, if you look at the network, RAN team has his own view, core team has his own view, edge teams are coming up, edge teams are not non-existent right now, they're coming up, they're gonna have probably their own view.
Yeah.
The transport team has his own view. Suddenly, this is so siloed. From the application standpoint, we have no way to kind of stitch them together in a realistic way to kind of say, this is what the quality of experience is going to look like. This is what the service level objective is going to look like. And it's probably where LFH and Akraino has a role to play. Maybe from the edge side, you guys try and figure out, what the right metrics are, and then make those all exposed to the standardized APIs. Other parts of the network can pull and push and stitch them together, right? That's something to think about there. And then finally, the network innovation in the ecosystem. This is super, super important because there's just a ton of things that would need to happen there. And let me just walk through a little bit so we can talk about a little bit more of that. So what are we doing for the network readiness vision? We're kicking off a bunch of immersive use case trials because today what's happening is that it's very much in bits and pieces. There isn't focused immersive trials that are going on that can say, okay, we can understand this part of the network is ready, this part of the network is not, right? So that's sort of like something we're kicking off. We're also contributing to this, the use cases and network readiness methodologies of telecom infra project that, that's something that Meta has been supporting and as a founding member. Now it's kind of became a pretty viable and industry movement. So we're kind of like trying to see how we can get this to be standardized. Because this is not something 3GPP, ITF, IEEE, any of them would do because they're very like the upstream on the standard side. There's a lot more on the downstream and practical network side of things, right?
We talk about the integration with TIP this morning.
Okay.
For the private 5G LTE blueprint.
Oh, okay, very nice. Yeah, that's something I've been tracking for a while. In fact, private networks, decentralized networks are going to become first-class citizens in the next iteration. It's not going to be just about operator networks and home networks, right? So, and so again, going back to that point about the metrics and the measurements are really important so that we can understand. And we hosted what we call a birds of a feather, like an industry-wide discussion there. So I'm just recapping. This is something was Microsoft, Telefonica, Vodafone. So this is what I was getting to your point, so that we can work with these operators, like Microsoft being, they're working on the enterprise metaverse. We want to really see how that plays out, right? Telefonica, Vodafone are two of the largest operators in the Europe, actually, on the planet. So they were also present with us to try and define this new approach to QE and SLA, the measurements and metrics in an attractive way, so that they can understand this better. Because today their view is like, we don't understand what the application is looking for. Our viewpoint is like, we don't know what the network's giving us, right? This application network, they need to come a lot closer together. And edge is one place where there's probably the lines are going to blur, right? Going to blur even more. And then finally, on the network innovation front, we have launched a connectivity accelerator, which is roughly a 12-week coupon program for connectivity startups. So if there are startups in this cohort that you want to take advantage of that, this is going to provide our ability to help with the trials, help with looking at the business plan, some of the technology vetting, and so on. So it's a nice program that's getting launched. And finally, there are some partner-led innovation hubs that are getting created around the globe. We announced one with Telefonica, Wira, in I think it's Madrid. They're doing in Spain, and there are going to be other ones coming up. So we're gonna be supporting them, supporting those as well. I think I'm pretty much at the end of my presentation, which basically I think is just a bit of a call to action that we're kind of the ecosystem that includes the RAN, core, edge, will play a huge role to make metaverse happen. And the reality is that the current networks, a very large majority of that are not ready for what we're looking for, but the best of our assessment. Therefore, we just call to action is to really come build with us. We want to work where many of us are on the bit of a, call it a bit of a roadshow to get people see what we're doing, what our vision is, and where potentially the gaps and learnings could be, and how do we sort of like work with you all to try and build specifically on the edge side, because I think edge is going to play a very big role. We do have to move a lot of the computes to the edge, to the closer to the user. I think that's beyond question at this point.
So can I,
I'll stop there.
let me ask you an unfair question.
No problem.
Well,
Fair or
maybe it's
unfair?
fair, I don't know. I'll preface this by saying I worked on this problem 4 or 5 years ago, maybe more, and it was extremely difficult then, and it still seems difficult now. Do you think either the metaverses of the world or your end users are willing to pay for QoS over a generally operated, multi-customer network? Because that's part of the monetization, right? So,
yeah.
And so what I worked on API gateways many years before it was a 3GPP thing. We actually launched the product, and it's very difficult to get people to understand the value enough for them to jump in.
Okay.
Except for advertisers, which you guys are sort of advertisers. It was kind of a weird thing, but that wasn't who we were targeting. Any event, do you understand the question?
Very, very well.
Okay.
And this is a quite widely discussed topic.
Good.
Different groups. So let me share my, at this point, weekly held opinion. Because it's
You
not
said weekly held?
Weekly held
got it.
opinion.
Okay.
It is not fully
Yeah.
qualified or vetted. It's under discussion.
Yep.
So we believe that consumers are only willing to pay if there's enough value for that drives that, right?
Yeah.
And we haven't been able to find anything in the current paradigm what's available, whether it's video calling or anything else that they'll be willing to pay for, right? Now, going into metaverse and the kinds of experiences that you will be able to get from the network, this all you can need data, that notion that we live in today, are probably gonna not come to an end, I would say, but it's more like it'll be challenged. Because networks are probably going to cost more money, going back to an earlier point. And in order for you to make money and monetize, you're going to have to go back to a little bit of the tiering, per se. And that tiering will help you monetize if you are guaranteeing certain network performance, certain QoE and SLO. This is one of the reasons why we're trying to unify this, so that you have to go to the user to be able to say that you can get 10 users or 10 people in your home. Who can constantly be experiencing metaverse without experiencing any downtime.
The problem with that is root metrics and other people also use that as a disadvantage and say this network sucks. Now Oleg has his hand up. I just noticed.
Are you helped by like what's happened, what we've seen happen during the pandemic, like Zoom's success? I mean, they obviously collected a lot of subscribers, even small companies like mine that wouldn't ordinarily have paid, right? Because they're forced into conducting these meetings and they want higher quality. They want to share lots of data and make a better impression. So maybe people either work from home, business, school, they might be willing to pay for a higher.
Very good. I think the pandemic has fundamentally changed the way we live, work, play, and learn.
So you see it as maybe getting,
it's certainly
I would debate
more attention.
Sure.
I would debate it because I don't think in general it works good enough. At whatever tier you're at. The question is the value to add $1 more, that quality worth it? If I asked you to pay $1 more and you get slightly better video quality or audio quality, you're like,
that's not going to be good enough.
Right?
It
has to be a step.
But connecting both of you, when I think about my home connection per se, right? When pandemic started, I had an ordinary Comcast, right?
Yeah.
With pandemic coming in, the company paid for Comcast business, right? So for a reason, we already paid from a $79.99 to $139, almost double. Why did I pay for it? I paid for it because my kids were going to school.
Yeah.
I was on the constant call and so on.
Yeah.
Now things have changed. I'm able to come here after 2 years. It's an event I'm attending after 2 years. Right?
You're not the only one.
And I'm sure many of you are on the same boat. But here's what I say fundamentally changed. I don't see myself going back to work 5 days a week anymore.
Yeah.
Right. That's fundamentally changed, right?
Yeah, or
There are
maybe
certain
snow
things-
days or whatever don't
There we go.
happen
Yeah.
anymore, right?
So when I'm at home, I want to make sure that I'm not missing out on any part of the meetings. And similarly, when my kids, they will go back to school. But there are certain classes they were doing before, they're actually going to start doing them online because we don't want to go the hassle of like 30-minute class and 30-minute drive or more, right? Rather just keep doing them, like piano lesson or so, just to give very concrete examples.
Yeah.
So we do believe some of the things have fundamentally changed.
Yeah.
And they will probably bring in the need to driven by business, education, or entertainment.
I think you just raise the bar, and then that'll be the general or standard.
That's exactly.
And
what
then
we
at
mean.
some
Yes.
point to go above that, you're not going to be
Yes.
willing to pay because.
So now imagine,
Yeah.
right, everybody getting Comcast business, just for
Yeah.
an argument's sake.
Yeah.
I think Comcast, like a lot of the CapEx problems are gonna just go away because suddenly they're literally doubling
could
the
be.
revenue, right?
It could
So
be.
that's kind of like how we're looking at it. And how do we get?
Except in my neighborhood, I can't get Comcast for business. I already tried. Anyways.
It was right.
Oh, Oleg.
Question from the bridge, yes. Yes, hi.
That's why you can't get it.
What's that?
They know you were previously.
I think there's-
Go ahead, Oleg.
Oh, yeah, sorry, what's Oleg?
Yes, hi. Thank you for the presentation. Very, very interesting. The question is regarding the infrastructure requirements. So you talked about the network, and it's sort of at a very high level. It is an expected type of requirement, right? It's just a matter of the magnitude of it, like how low the latency or minimum low latency should be, but it's just part of the issue, right? It's in order to build something like this, you'll need the infrastructure, right? So I was wondering what was Meta's kind of expectations on the infrastructure and distribution, especially where it relates to distribution of things like UPF and edge computing associated with.
Absolutely. Let me maybe share a little bit of our future network vision based on that, what I hinted earlier, that a continuous evolution of the infrastructure. So first and foremost, we see a tremendous use of open and open source technologies. Open RAN, open Wi-Fi, open core. Try to make things, I would say, better cost per bit, if you will, that will help drive the access side of the things, right? That's the number one. Then we have an evolving network architecture to start supporting private and decentralized networks more, which are a lot more distributed, a lot more, I would say, break out to the fiber or the fastest transit as fast as possible, right? And don't hop over the air or low latency network. So that's a fundamental shift in the network architecture that we're expecting. The third aspect is that moving a lot and more of the non-real-time network operations and other workloads to the cloud. So they should take more compute and more horsepower from the on-prem and the edge side of things, where we should run more real-time and more user planes. You talked about the UPF per se, right? So that they can be more useful towards the latency sensitive ones, right? And I think that's an important notion, that how do we kind of bring UPF and get them co-located with the edge, right? And then you kind of like have the access come to the edge as with the shortest route possible.
Mm-hmm.
That's sort of like the piece to help with the latency side of things. We also see the application of AI/ML for better management, operation, orchestration of the networks, and a lot of the challenges associated with the power management, mobility and handoff, energy, thermal, what have you. We believe there are a lot of AI/ML techniques that we can use that to help with this. And then last but not the least, many key features: spectrum innovation, support for network slicing, scalable low latency protocol like L4S is getting more and more attention from ITF, right? Improved quality of service, better congestion control, buffer, active queue management, remote rendering from the cloud and edge, right? And hopefully, the layer on top of all of that is a standardized way to measure the quality of experience and service level objectives I just shared for immersive experiences and the metaverse. So that are based on very canonical definition across the industry. This is a big challenge. We do not have that today. So these are sort of some of the things that we're looking at and our expectation from the network infrastructure perspective. And we expect to work with the ecosystem to gradually upgrade the networks to make them metaverse ready.
I was gonna, maybe I should be more precise in my question. So it absolutely makes sense what you described in the feature sets and the capabilities. However, what are the, for example, data center requirements? Does Meta believe in a extremely distributed, very small type of housing, so data centers for all of those capabilities? Or have you done any studies on, for example, finding a sweet spot where the more you distribute, obviously the more expensive it becomes, right? Because you need that compute and networking at every little location. Is there in your view, is there a metro level type of aggregation or sub metro that would hit the spot here for and meet the requirements?
Absolutely, that's a great question. I think you're being very specific from an edge perspective, or like really the infra, like the cloud, edge, and on-prem. I think we'll look at this from three, sort of like the major nodes. Now we have the entire team of people who are working on our own edge infrastructure. And then if you're, just for the records, we run the largest edge infra on the planet, right? I mean, where we pull more traffic to the edge than Akamai or anybody else for that matter.
Yeah, we believe you, yes.
Yeah, so the point is, we've been doing lots of analysis. We have something called Facebook Network Appliance and Facebook POPs. They are housed with the ISPs and the MNOs today, right? In a nice peering agreement. So whenever there is meta traffic, it's gonna break into our nodes. Now that's, to your point, and are like not at the metro level today, right? They're like at the region level. So, and we've done all the analysis to realize that latency sensitive applications like cloud gaming, cloud VR, and Horizon World, and sorry, not Verizon, Horizon World, and so on, they are going to have to be closer to the user. So one of the things we're looking at is latency distance metric, right? Roughly try and have a compute within 100 kilometers of every user, right? That's sort of like the kind of way that we're looking at it. We are pushing out from the edge, the cloud onward, right? Or data center onward, outward. And then we're also looking at things like putting like micro DCs right at the cell site, or right at home, right in the neighborhood, right? Which would be perhaps doing some selective offload and whatnot. So there is like lots of work going on. There's a big team that's actually working on this as we speak to figure this out. And we have a lot of company level directive to make sure that infrastructure is ready for the experiences that our colleagues are building and other teams.
Thank you very much. Thank you.
Does that answer your question?
Yes, I mean, this is very exciting. I happen to be from a company that provides this infrastructure today at the Metro. We're at Equinix, and we work in Akraino to really kind of understand all these dependencies and the distribution and how open source can help in anywhere from the functional level to the, what's on top is the orchestration, the more you distribute, the more you need to orchestrate, the more you need to bring things together, because it's so complex, nobody could do it manually. We'll need Meta for orchestrating the network.
Right, orchestration is going to be a very important part of this if you want to make the split compute truly work. I mean, today's age, if you think about it, it's not split compute, it's not to completion, right? That entire model, as it changes, orchestration is going to become very, very important. And I would love for LFH and the Akraino team to start thinking about that. How are we going to support the split compute model? And how do we transparently offer this to the devices to offload compute, offload storage, offload network functions, and stuff like that. So that's
you guys might possibly have a plan for an Akraino blueprint to get involved in something like that, like you talk about this offloading and micro DCs or.
Right, we've been involved in different blueprints so far. We would love for us to be involved in this part. I think we'll probably have more discussions offline to understand so that we can talk through like what are the requirements or what are we looking at and whether, because blueprints sometimes could be seen as like as a broadly applicable for many different use cases. This could be a bit of a special one for metaverse, for
Yeah.
example.
Yeah,
So
so
we
we
can kind of
already
see-
have the metaverse area. And I strongly recommend the meta connectivity step up to lead activities. We already have 2 blueprint families and 1 blueprint, like 5 to 6 blueprint already there, but we just need meta connectivity to paint the framework, just like that architecture. Painting as architecture rather than we are bringing the bricks there. And then
Got it. That's a good point. I'll have someone from my team to kind of follow up with you guys to see.
Yeah.
Sorry, you were trying to say something.
Yeah, I would say for now, there's a lot bugs around the metaverse. What exactly is metaverse? You touched some point here. The metaverse is basically sharing and brief silos. And that's very important because there's more fluid of information sharing across different kind of vertical area industry.
You just
and
hit the nail.
tenants.
Yes.
So that's what we enable everything become more like a true meta, right? So in that case, that comes to the case about the meta connectivity, and also down the road, you say try to build mini data centers. I would say this more than just Facebook to build those things. It's more like whole industry will build things, become the whole ecosystems. That will enable almost everything.
Absolutely. That's a very good point. You hit the nail there. It's all about sharing. It's about breaking silos. It's about making our world more interesting with people who are not with us, right? This is not about replacing the physical world. A lot of people are thinking, oh, metaverse suddenly takes over the physical universe. Not at all whatsoever.
So is
It's a way
metaverse,
to enhance our experiences, not to replace them.
is the metaverse going to replace Zoom and WebEx and all the other gazillion things and make a standardized approach to talking to one another, not face to face? Because that's without that, it seems like you're just going to create more silos.
More silos, yeah. I think metaverse, this is an important characteristic, like what we call like continuity and persistence. So we should be able to go from Roblox like world to the Horizon world to the Zoom world, right? But we need all of them to work together to make that happen, right? I don't think it'll be, I would be a little careful about using the terminology on replacement. There's nothing getting replaced here. It's more like they're coming together into a continuous experience. As a user, you may want to be on a Zoom call, and then seamlessly, the next call may not be on Zoom. It may be on WebEx. Today, you're gonna have to shut this down, go to WebEx and start that. What would it be if you could just say, okay, from the Zoom call, I have a WebEx call, boom, I just switch to the WebEx call, come back to the Zoom call. I'm describing a very specific possibility, but it's the continuity and then the persistence. It's the same person. You don't have to create another identity and basically another representation of yourself. Today, you have a separate representation with every ward or every conference that you go to, right? That's what we want to break down and try and get everything together in a unified way.
Yeah, exactly like Sean mentioned about here. But nowadays, you belong to those companies. Now you are not belong to you. In the future, in the metaverse, you belong to you. So all those things
That's exactly
will
what
serve you.
Yeah. So that's like your identity, your avatar that I was just showing. Your avatar, you said, this is my digital representation. You want Zoom to honor that and recognize you because that's the persistence part.
Yeah.
You're being persistent across all the different.
So you're not trying to solve the point where you could talk between WebEx and Zoom, for example,
Well,
or
in
a
a way
meta
you
switch
are.
from Facebook and a meta switch from Microsoft or whatever, not meta
Mesh.
switch, sorry, Mesh.
Microsoft Mesh.
Yeah.
You could be in Mesh, and then the next time you can basically say the same avatar, everything else you can be in the Horizon workroom.
Okay.
We are trying to solve that, but it's in a slightly different way. That needs a lot of openness and the interoperability per se, right? I know I'm out of time. I'll be just mindful about that. We're out of time.
Meta is taking that role. It's very important for person to the person, not belong to the asset of now those companies.
Yeah, exactly. And the unified identity authentication, a lot of work that are going on. Just because we change our name to Meta, it doesn't mean that we will. That's my last parting word to all of you. We want to work with all our friends, the industry, and try to build this together.
That's
right?
how we can talk.
I guess I'll take it as
For
literal.
the first point, we launched a Meta Connectivity Accelerator for startups. And in this room and on the call, yesterday, 1,000 participants yesterday night. We have at least more than 10 connectivity startups. And they are all interested on the meta connectivity.
Oh, that's great to hear.
Yeah, I
please,
think if you're leading the metaverse area in Akraino and also leverage this program, we will have a big success.
Sounds great. I will take that as an action for me. I will speak with someone at my team. We are spinning up, like I said, there's a large group working at Meta's edge infrastructure. Within connectivity, we're looking at how that infrastructure connects with rest of the edge infrastructure, right? So that's where we're looking at that closely. I'll have someone follow up. And we're excited by a lot of the work that you guys have been doing. Actually, internally, we're using some of the, the glossaries that you guys created, the terminologies. They were very useful. State of the edge report, that was useful. So just wanted to.
Yeah, these are all
point
the
out.
people, they are hands-on.
Yeah.
He built the API and he built the CI/CD. Everybody here is
Yeah.
just so great. So
That's-
you have
that's-
great people, that's your
Yeah.
great promise.
Yeah, exactly. That's awesome. We want to take it from the paper to the next level, like I say, try to get the API much more harmonized. And there's a lot of work to be done. I'm excited about the times ahead. Thanks, everybody. Thanks for the time and thanks for listening.
Send us your avatar.
Believe it or not, I actually don't have one.
Well, I see everybody's, Mark has one, right?
Yeah.
Yeah. Can I
I'm
have
still-
one? Yeah.
You can create an NFT for your meta.
Yeah, we should have the test cases for the blueprint stuff.
So that's
Yeah, lots of exciting things. It's NFTs, it's Web3. We're looking at, all the payments, like how that's gonna work.
Also, your avatar is going to be an NFT. So you can actually sell yourself at some point. If someone else wants it, or
I wouldn't go that far. I can get.
No, you want
that's what.
Thank you so much. Thank you for having me.
in that sense, I don't mind.
Yeah, I think our next speaker is Jane, VP of Mavenair, or
She just stepped out.
She has a meeting in the company. She's either switching the spot with Jeff. Let me see.
Okay.
My sincere apologies. It's a little cramped week. I would have stayed a little bit longer. I'm gonna get somewhere by 2.
And
Please,
you want to box some of them? We didn't touch
I'm good.
it.
I'm quite good. I have some plans.
Yeah.
Because of that, skipping lunch. Yeah. Thank you so much, everybody.
Thank you.
Jane wants to switch.
Switch
back.
with you.
Yeah.
Okay, good. Thank you.
Take care.
She seems to be stuck on the phone.
Yeah, so she had a meeting, she told me.
Yeah, okay.
Let's switch with Jeff, CEO
I need another cup of coffee.
Logic. Yeah. Oh, you send a message, you can just ask, right?
It's faster if I just go.
Or you send out a message in chat box.
Oh, yeah.
Yeah, next time if you're in the room, you can just ask.
Oh, yeah.
Yeah. So you want to use your microphone or this microphone?
This microphone.
Okay.
Yeah, I'm completely disconnected. I don't want any other feedback.
You're joining from the Zoom, right?
Yeah, I'm gonna share right now. My
Yeah.
screen sharing right now.
Yeah, be careful the coffee. Is that still coffee inside?
No, it's empty.
Okay, good.
I drank everything. It should update. I just changed to. Come on, do it. Update. Well, it's sharing the main one, but it's not sharing slideshow. Come on.
I can see from here.
Yeah,
But
but
it's not the.
yeah, when I click
how-
slideshow, it won't update. That's frustrating.
You want to send it to me or use mine?
No, I could probably just live with it like that, I guess. I don't know why it won't go to slideshow.
Then you upload.
Yeah, I
You
did, but this,
upload your slides, right?
Meta will fix this too.
yeah, it might.
Sure.
I just go with it, but like this, it's fine. Okay, let me get started then.
You guys haven't started yet. One quick note that we are hiring a lot of people. If any of you are, just want to plug that in, please don't forget. Reach out to us.
So sraman@meta.com, is that right?
No,
No?
Shah Raman,
Yeah?
my full name at fb.com. Haven't changed to meta.com yet.
Oh, fb.com?
Yeah.
Yeah.
Alrighty?
Yeah, my colleague is coming to see you, but you're leaving anyway, I'll tell him.
See, he's selling, I'm selling. That's a trade. Okay. So for everyone who's not live here who's listening virtually, I'm switching. This is Jeff Brower with Signal Logic. And so I'm switching time slots with Jane Shen from Mavenir because she seems to be stuck in a meeting. She's on the phone outside in the general area. So I'll go first and you go after me. Okay, so this presentation is about recent, actually it's been about a 2-year effort, product effort from Signal Logic, and it's relevant to what Akraino's been doing in edge computing. So although it's a product, there's a lot of key points or philosophy, whatever you kind of high level perspective that are, I think are relevant and pertinent to what's happening in the Akraino community. So I thought, I've been thinking about presenting for the last several months, and I thought maybe this was a good time to do it. So here's a content slide. I won't go through it right now, but the PDF is up on the event page, the wiki page. So if anybody wants to grab that, and you can go backwards and forwards and reference the contents at the same time I'm presenting, then feel free to download that PDF or bring it up on your screen. Okay, so to start out, edge computing is, at least from my perspective, is sort of starting to take shape. People have been talking about it for a few years now. It's been mostly, at least for a while, maybe since up till 2019 or 2020, kind of hypothetical. But now you start to see actual activity, and people, I think, are really getting serious about it. And I do believe the pandemic has accelerated what's happening in edge computing. And so I borrowed some pictures here from Oleg at Equinix. Thanks, Oleg. And I added some data flow arrows. So Oleg, of course, at Equinix, being data center experts, they can see clearly what's been happening in the edge computing infrastructure, in the physical environment. Of course, that means it's densifying and becoming decentralized from the cloud, which was also a major point mentioned by Moshe in his presentation just an hour and a half ago or so. But as this happens, of course, the need for in-node computation and data flow between nodes increases, maybe even more so than at a higher rate than the actual physical nodes themselves. So you get more nodes, you got to start moving a lot of data. So we have, sorry, I'm skipping around, I'm having trouble controlling it. So we have a number of existing problems. Obviously, I think everyone can agree, my language might be a little more harsh than cloud guys want to hear, but cloud computing was never designed for the edge. Cloud computing has always been about economy of scale, making computing cheaper for larger users, corporate users, analytics, and collecting data, especially with the advent of deep learning. Collecting data is a huge thing. And of course, as we all know, to a certain extent, we have to admit they're driven by advertising. So that means yet more data and oftentimes of a personal nature. It's also my belief, as being a programmer for many years now and programming a number of systems, that when you start to see what happens with all the microservices and all the applications in the cloud, you start to see, for lack of a better word, again, one of my harsher words is bloatware. You start to see people saying, well, let's put this together and we'll throw in an open source from here and we'll grab one from here. And before you know it, you have a huge footprint. You have something you can never possibly run in the cloud. You can't fit it in a small server, much less get efficient or real-time performance out of it. Now, a good thing is that latency continues to decrease, but there's still no guarantee of real time, which for certain applications is essential. And as you can see from my graphic there, you end up with a very long supply chain. I'm using that word H, supply chain, because that's been a topical subject lately. You end up with a long supply chain of zones and regions and services. So it's quite the distance from the edge to the cloud. And there's a lot of things in between those and a lot of things that can go wrong. Here's another slide that kind of indicates that. I'm using, for the purposes of this talk, wherever I say robotics, I might refer to a Roomba as being a kind of an example that people can relate to. Lots of people know about that, or there's lots of little videos going around showing people fighting, cats fighting with Roombas and so on. So people might be a little more familiar with that. So this particular example makes it clear, you want to talk to your Roomba, you want to tell it what to do, but you got to go grab your cell phone, you got to mess with the app. You might speak to it through your Alexa assistant, but in all cases, what's happening? You're going all the way to the cloud and back down to the Roomba again. Why are we doing that? Is that truly the future for robotics? I don't think so. So here's some of the needs that we see at SignalLogic. When you're thinking about robotics, when you're thinking about factory automation, you have to deal with the environment at the edge. And this is a real-time situation. You want to respond to voice commands. If you see something bad happening, a forklift is doing the wrong thing, you should be able to yell stop. And it should recognize that. It should be immediate. There should be enough sensors on that forklift that it's impossible for it to tip over. No matter what you do, either the person driving it or even if it's remotely controlled, it just can't happen. So these things are going to become prevalent in edge computing. And when you talk about dealing with the environment, you're talking about analog data, you're talking about sound, you're talking about video. That's a huge amount of data. And that's what drives the increase in node computing. You're going to have huge amounts of data. Moshe was talking about that, but he was talking about, of course, time series data, but not at the same level as, say, continuous speech, or much less continuous video. Then when you start talking about that type of data, you're talking about massive amounts. And if you want to stay in real time, there's absolutely no way you're going to be sending all of that up to the cloud and back down again to different nodes for processing. That's just not going to work. So we want to operate safely. As robotics and these automated equipment become more prevalent, there will be huge legal liabilities. You cannot hurt anyone. You can't damage anything. You can't run over the dog. You have to be super careful about it. And we're going to see the need to share this content with other nodes. Maybe one node has encountered something that's crucial for other nodes to know, and it needs to be distributed and communicated in as close to real time as possible. And that could be a lot of data. It could be saying, look, here's a video of something that happened here. You need this on a nearby node or related node, and take action on this. We've seen this. Maybe it's a security risk. This is what you're looking for. We might encode that video to make the transfer a little bit less onerous, but it's still going to be a lot of data between nodes. And of course, when you're talking about the edge, you're always worried about energy and size constraints. There's always the need to operate with less power consumption and in a smaller form factor. So here are some use cases. Now I'm putting these in here because these are either ongoing contracts or ongoing discussions that are happening with actual customers at SignalLogic right now. So we're in touch with people who want to add ASR to robots. I've already mentioned the factory example of a forklift type of situation. There's people who want to do add-on, like small server add-ons for cars. Yeah, they're not going to go, we're not talking about a Tesla where they're building it themselves. They have an existing vehicle, but they want to add something to it. They want to add something that does, for example, your own LiDAR. So maybe you find some way to make the car safer, a product that people can go buy in Costco. They spend $1,000 and they add it to an existing car, and they have automatic braking or something that makes their car safer or more automated in a certain way. And of course, something that we do that is, again, media-based is malware detection, but specifically for RTP media. So malware payloads can hide inside RTP packets, and you need to detect that as soon as possible. You don't want that to go all the way to the cloud before somebody figures out that something bad is happening. So these are all processing intensive, compute intensive use cases. So now we talk about, I think I've missed something here. Okay, no, I didn't. I'm sorry, came back. By the way, this picture is me kicking
That's really.
I did that too.
Well, have you guys ever been on a Zoom call and here comes the,
Yes,
here,
it's always switch.
and it's noisy, right? And
Yes,
you like to be, just
really
tell
loud.
it thing, hey, can you just go the other way for the time being, but you can't. And you're not about to drag out your cell phone and worry
Yeah.
about it. So I just give it a kick and spin it around and
My kids say, shut up, I remember.
yeah,
And
just
he didn't listen.
send it the other way, right? Okay, so I thought I missed it, but I guess I passed it by. So EdgeStream is SignalLogic's attempt to productize some of the work we've been doing over the last few years, some of the R&D and other related but not sort of integrated software efforts. We have done a lot of things for telecom, for media delivery, content delivery companies, law enforcement agencies. But now we've been thinking about integrating some of the things we've come up with and working on an edge computing platform. So that's what EdgeStream is all about. So one of the things that we're doing that's different, and I'll show you a little bit more specifically why it's different in a moment. But in order to be real time, you have to be extremely wary of what actually happens on the generic Linux platform. I know everyone likes to say, well, I'm going to run platform independent, any platform. Containers will abstract everything for me. But the bottom line is it's still going to end up running on a Linux somewhere. And you have to worry about Linux's architecture, their kind of centralized way of controlling all the cores. So what we are focused on is we have a workflow that's per core. It takes you all the way through from gathering data to inference at the end of it. And it's optimized, and we have no spin locks. So that's been a major help to us. It's helped us win some business, because what you'll find is people have other architectures, and as they start to add cores or start to add the workload, eventually there's contention. Some different tasks or different threads, even though they're supposed to be on paper linearly scalable because you've got this many cores, it ends up not being the case because somewhere somebody is locked waiting for somebody else. So that's an extremely difficult thing to do in software, but we think we're doing it. We have a real-time workflow. We start with packet processing that comes from our telecom background, codecs, signal processing, user-defined processing, and inference. And of course, we always keep hardware acceleration in mind as an option because that's the trend in edge node computing is people making both x86, ARM, FPGA-based solutions that have some type of acceleration for depending on what the application is. So the workflow that we have here is, of course, you see over here on the left, your user devices connected to small servers. You have packet buffers, for example, a camera might be encoding its video as H.264, H.265 packet stream. So that has to be decoded when it reaches the edge node server. So we have extensive packet processing. We're able to deal with a lot of packet loss, a lot of out of order packets. We have decoders. We have what we call pre and post signal processing both. So then you end up eventually with raw data where you're doing that type of signal processing. We have user-defined insertion points for user-defined signal processing. And finally, you have your inference to get some usable result out in terms of computer vision, say, or speech recognition. So here's a comparison with something you guys may have heard of. NVIDIA has a deep stream framework that they put out, and it does many of the same things that EdgeStream does, except I've highlighted a few differences here. EdgeStream provides a intense sort of level of packet processing, and that again comes from our experience with a number of telecom customers over the years. If you somehow are missing packets, if you're not correctly handling packet out of order, if there's any issues with RFCs, eventually you're going to feed that inference engine with some substandard, which is a no-no, given that it's training. And then sometimes we see clients or customers say, well, don't worry about that. I'm just going to train it with all those errors. I'm going to add this noise. I'm going to add this packet losses noise. our experience is that's not a good idea. You end up overtraining, and yeah, maybe you can handle that if you're in the cloud. You just add more layers, and you do a little bit less optimization, and you just keep feeding it more and more data and constantly training in the background. But again, that's not going to work at the edge. You start doing that kind of thing at the edge, and you've lost the. You then start needing way more compute and storage and all the things that you have in the cloud that you're not going to have at the edge. So the quality of the actual input, whether it be audio or video or some other type of data, is crucial. So we have a lot of emphasis on packet processing and signal processing. Edge stream includes encoders as well as decoders. Deep stream is mainly a decoding framework. And again, we have a lot of places where you can insert user-defined or application-defined processing. We also have a comparison with GStreamer that's been around for a long time. GStreamer is open source. It's very flexible and widely used. The issue there is, going back to one of my starting points, GStreamer's thread architecture is a thread slicing. So on paper, that's good. You can have a wide number of cores, threads, and just arbitrarily assign them. You can see here in the diagram I pulled from a GStreamer example. One thread is handling sources, another thread is handling some queuing. But as you start to add up real-time processing, as you start to increase the compute workload, if you want to add ASR to that, you want to do it on, say, an Atom, an x86 Atom CPU with a couple of cores, and you want each core to be, say, handling one ASR, full ASR stream in real time. Even the contention between those two cores, if you run GStreamer, will bite you on an Atom. It's just not fast enough to do that. So you have to think in terms of, what are my Linux constraints? What's my real-time factor? What CPU am I eventually going to run on, even though I am containerized? And you have to worry about contention between those threads. So thread slicing is got this issue of thread contention, which is it's difficult to overcome.
Is there any cache coherence that are considered while doing the thread pool?
Well, at that level, at the CPU level, if you're talking about CPU level cache coherence, then we completely count on Linux to handle that. But we're not at the device driver level, at the application level, anything above Linux or above the container, if that's your perspective, or within the container, we're not using spin locks. So we're not forcing any thread to wait on anything that thread is. Yes, we do not want, as long as that thread has been allocated to one workflow inside EdgeStream, then the assumption is nothing else is going to interfere with that. Now, Linux might need to do some housekeeping or something, and that's always a problem. So sometimes we like to tell people, if you have a third core, you have a dual core processor, but you might need one more core to let Linux do its thing. That's a good idea. But again, these are things that we've learned the hard way through the school of experience. Even though you're containerized, you're not going to get away from that. And it doesn't matter whether you're on x86 or ARM. These same issues arise over and over again. Okay, so this is not fantasyware. We're deployed. I give some examples here. Most of these are telecom and law enforcement agency, but we are, like I said, having some discussions with people who want to do, are doing robotics and computer vision.
Jeff, question.
Yeah.
I'm Steve, by the way. Nice to meet you all. For those I haven't met, work alongside Tina at ARM.
Okay.
Responsible for the Africa and South
Oh,
America.
Steve, right.
Yes.
You and I have been exchanging emails.
Yes, yes, yes.
Nice
Very
to meet you, Steve.
Very nice to meet you.
Yes.
My question is on the deployments in relation to automotive. I saw you mentioned a use case for automotive retrofits. How mature is that? And
it's not very mature.
Okay.
There's one startup who's approached us about this idea of building, very small servers that would actually become a product.
Okay.
And it's not Tesla, it's not GM. I mean, it's like a company that's saying, I want to make an add-on and I'm going to sell this, and it's going to go into, people can use this in their cars.
Yeah, so we should, I mean, as part of the many things we have to talk about, I think that part will be necessary. ARM is, we have a lab now in the automotive headquarters of Africa, so the Detroit of Africa, as it were. And as ARM, of course, our forward-looking technology for software-defined vehicles, it's sensor-based, it's, it's forward-looking. But there's also a need for us to support the ecosystem with technologies like this that have representation within what's more backward-looking, right? Because, as you said, the retrofits for edge may not exist with the forward-looking, it may exist with the backward-looking.
Right.
And so there are quite a number of use cases for V2X, for telematics, for location-based systems, for which our lab will be serving as a touch point for quite a number of those developments.
Okay.
So I'll be glad to chat more with you about that.
Yeah, that sounds good. That sounds very good. Okay, I think I'm almost done. I wanted to point out we have a GitHub page and a Docker Hub page, and there are ready to run containers up there on Docker Hub right now. There are RAR packages on GitHub for people who want to install on their own hardware as opposed to running a container. And those include demos, reference apps. And the GitHub page has by now it's dozens of example command lines on how to do one thing or another. And there's some mention here about the source code. Mainly that's there is to highlight the effort that's gone into it and the relatively high level of security. We can't license things to law enforcement agencies that have any dependency on third-party libraries that weren't developed in the US. So we're able to tell them we developed everything in the US, and not only that, we don't have any third-party libraries. So that makes it straightforward for them to evaluate our solution. So because we have that history in telecom and law enforcement, that's how we've ended up in that position. So that's it. Ask me anything, and I put the EdgeStream webpage link up there if anyone's interested.
Cool. We have 1 minute for Q&A.
1 minute for Q&A.
Because you switch with
Oh, so I was supposed to have a 30-minute.
Yeah, you have 30 minutes.
Okay.
We already talked this 30
No, I didn't, guys. I started 5 minutes late because we were looking for you.
Oh, your time is late. Okay, fine.
That's okay. That's okay. I don't see like a whole piling up of questions. So.
Yeah, here you go. Marsha has questions.
Yeah, so you're positioned like NVIDIA, but faster, more, easily deployed on every hardware.
Right, exactly. x86 and ARM. So the emphasis would be more that we're a more general purpose CPU, but amenable to hardware acceleration. Whereas NVIDIA's emphasis might be more, you're going to use a Jetson or something for inference, and then we'll then in turn accelerate that.
Yeah, so because we were talking to NVIDIA, and I think there is a very strong synergy between what we're doing and what you're doing.
Yeah, it could be.
We're servicing the data. We don't do the inference side. We don't.
Yeah, well, you made
the AI processing
in different way. You made it basically very similar points to what I was making. Like when you say move the computation close to the data. I mean, that's a well-established computer science paradigm, right? I mean, that's been there since the 80s. But somehow the cloud keeps stretching that. I keep thinking, didn't they figure this out? Isn't that like neural networks? We had those in the 80s, and it turned out they worked. Mm-hmm. So moving the computation close to the data makes a lot of sense. And I firmly believe that it will continue to happen.
Because I now understand where your question about the voice and because we make this data available at the edge to an edge node, right, and then the inference, the logic.
Yeah, your effort seems more about management and this concept of virtualizing. Some storage is here, some compute is here, but you don't care too much, right? You're going to choose those. Our effort is more about how do you get that optimized high performance at the edge. It's not easy. I mean, you see all this marketing talk about containerization, and people like to say things like software only solution, and they like to talk about serverless. And I'm listening to these marketing terms, and I'm thinking, guys, there's a chip under there. I don't care what you do, you can run any container you want. Eventually, you're going to encounter the limitations, the physical reality of running on that CPU. And if your software is not cognizant of that, if you haven't paid attention to what's actually going to happen, whether it be security, performance, or some other low-level issue, then you won't run very well on the edge. Because immediately you'll be looking at like 250 watts and 2 cores or 4 cores or something, and that's not going to be anything like the cloud.
Yeah, that's why the software developers that made the hardware at the end of the day.
Yeah. So.
Yeah, we could take it offline, but
Right.
there is an interesting thing, a synergy here.
The emerging markets are ready for you. That's all I can tell you. Between Africa and South America, you have the right type of test beds.
Yeah.
A lot of the technology you're talking about. So,
well, oftentimes it's been my experience that those emerging markets will leapfrog. They'll jump ahead because they don't have the time to be building up a lot of infrastructure and going through all the, you know, what was it that Shah Rahman was talking about? We're going to cut the G off. We're not going to have any more G's, right? So, and you know, he wants to accelerate too. He has a different reason, but
I mean, that's the thing. All are welcome because you find that it's such a vast amount of opportunity that you still have the folks bringing in undersea fiber. You still have the T1 lines. You still have the satellite folks, millimeter microwave. The backhaul is as large as it could be, right?
Right.
And then you have broadband and mobile. And so what you find is that solutions like this get more inland, you know, talk to the endpoints better.
Yeah.
Do a lot of the compute function at the endpoint.
Right.
And just make
if that solves the problem,
and
it gets you there faster, then why not, right?
Absolutely.
Any other questions?
No, let me stop sharing.
Well, thank you for Jeff actually had a lot of contribution and leading many efforts, activities in Akraino, same as down. They flew from Texas, and yes, yeah, for people in the Bay Area, if you think you need to drive for 40 minutes, I was joking with Stephen. I said, as a Jeff came from Texas. Okay, so our next speaker is Jane, VP of Technology Strategy from Mavenir. She's going to talk about the update for Mac and ORAN because I didn't receive the Converged Edge is the official title.
Yeah. So I think I have 15 minutes. I'll try to go through my deck. So I think Converged Edge is a topic I would say surfaced more recently in the sense of the deployment of open ORAN based RAN system. So this talk is about this Converged Edge solution. So with the Open RAN architecture, in the middle, this is the Open RAN ORAN logic architecture. So basically, ORAN opens up the key RAN components into the RU, DU, CU components. And also there is a orchestration plus the radio intelligence controller portion highlighted here with the red dotted line. So with the ORAN architecture, the RAN implementation now is disaggregated with the open specification, and the implementation itself is employing distributed architecture. It's built on COTS hardware. There are lots of hardware solutions, like say Intel-based FlexRAN, or now it's in the news that Marvell, Qualcomm, NVIDIA, all are potential suppliers of the RAN COTS hardware. And then on the right-hand side, you can see the RAN intelligent controller, the RIC, and the corresponding X app, which is a application built on top of the RIC platform. So these things can all be combined, implemented into one solution on top of a unified platform, virtualized or containerized platform. So we call this a new deployment or new solution is a RAN edge. And this is a marriage only possible under the Open RAN. Because in the old days, if you look at the RAN, it's a black box. If you want to input, if you want to combine any application computing into that black box, it's impossible. Now with Open RAN, this is becoming a reality. And the first application we see for such RAN edge is actually the network optimization related. It can be AI-driven network applications. So I listed a few here. It can be the customer-facing applications, it can be vertical applications, and it can be the network applications. Network applications focus include the network optimization itself, the QoS controls, and the network observation automation. So these are the typical three categories of the RAN edge would have some advantage. Now, talking specifically the RAN edge benefits. So it obviously, now we're moving computing further down to the RAN edge. In some cases, it's called far edge. This is where we talk about it, sometimes it down under the cell tower. So I think the previous talk from Meta, you mentioned, you keep pushing the latency to the lowest possible. I think the RAN far edge is the furthest. Also because of the virtualization technology, and especially the containerized platform, allows such implementation possible. And this gives several use cases like self-driving cars, mobile gaming, and dense IoT deployment. And I think this page pretty much just talk about why Open RAN is a must in order to have this RAN edge. I think I actually explained in the first slide. It basically, when you use the Open RAN, there's no RAN locking, and you have the Intel, at least for the time being, you have massive Intel support on the platform side, and you have increased choice of various vendors and innovation designs in DU, CU, MEC, and all those. And specifically, if we look at the RAN edge evolution, so first we reach Open RAN, so we open up the RAN, and then we implement the RAN with the cloud native technology. And then on top of that, the ORAN specify this new real-time RIC. And then with all these steps, we finally can reach a converged core edge. And in this, this is a diagram of a virtualized RAN infrastructure for the RAN edge. So you can see this is actually a combined the RAN CU-DU plus the UPF and the MEC platform and the 5G core connectivity proxy and MEC app all in the same edge node. So this is is the the typical RAN edge deployment, and then we will continue to add the RIC components to this. This is what we have now in some of the far edge case, especially if for the NPN, the non-public network case. You will see this kind of deployment very common. So basically, you have one server. It has an accelerated card for DU, and then the remaining host computing power will be used for CU and UPF and MEC.
Is this an ORAN reference or is this a Mavenir reference design?
This one?
Yeah.
This
The
is
the whole thing, because you have a.
this is a
embedded-
Mavenir.
okay.
Yeah. But actually, the ORAN part here emphasize on the, you include the CUDU part into this node.
Right,
And
okay.
the DU actually needs to have an accelerator card.
I was hoping this was ORAN, because several years I was trying to get the ORAN working group, what is it, 10, which doesn't exist, to include the core. Which is what you had on the previous slide as a timeline past, because I think the core tightly integrated with the CU.
Yeah.
Good optimism. We talked about this before.
Yeah, that's actually what's happening
Okay.
for our NPN deployment enterprise.
Yeah, because you don't need an
Enterprise
N3
IT.
interface, at least not an external one.
So when
Right.
you,
But you would need an N4 optimization.
so when you say accelerator card, and you mentioned like Marvell, and I think you said Qualcomm. So these guys are all
Intel.
ORAN.
Right now, it's
members?
Intel. Right now, it's
Yeah.
mostly
Most, but they're-
production level.
Okay, but
offering
but
is
they're,
Intel.
they're ORAN members, so they're kind of.
Oh yeah,
they're
they're all
pushing this-
ORAN
pushing this along,
members.
right?
Yes, they're all ORAN members.
Hi, Jane. Is this a product?
Yeah, it's a because Mavenir actually have two major categories of customers. One is the operator side, the other is the enterprise. So enterprise, so we have this more deployed already. So it's basically combined the RAN server and the core server. For smaller deployment, I think one server is enough. And of course, if you think of redundancy, there could be a couple more. And the applications for enterprise NPN network is more geared towards some of the enterprise applications. Now, similar thing in the operators customer front, the focus are mostly on the network AI part, basically optimize the network itself in terms of the edge applications.
So Jane, to the right of the UPF, is that an N6 interface or is that a control plane interface or something new?
Can you make it bigger?
You mean UPF to MEC platform?
To the right of the UPF.
To the right, correct.
Where?
It's
Like-
an N6. It should be.
Where the two boxes that say,
This
all
one?
three
Yeah,
boxes
is that
say net.
N6? Is that like is that just another IP interface or is that a control plane or a new interface that I'm not, just trying to understand what that represents?
Yeah, it's not labeled
No, this is another N6 actually,
N6.
Yeah.
Separate from the one below or are they actually the same?
separate
Separate
from,
N6
yeah, because this is local, or in some cases, I mean, this is a very simplified diagram. In some cases, it is a local breakout, just some of the traffic go to the MEC side, and then the remaining traffic will go to the DN at the lower side here.
Local breakout. Okay.
So just a couple more questions, if you don't mind, Jane.
Mhm.
On the UE side, so it's not showing the RRH or radio unit.
Oh yeah, radio, I didn't show. I just.
I understand, but do you
Who needs that red anyway?
Yeah, the RAN's on.
do you
Oh, like, don't find them, they're.
There was serverless. We had servers,
Yes,
now we have
there's
radios.
supposed to be a UE.
It's okay. It's okay. We understand. I mean, my question really is: if you worked with or Mavenir have worked, do you provide those radio units, or do you work with other companies to interrupt?
Yeah, I think the O-RAN ecosystem is a massive. When you talk about RU, we actually do all what you just mentioned. So we work with third-party RUs. We have our own RUs. We also sometimes work with the operators appointed legacy or not legacy the RUs. So.
Okay. Thank you. And then same question for the core, like the SMF. Can it be? Is it Mavenir's SMF, or does it interrupt with others?
Oh, okay. So everything on this box, on this diagram, except for UE, actually we even cover some of the application on UE. Everything on this diagram, Mavenir can provide. However, we can also interrupt with others.
Okay.
Especially on the core. I think
Even
out
the
of
SMF to UPF interworking, because there's a lot of gaps in the standard for actually making a useful UPF if you have a third-party SMF.
I think right now interact within among the network functions within the core. It's not like a randomly you can randomly interact with any. We've seen deployments. We provide even in the O-RAN side. Theoretically you can do CU and somebody else do DU, but in reality you do all one vendor. Core is similar. However, I think the core started to have some separation, especially on the user data management part. Yeah, so that part can come from a different vendor.
Right.
Did I answer your question, Oleg?
Thank you, Jane. Yes.
Mm-hmm.
Since you're gave me the floor, I have another one.
Okay.
Sorry. So the Mac interfaces, are those compliant with ETSIMAC, or these are just framework? Like do you actually? Yeah.
We do support the Mac framework. However, I think we're not religious about it.
Okay.
Yeah, because honestly, I think for the Mac application, what matters more to them is the network exposure rather than the underlying infrastructure platform. So that is something we noticed. And also for operator case, the network AI type of application, we don't actually go by the Mac platform. However, it is a edge application.
Thank you.
Yeah, I only have 15 minutes, so I'll continue. So this is actually what happened is the E2E private networks. So I just highlight, at the edge compute part, we've seen more noticeably the CU, RIC, MAC, and core network functions are all combined in one or two servers. So this is just the highlight of the stacks there. And yeah, this is an interesting picture. So just to show you guys the potential of this RAN edge. So the red box is the O-RAN, and then the blue box is blue box is a picture of a traditional RAN. Both are at the cell site at the foot of the cell tower. So you can see for O-RAN deployment, at the bottom of the cell tower, you only need a rack. And this is actually a full 42 U rack. In some cases, it can be a smaller rack. By the way, these pictures are taken from the dish deployment because Mavenir is the O-RAN CUDU supplier to dish. And right-hand side, you can see this is actually a AT&T traditional. So in the past, it does have, it needs a room. Of course, I mean, the room probably is not full, right? It's
full. It doesn't look as cool as the one on the left. But
yeah, I know.
sure.
But the visual, there's another picture. I mean, the visual impact is even bigger. Like the O-RAN deployment, you have a small box just hanging on the fence of that under the cell tower, and then the other side is that this time is the Verizon. Verizon has a small cabin there to host everything. So the size, right? And then
with a bunk bed.
and then another thing is to say, look at this rack, right? This is a 42U. This hosts the DU there, and in some cases RU hosted here, and there are lots of room for future expansion. So all the stuff we talk about, the RIC, MAC, UPF, you know, you name it, there are lots of slots available.
So these deployments, are they for the equivalent capacity in terms of number of sectors and traffic?
Yeah, it's I think it's in Las Vegas site.
So this rack will handle the same as the CRAN, you know, enclosure here.
Yeah, and as I said, that they probably yeah.
And to be, not that I'm defending AT&T, but normally there's battery banks in there for backup for 8 to 12 hours of power.
That needs a lot of battery.
It'll be a lot of batteries, a lot of lead acid batteries.
Yeah.
Again, not to defend.
I understand, and I'm the one who is saying probably the cabin is not, you know, filled with
I still think the one on the left
everything.
is cooler. I'm not saying it's.
Yeah.
That's a good point, though.
I do think this is because I think Light Reading and the Fierce Wireless, they have very recent a couple of weeks ago articles talking about this. They have more pictures because I believe Dish just had a drive test.
Yeah.
I think 2 weeks ago in Las Vegas to test their RAN network.
They're only a year behind schedule, I think.
Well,
No,
6
not quite a
months.
year.
6
Yeah,
months. 6 months.
Well, they're-
Yeah, they're getting there.
You're getting there is always
Yeah.
good.
They'll be okay.
Okay, so last page. So Mavenir is I think as of now is the biggest promoter for O-RAN as the ISV. We had the actual real world deployment with the O-RAN component on public cloud for the operator, the Dish networks. And we have the unified cloud native platform where we can host any of our network functions on the same platform. And this platform actually is portable to be deployed either private cloud CAS or public cloud like AWS EKS and moving forward to Google Anthos. So this is the strength and advantage of Mavenir's unified container platform support. So here the quote is from the Dish EVP Stephen. I think he mentioned something in the FCC Open RAN solution showcase held last July. So all the O-RAN vendors actually will give some talk presentations and defend or provide their input on the O-RAN their opinion on ORAN. And I found what he said is very interesting. He basically said people are always talking about what's the use case for the edge. And from the operator's point of view, our network is the use case for that. And we, as the vendor, we echo what he says. So that's my short talk. I think yeah, for me, I joined Mavenir close to a year now. It is a company spearheading in moving the telco mobile network workload from RAN to core to IMS messaging product to public clouds. We're the one of the biggest telco ISV partner in AWS. And for ORAN, I think we're pretty much the biggest promoter for ORAN. You probably can see lots of our publications on the ORAN front. All right, so that was a little bit of marketing for Mavenir.
You're getting better at it.
Cool.
All right.
Thank you, I appreciate. So our next speaker is Akraino-san from Fujitsu. Should I say Ohio?
Hello.
Is in the morning in the Ohio?
Can you hear me?
Ohio.
Oh, good morning. Okay, let me share with my screen. Can you see my screen?
Yes, I can.
Okay. Hello, my name is Haris Sofkano from Fujitsu, and I'm TSC member of Akraino from the 2021. Today, I'd like to introduce two blueprints, which Fujitsu ready to progress and target to release on Akraino release 6 for the next release. In the first 50 minutes, I explain about the CPS, robot blueprint family, and its QA. In the next 50 minutes, I will explain about the smart data transaction for CPS and its QA. So let me start with introduction to CPS robot blueprint family. First, I'd like to explain about the reason why we focus on robotics. We believe that robotics can contribute to achieve SDGs. For example, robotics can release the people from simple tasks, and people can focus on the decent work and more innovative work. As a result, we achieve the economic growth. In this slide, I show how to contribute to SDGs. The first, we will build the robot platform, which suit SDGs number 9, industry, innovation, and infrastructure, and also apply to robotics various industry, and it will have the positive feedback to the another SDGs goal. For example, if robotics can improve productivity of agriculture, as well achieve the, for example, zero hunger, and so on. So, however, there are several fields where current robotics are difficult to apply. And from in this slide, I'd like to explain about there are fields where current robotics are difficult to apply. For example, the food service industry, agriculture. There are common challenges in these fields. The object which controlled by the robot with diverse shape, flexibility, and frictional properties. And also around the robot environment is uncertain. Current robot, for example, in the car factory, car manufacturing control the car as an object, and the car is the uniform size, and the production line is the constant circumstance. On the other hand, please try to imagine the farm like this agriculture industry, the crops as the object controlled by the robot have a diverse shape and diverse size individually. And also in the ground is the uneven. The weather will change its frictionalities. So circumstance around the robot is uncertain. And also high mix small lot productions. For example, please try to imagine when we order sandwich in the subway, the order depends on the people. Nothing is the same. So in this slide, I'd like to explain SACS as the solution for that challenges. There are two major points in their approach, sensor-rich software and effector system, SACS. One is enhancement of cognitive ability. SACS use sensor-rich technology for multi-dimensional data acquisition and use AI IoT technology with force contact information to control robot. And also they use the IoT maintenance and the inspection technology. The other point is the new mechanical. They developed the flexible hand by polymer materials using advanced 3D printing technology to make complicated form for grabbing the various objects. This slide shows that the SACS is one of the theme of the SIP. SIP means Japan Cross Ministerial Strategic Innovation Promotion Program. So there is several themes in the SIP. For example, the personal mobility, also labor robotics, IoT platform, and also the basic technique about the ultra low power edge processor, energy harvesting, and also state-of-the-art sensor. The Ritsumeikan University leads the SACS in this project. So there is a SACS use case and the demo. So for example, how to serve the food in the plate, like first they grab the dishes. And next, they change the hand and also wash the hand. And then grab the food and serve on the plate. And also there is several use case, for example, remove dish from the restaurant table on the dishwashers in the restaurant. Oh, go on. So and in this slide, I'd like to explain about our blueprint family overview. We like to provide an open software stack based on the SSES to apply the robotics to any industry easily. And the figure shows the architecture and also the blueprint relationship. So we have proposed this blueprint CBS robot blueprint family and robot basic architecture based on the SSES on the January 6th. So, and we have approved. So there are the several blueprint and also blueprint candidate. The first, we have the approved robot basic architecture based on the SSES as a basic architecture covers the SSES. And also there is a several blueprint candidate. For example, how to teach the robot and how to maintenance robot and also how to control the multi-robot in the co-working. Then we will propose them as a new blueprint in the future. And let me explain about the current our robot blueprint status. So we are under testing for Akraino release 6, our robot basic architecture based on the SSES blueprint. So in now all documents are available on the wiki page, architecture document and also installation document, test document. This figure shows the detail of the architectures. That we have we have the component in the each hardware to control robotics. So let me explain about the robot basic architecture based on the SSES blueprint activities in the next year, 2022. So we'd like to enhance the current blueprint functionality. For example, autonomous optimization of the robot control. So robots have a PID control, for example. The PID control have the parameter. So I like to optimize these parameters by using the AI and the database. First, we store the data measured by the robot and also the multi-sensor module, which called the pre-MSM. In this, there is some information about from the MSM and or robot. For example, the robot control result, which is the fail to grab or success to grab the object, or how long time to control the object, and also the contact pressure information from the multi-sensor module, and go to send to and store in the database, and also analyze data in the cloud for better parameter for the PID control, and also the feedback to the parameters. So we will add the AI and the database components to the current blueprint for the autonomous optimization in the 2022. So as a conclusion, we will release the robot basic architecture based on the SSES blueprint Sorry. Can you hear me?
Yeah, we can. Keep, why don't you finish up?
Sorry, but my battery dropped.
Oh, that's what we guessed. Yeah. So you want, I think you're on your summary slide. So if you, can you just talk through your summary and.
So let me. Okay.
About like 5 minutes.
Yeah.
For the information.
Okay.
So I will just, at least have a.
Guys, we have to go. Evidently, they have someone that's using this room at 3 o'clock.
Oh,
Yeah, that's the.
I guess we're gonna have to.
Unplugging it.
Yeah. Tina can hopefully tell Akano-san what.
He's on the phone. He's on the phone right now. So
Oh,
you
is
know
he?
to tell him. Or I guess he's done.
Yeah.
Yeah.
Is he? Oh, it's on.
Okay. Well, we're in progress.
So unfortunately, we're losing a room in 1 minute. So Kana-san, sorry, but I think we'll have to end right here.
We can temporarily set up on a table.
Oh,
We
keep
have
on
the
going?
tables until 3, but nobody is using those. So she'll let us do that.
Okay, well, then keep on going and you could, we're gonna transfer out of the room, but the Zoom will be up.
Yeah, that would work.
Everybody can hear me.
Tina.
Tina is outside. She is.
Oh, really? This is Ino from the Elfit's board. So I think the some of the organization is not perfect. So we have been waiting for long. So please tell Tina to have the better organization facilitation. Did you hear me?
Yep.
Yes.
You see what I mean? Hello?
I think because the reserved room is.
Understood. However, it's already 1.5 hours was pushed out. And then suddenly the presentation was stopped. It is not really fair. Okay?
Oh, no, we are not stopped.
We're not stopping. We just moved to a different location. It'll resume in 2 minutes.
Oh, really? Okay, I see. I thought that it was stopped.
Oh, no, it's not stopped. It's just, we're
Okay.
just moving from the meeting room to the general area.
Okay.
Yeah. I'm sorry, who said stuff? Maybe that was my.
The misunderstanding.
Oh. Okay, sorry about that, Ino-san. That was my alarm for me to eat my snack. You know, I'm in a diet. I eat every 2.5 hours. It wasn't a alarm for you. Sorry about that. I was talking to Wenjing.
Don't forget.
See.
Oh yeah, this is mine. Yeah. Okay.
You go. That's got the laptop. Go ahead.
Yeah.
Keep going.
Right, it's just the HANA House people. They probably have the other group using the meeting room. We already reserved both the meeting room and the general area. We reserve tables there.
You need to throw the rest of this away, right?
Yeah, or you can to go. I mean, box home.
Well, I'm not bringing on the
Inosa? Yeah, we move to the reserve table now. I can turn on the camera so you can see me and the team. Can you hear me?
Yeah, I can hear you.
Okay, let me turn on my camera. Yeah, it's Wenjing was talking to me outside, so I didn't know what's going on in the meeting room. Sorry about that. Can you see me now? See.
Okay, Tina. Okay, thank you.
Yeah, sorry about
Probably better that you better move the room and before the podcast start and so that.
No. You probably gotta get into panic. Like, why are people moving?
All right. Oh, okay. I see. Okay, and maybe I misunderstood what you were saying. So, but anyway.
No, it's just the lady from this facility. She wanted to kick us to the general reserve table rather than the meeting room. Yeah. Now we are all here.
Okay,
then you
thank
can continue. So is it you finished the presentation or is it a Q&A session now?
No, I'm done.
Oh, no. I mean,
sorry, I my PC laptop was dropped, so let me explain about that conclusion about. So we will release the robotics basic architecture based on SSES blueprint in the next Akraino release, and also we will enhance robot basic architecture based on the SSES blueprint functionality for the next release, and also we will propose blueprint based on the SSES in the CPS robot blueprint families as another blueprint. Robot teaching or robot IoT maintenance, calibrations, for example, multi-robot co-working. Okay. So about the CPS robot blueprint family introduction, that's all. So if you have any question or comment.
Yeah, very good. Thank you very much. I think this blueprint family has already set up examples for the other blueprints in Akraino. You really follow the process very well. Communication for the documentation subcommittee, process subcommittee, and technical community subcommittee very well. And I reviewed the documentation. I really appreciate you check every single requirements of the release 6 very well. I think Jeff, you had questions about the robotics before. You also mentioned robotics in your presentation.
Well, actually, yeah. Okada-san, this is Jeff.
Yeah.
I'll send you some. I actually have a kind of a major question. I'll send you by email. I want to ask you about joining your blueprint family, but I'll email you the particulars on that.
Yeah, that
Okay.
means yeah, because some of the time I always join the blueprint meetings. Sometimes they speak Japanese. So once Jeff join, yeah, you have to switch it to English.
No, that's okay.
Jeff and me.
That's okay. I know a tiny bit of Japanese.
Oh,
from
really?
Many years ago, yeah.
Okay.
It's okay. But the reason is, I noticed you guys are using these small server, like these Atom, very small nano server, you call it. And I'm wondering if at some point you guys want to add the ASR, the automatic speech recognition, to your robot.
In your presentation, there is a Lumba, right?
Yeah, so that I'll email you, but that's basically my question. If you guys are interested in adding the ASR capability to your robot, then we would like to participate in your blueprint.
Yeah. I think this is a good sign because having a blueprint in the community means you can attract the more developers, more companies and partners to work together for the same use cases. If you're open to attract the more partners to work at the same blueprint.
Mhm. So actually, this is from the Fujitsu. Actually, it's good idea that because we think the multiple sensors, the multiple devices, how to easily and quickly to add to the library in the part of the service. That is our issue we are currently thinking. So having more devices with the new library to be added as the option, that it's really good. The good, how to say it, challenges that we can try in this family. So this is really welcome, and thank you for your offer. So please talk with Fukano more about that. Thank you.
Yeah, sorry, we were muted. Can you repeat?
Oh, yeah. Thank you, Hatsumi-san.
Okay. Thank you, Jeff-san. Let's start discussions with the blueprint, in the blueprint.
All right, so just explain to them, we are still on. When you have any questions for release 6, you have the new blueprint. So I think this blueprint for the robotics blueprint family has already set a very good example. If you look at their documentations and the CI/CD process, I think if they are just freshly learned and they can be your new teacher, I mean, yeah. So for your new blueprint, I think now it's March and our target date is April 30th. You still have some time. They also made it in a very short time period. Yeah. Okay. You have any questions for the robotics team?
I actually had one question.
This is the Mausha.
So, yeah, I was curious if you could talk a little bit about, you said you're going to add databases. What type of data do you collect, and what is your thoughts about managing the data and the data collection and the databases to use?
Okay. Current considerations, we will correct the data which related to the robot control. For example, the contact information, how do I say, the hand grab the object and the hand detect how to flexible and how to pressures from the sensors. And also, we will control the robot. And for example, the can you see my screen?
I can, yes.
Okay. And also there is an object and the grab by the robotics hand, and also move to the another place. And then, for example, these control result. For example, they fail to move to the another place. For example, they drop the object, or how long does it take? Very, very slow or fast is a robot control result. And also the which data used to control the robot. And the set of these data we store in the database. About what kind of database now we are discussing, and we are not we have not decided which database or not. So if you have any database knowledge, so your advice is welcome about the database.
No, actually I do, but I'm looking at your diagram. It looks like the database is in the cloud. So you push the data to the cloud and then run the query again where the robot is? Or you plan to put the the database at the edge. See, according to your diagram, it's a robot works. He pushes data to the cloud, and then when he wants to know something, he pulls the data from the cloud. So that looks like a long round trip, which has.
Yeah. But this long round trip is not the real-time feedback. For the real-time feedback is the red line. For example, the robot in the robot control, there is a major control by the PID control. PID control have real-time data and also the parameters, which is always same value is the parameters. So long run trip is used to feedback to the parameter data, which is not real-time feedback.
Sure. I see. So yeah, so I would love to talk to you about that. So I'll ask Tina for your email, and then we could take it offline. But I think there is an interesting discussion here.
It's amazing.
Yeah, I will send our email to Fukano-san, Ino-san, and Moshe to connect you guys.
Great.
Okay.
Yes, I will post it to wiki page. And tell me which one you want to beautify. I'll beautify before I post it.
Fukano-san, this is Jeff. You know, you say one of your great advantages is relieving people of this routine, repetitive work. You should also say you reduce inflation. Yes, because then we won't have this labor shortage.
Oh, at least in the US.
Yeah, at least in the US. But I think they might have the same problem.
Not quite, yeah. We've had that for a while.
That's funny. Yeah.
Okay, sure. And
Okay.
this is everybody here. I hope you can see. So tomorrow at California time, 7 a.m., we have a Vincent, the father of the internet.
One of the fathers.
One of the fathers of the internet, no mothers.
Yes.
Happens to be true.
Questionable. You wonder what internet it is.
We'll give a talk about
No wonder it's such a big mess.
security alligator of the internet. And then we have the TSC member sharing. I hope Kano-san and the TSC members just show up, tell us who you are, where are you from, where are you going. And then we still have a lot of talk from Verizon, Nokia, from Equinix, many companies very pioneer in this edge computing area. I know it's probably late for our colleagues in Japan and China, but 7 a.m. is just our normal TSC time. Maybe you can attend the first hour. And I really appreciate today we have the hybrid mode again. We have so many talks. Everybody here talk except Dao have already asked a lot of good questions. Very good questions. I just said you should talk. Yeah, I think we had a great meeting again. We have a lot of people on the Zoom and back go in and out, have the online on-site meeting. Every chair was, a person was sitting on a chair. We have a very crowded room here. Probably next time we should find a place that has a bigger room.
I think at one point the room had 14 people.
Oh,
14 or 15 people.
Yeah.
So we really did use the room.
Yeah. So Shah was sitting outside. Because he feels like it's too crowded. He wanted to wear the mask. He was sitting there for an hour, he told me. So I came out to drag him inside. Yeah. Cool. All right. Any other business final mark anybody want to give? And I really think you
Will be.
Sorry, Tina, about the smart data transaction.
What did you say? Okay. Yeah.
So very, very quick.
Is that Japanese?
Not that well.
Yeah, not this one.
So is Sukano-san trying to do another presentation?
Yeah.
Oh, another presentation. Oh, sorry.
Yeah.
I thought we are done with the presentation. Okay, go ahead.
Sorry,
Sorry.
very quick.
Okay, go ahead.
Yeah.
Sorry, my bad.
Very quick. So
Thank you.
yeah.
Thank you.
can you see my screen?
Yes.
But, yeah, in this slide, we will introduction about the smart data transaction for CPS blueprint. So we agree with the Akraino concept, and we will contribute based on our IoT edge social implementation
I just
achievement.
wanted to see people here.
So we have several social issues to contribute to the social issues. For example, the monitoring sewage water level to avoid the urban disaster by the heavy rain, and also the monitoring frost farm for the tea plantation, and also monitoring about of the feed tank for the livestock, and also in the nature product bird song detection, and also in the farm individual identification of the cattle by image recognitions, and also batch recognition barcode and the QR code. So we have studied smart data transaction for CPS blueprint based on challenges and solution from these social implementations. In this slide, I explain about the motivation for the smart data transaction for CPS blueprint. So there was a challenges in the social implementations. For example, the bandwidth of the sensor network and depends on the use case. There is several network kind of, and in this map the bandwidth and also range. And also big data from the many sensor node will pressure the network bandwidth between the edge and the cloud. So we need to have the means to optimize each network bandwidth according to the use case. This blueprint proposes a solution for the network bandwidth optimizations. So this is our architecture overview solution for the network bandwidth optimization. So there is 2 points. The one is increase the type of the sensor network supported by the Akraino. For example, the LPWA, LoRa. So we can meet the various demands about the sensor networks and the distance and the power consumption, which comes from the various use case. And also there is a data synchronization. We can share the process data between the edge node. And as a result, we can reduce the network bandwidth between the edge and cloud and the processing latency. So there is several use case in this slide. The first use case is the monitoring sewage water level. In this use case, to monitor as water level and predict the urban disaster by the heavy rain, and also they send sensing data to the edge node via the LoRa interface. So we can increase type of the sensor network supported by the Akraino. By this blueprint, we can support various IoT edge use case. In this use case, which is difficult to supply power to the sensor because there is a sensor on the manhole, and there is a lot of the manhole in the city. So, and also use case which covers the wide area, for example, agriculture. And also there is interactive live sports and music. This use case is under consideration, so I just explained about the concept. Without the data synchronization in such virtual space live sports music, so they send movie to the crowd, and also crowd generates the virtual space from each user or each athlete musicians from data. So there is a pressure network bandwidth between the edge and the clouds. So after we add the data synchronization between the edge node, we can synchronize the data between the edge node of neighbors. So some edge nodes generates the parts of the purchase space and send the generated purchase space to the cloud. So we can reduce the network bandwidth, edge node and the cloud. This is a concept about the use case. So the current this is the current status of the smart data transaction for CPS blueprint. So we have the pass all test, and now we are reviewing by the documentation subcommittees for the Akraino release 6. And all documents are available on the wiki page, architecture document, installation document, so test document. So if you have any, if you know the more detail about that, please go to our wiki page. So as a conclusion, we will release this blueprint in the Akraino release 6. And also now we are discussing about the enhanced functionality for the Akraino release 7. For example, the support synchronizing, streaming data such as a camera. So if you have any interested in this blueprint, so please welcome to the participant. Okay, about the introduction about to the smart data transaction is that's all. Do you have any question and comment?
Yeah, this one is Colin is the PTR, that one, right?
Yeah, yeah.
Which one is the university participating? This one or the previous one?
The previous one, robot blueprint is have a university, Ritsumeikan University.
Yeah, why are these two blueprints separated and not in the same family?
This is a difficult question about.
Yeah, I can see the difference. I'm just curious to know. I can see this one can be standalone and serve not only for the robotics.
Yeah. So I separate the blueprint.
Yeah,
and we can. I think we can use this blueprint in the robotics and also another fields.
Yeah. Oh. Right. Any questions? I think this one is a standalone. Well, this one comes first, and then that one. And I think I attend several times of their meetings. I like their documentation and the way how they architecture this. Any questions, comments from the audience? Yeah, I think this one is pretty clear for us. Yeah.
Okay, thank you for your time.
Yeah, sorry, I misunderstood. Because I was away talking to Wenjing, and because anyway, something happened on site, and yeah, I thought you presented all of that. I think this is really great, and so I think you have already for both blueprints, you went through the documentation subcommittee review, right?
Yeah.
And then I think for the APIs, you've done the APIs. You work with API subcommittee already since Jeff is here.
About APIs subcommittees, I think there are no new API. So
so no APIs
for
this release for both blueprints, right?
Yeah.
Okay, got it. Yeah, and then we only need to see the CD log.
Yeah, CD log and also security log, right?
Yeah, I mean the CD log has to pass the security scanning, and I think Wenhui is the security subcommittee co-chair. Any comments, or did they already?
One comment.
Yes.
Kana-san, this is Jeff.
Yeah.
Can you send an email to me that says no new APIs, and then when I receive that, I can update the tables.
Okay. I understand.
Thank you.
Probably need the log from the call.
Can you hear one quick?
I will type it down. Could I type it down in chat? Oh yeah. So we probably like need the 4 logs, especially from Blueval scanning, just to make sure like there's no issues with the code like that will bring some vulnerabilities in it. Yeah.
You mean that are there any trouble in the Blueval?
Not in the Blueval, but using the Blueval to scan the code, which is like in this blueprint, proposing in this blueprint.
Yeah. But Blueval, we have done the Blueval, and yeah, we have verse. How do I pronounce and security checked in with the verse. Yeah, we have done.
Yeah. So just send the logs to the security list.
Yeah.
They will review it. Go from there.
Yeah, we will send the log file to the security
Thanks a lot for your help.
Yeah. Okay, thank you for your help.
I think there were like 5 notes. Yes, the YouTube is live streaming. Maybe you can check, or I can check with Kendall. Kendall, you still here?
Yeah, I'm here.
The question asked. Oh, okay. Can you remove Innocent's comment about the facilitation?
Well, if it's, I would have to I might be able to actually. Once the live stream ends, I think I can take that piece out.
Yeah.
Thank you. Yeah. That is not related with actually that's the topics itself, and some of the misunderstanding happened on the online and offline. So I'm not happy to have that comment in the distribution. So.
Can you send me an email with the comment that you want removed, just so I know what part to remove?
This was the one that between the room changes.
Around 3:30. Around 3:30.
Around 3:30.
Actually, 3 o'clock, 3 p.m. 3 p.m. we switching from the room to the reserve table.
So we thought the meeting was stopped.
Okay. Oh, okay. I know exactly where you're. Okay.
Yeah, it was stopped, and then actually you just moved the room, but we thought the meeting was stopped, and I showed some of the frustration, and then that was not good to distribute to the outside. So that's what I thought.
Yeah, no problem. Once this wraps up and we end the live streaming, I can hopefully go ahead and edit, which I should be able to because YouTube lets you edit videos. So.
Thank you very much. Yeah. This was kind of due to some of the miscommunication on.
Yes,
so
no problem.
Thank you.
Okay, really appreciate everybody's effort. You see these 2 gentlemen, they're happily discussing still. We're going on, but we'll close the online and we'll see everybody tomorrow 7 a.m. Any other final remarks?